I want to talk about some recent creative ideas I've had. We're going to go over a van, camper, uh, tent thing, source setup. We're going to go over a new TV slash monitor, utilizing different ways of making light that are a little bit old and new, and talk about a way of making a possible way of maybe gaining energy from quantum foam. Okay, and then talk about this thermite reaction that I think might work. I don't know much about chemistry, but it's a different type of thermite type of thing. And then a really cool, this is actually not a thrust style nozzle for like a rocket engine, but it's meant to increase the heat output of like an oxy and acetylene setup idea I've also had. Okay, and these are all fairly recent. Is right before bed and right after I woke up. These are after I recorded everything I did yesterday. Okay, so we're gonna start off. Let me write this down. Actually, I should just put it on my Google Keep notes instead of trying to move, since I don't have any pen and paper anywhere near me. So let's write this down. So plasma stuff, TV. Let's see here, quantum foam, energy. Let's see here. I think that's probably what that would be. Oh, right. Computer transistor thing. So your van with a camper setup and other due dates. See, is it thermite together with oxy acetylene nozzle to increase heat using different method. Alright, so let's talk about the van with the camper setup and the other doodads first. So you have to deal with that first. Alright, so that one is a rather simplistic one. You've probably heard about this. I like, let me just look up what these are actually called. Yep, they're rotary engines. Well, that's a Wankel engine. That's not the same as this. Right. So that's why I keep thinking Wankel engines for rotary aircraft style engines. Right. Anyways, so I decided to make this in a different way, so that way I don't have to like have it be nearly as complex as some people thought previously about my bus thing with the whole rotary and then like having the top and bottom. So this one's an axle. It's shaped like, so the central axle here, it's got a bunch of gear teeth. Think sine waves. All right, on bumps. So bumps, what's a good way to describe these bumps? So they're like waves. So it's like they're going to go from this central smallest point that then goes up, but it's a slow slope angle that then steeply falls off, very quickly. So they're kind of like a wave, but they're not overhanging. They're just kind of falling down, almost vertical. Right? Alright, now that's the central axle. Okay? You gotta imagine it with gear teeth on that. Alright? I know. Where is this going? Hold your horses. You're gonna love it. Guarantee it. Alright. Now you're gonna imagine a axle, hollow axle. Alright? Simple stuff. Those have teeth on the outside, that axle. There's going to be one for each one of the 12 cylinders we're going to go with. Alright? But they're hollow for a reason. The crankshaft, which is basically what that is, what I'm describing here, that this has the piston head and connecting rod as normal, regular assemblies. Okay, but they're going to connect to a bearing style instead of like a frictional, meaning two hard surfaces with some lubricant. In this instance, we're talking about roll ball bearings, Okay, now that is not just attached to that axle, they're actually, because we haven't even fully described that hollow axle. There are gear teeth on the inside of the hollow part of that axle. The bearing will rotate around for the connecting rod from its version of top dead center on its bearing, rotate down, rotate all the way to its bottom dead center, and then rotate back up. Okay, you can picture that, I'm sure. I'm sure you've got that, right? It's pretty easy to understand. Alright. Now, that spins a gear that it's attached to, that bearing, to the internal hollow axle part that this rests inside of. So that bearing is inside of this axle that allows for that to do that sort of rotation around that central point bearing that it's connected to, kind of like a standard crankshaft. Now that rotation will then be transferred via those gears and its teeth to that outer axle, from its internal to its outer, kind of like a ring gear except it's wider. Okay? Now, that transfers itself to this central axle with the waves and the gear teeth that I just stated. It's also hollow, but in this instance, it's got a hub in the center with like supporting, arms or structures, whatever you want to call them, because we're expecting to have a lot of torque, and I want it to weigh less, and I want it to be able to transfer a lot of energy very effectively and efficiently. So it's not just hollow, it makes sure that it can support itself across multiple areas throughout the entirety of its length. Okay? Because I designed this to be a standard, at the top only, combustion chamber rotary design. Now this was a 6.2 liter longer stroke to bore engine that fires 3 cylinders every time it's rotating, for all 4 of them to be going off. 1, 1, 1, 1 in a pack of 3. I call them 4 because they're a pack of 3 and they do it triangularly. That's how this works. So that's why the axle is shaped like this with these particular geometric structures. because I can cast a block of cylinders that have an increased length, meaning stroke, to bore. It makes it a lot easier to do this. I can section it in 4 packs, bolt them together. There is a sliding circle of 3 layers. Okay, so these are 3 layers. One on the inside slides in between 2 static fixed rings. They're shaped in such a way, the connecting rods and this separator for the crankshaft area, to try and pump oil to the crankshaft area, bearing area, and be able to seal that oil out of the rotary's engine, bay area. I don't want it to go into any of the cylinders. But it's not just that, I also do have a pump at the bottom that's a dry sump. It's meant to try and take anything out of that bottom area where it rests at, and then put it into a box that just pumps oil back in. Now, that pump also pumps it back to the rings, because it'll still get to the rings. It'll still go from the connecting rod back into the top layer and then back into the bottom layer, which is its version of lubrication. Okay, and so as it slides, as it moves from side to side, that's a pumping action that'll try and pump it back in. And it'll grab some of the oil that escapes and it'll go to the rings and to all the rest of the bottom of the piston skirt here, because it'll fling it enough around as it goes through too that it will definitely lubricate and oil all of the components like we want. But bolts, of course, go through that and connect the 4 parts for the 12 total cylinders all together and keep this all stuck in. And then there are, of course, bearings for the axles to rest on and have seal to exist, so that way the oil doesn't become a problem later. And you have a front and rear for your standard supercharger, pulley, all this. We're going to get to timing now, and I'll get to why this axle does 3 of these things at once and why it's actually a really good idea, and you might not quite fully understand why it works the way it does and so on later. Give it a second. I have to give you the rough overdraft of everything, and then I'll get the nitty-gritty details. Okay, there are 2 rings, alright, that exist on the outside. They're rotating counterly, one clockwise, one counterclockwise, front and rear, respectively, to the engine. They have bumps on them that push in a piston, which in this instance is a poppet valve, but it's still a piston, so I don't really see the difference, with a hydraulic fluid that is attached to that piston. As it slides and rotates, there are 3 bumps, and there are spacings such that the arm, the piston that it pushes in, pushes open the valve and then pushes close the valve. In this instance, I use the front and rear to do both sets of work. They are the intake for the front and then the intake closing for the rear. That way, it's easier to balance the pressures that are going on with the hydraulic fluid, oscillation harmonically here, out and cancel them, as packs of 3 can then be canceling out that oscillatory pressure wave. So it's very well balanced. And this is also why the axle works so well. For 3 of them going off at once, it balances out perfectly in a triangle fashion. I'll just have to quickly shove this in real fast. I was going to do this after I describe how the whole pressure, hydraulic fluid pressure, and that rotation effect for the ring. I don't use any gears. I use hydraulic fluid moving like a torque converter. In this instance, it's a coupler, but it's really just I turn on an electric motor, it spins up a little bit, then it engages the starter, so that way it gets pressure. But it's really not necessary because it's a 1-to-1. But like, I want it to, with solenoids, with an ECU that I have, because I want to move where the arms are for the hydraulic ram as it pushes it in and pushes out the poppet valve, and then it'll close. So, anyways, whole thing, the pressure allows for increased lift. It's a cross valve angle system. So you know how normally like the valves on an engine, typically you want them to be angled anyways to allow for better flow. Well, in this instance, they're very heavily angled, and instead they're angled in such a way that they're at a diagonal cross, so that way as air comes in, it goes in and it goes down the tube in a vacuum vortex. There's a manifold that's a ring manifold that has a couple of V's that go into the port. And by a couple, I mean just the one. And so it mostly goes down one way. But then that will have its oscillation continue off the direction, meaning the pressure wave, as air moved in back into the ring as it spins. Some of it will go back towards the main intake funnel towards the port, but it's shaped in such a way that it tries to reflect the majority of it off to that direction. And so that's a simple curve, and then more of a straight line that then curves. It's a big wider funnel into a elongated oval kind of thing. If you do that, then it allows for the majority of that pressure wave to be reflected back into the other side and captured into the rotational manifold, as it is separated into 4 parts, like with the engine block, as it comes in from a central area that then tries to angle it into 4 different sections to create a continuous rotating vortex wave, thus allowing for it to maintain higher pressures and velocities inside of the manifold, increasing its efficiency as an air pump for a rotary engine. Alright, we're almost done for the rotary engine. We have to go to why this axle works so well for this very thing that I'm trying to get done. So it only needs the 3 waves, and then it's meant very specifically to be at its very top dead center. So let's start at its very bottom dead center. Alright, it's at in between the wave areas, with the spikes as it moves over to the right or whatever direction, so it's turning, rotating. It's going to go right up that nearly vertical front face part of the wave. As it does so, it causes the gear teeth to change its direction for the axle that is there rotating on it and is stationary, because of course I have the girdle that I described that holds in the oil alongside of the plates along the other side where the crankshaft's bearings are. So they're just going to go up and down. They're going to go up, down, and oval. So it's kind of like, let's put it this way, it's like a right angle triangle that has some curves. So it goes over, and then it goes in, and it goes up. It goes over, in, up. That's what it's doing. Alright? Now, as it goes up that nearly vertical wall, pretty steep angle, it rotates from the bottom dead position at the bearing where the crankshaft's arm, nope, not crankshaft arm, the piston connecting rod, okay, someone else is probably here, most likely, yeah, that then rotates that over to the left or right, depending on your perspective here, up to its version of top dead center, goes up to its version of past its point of top dead center at that point. It has moved up while also moving the connecting rod up. It has traveled its full stroke length, gaining in a shorter package a much more increased stroke length than you probably thought. Now, as it then combusts, it rotates over, because it's already moved over, it's rotating now, the central axle, that's going to transfer all this work energy to your wheels. As it goes down, it goes from its version of top dead center on the bearing over to the right, or whatever your perspective is, and that transfers to the gears on the inside, to the gears on the other side, and eventually, meaning it transfers it to the axle tube, that's a gear tube or whatever you want to call it, that goes to the gear teeth on the axle, another version of gear tube, I guess. Anyways, but because it's positioned in such a way that it's going to rotate over while doing that, it's going to transfer to the gear that is the axle gear, like the real axle gear, a lot of its rotational energy as it moves down, but then it's now a much higher degree of torque and leverage because it's much further over, pushing down the piston head as it both rotates that bearing but also pushes on that axle with the three wave gears, I guess, with the gear teeth, but they're waves on the axle. They're like bumps, effectively. I call them bump stops because they're like, well, it's a rotary engine for an aircraft. They used to use these bump stops for when they were shooting guns. And so they would stop the gun from shooting while a prop was in front of it, and you get that characteristic sound, stuff like that. And so it's like, this is kind of a version of that. They're like bump stops, but they have gear teeth on them, and they're shaped in a very specific way to allow for it to transfer a lot of that leveraged energy over as it moves down, and then it pushes it down, and then it comes back in because of the geometric shape that's going on. It wants to head back in. The piston can no longer travel down, but because the piston was traveling down, over its top dead center with the bearing to its bottom dead center, that acts as a increased amount of rotation, meaning opposite effect. It's trying to move the opposite way for the central axle gear, but it also pushes itself back in towards the now nearly vertical wave bump on the axle. So like as it rotates, it'll move itself back in on that gear. That's what it's designed, but it's also meant to try and move that central gear, that central axle, rotationally speaking. So it's like it performs two actions. It both speeds up the rotation, but it also moves back that axle gear to its central position. And then it'll ride back up and it'll take some of that energy from those teeth and the rotation of this axle, and then of course there's a flywheel, back into putting that up to its top dead position, while also at its very top dead peak bump stop position. That now has a 4-stroke. These are 4-stroke cycles. Each pack of 3 is a 4-stroke. So power stroke, and then it does its exhaust stroke, and then it does its intake, and you get the whole thing. So that has a little plate that allows for it to slide, stay in line with the rotation of the connecting rod for the piston. But the reason why this is revolutionary, I guess, is the word that you'll probably use if you want to sell it to people. To me, it's really a big deal because the entire duration of the downstroke is captured. The entire power stroke, all the way to the bottom, dead center it's at, is effectively captured. It's very close near the bottom. There won't be some capture. It is a very different design than what basically everyone else has, but as a result of it, I capture the full power stroke every time. The biggest drawback is the sudden rise, meaning it very quickly rises up, and that's for its given amount of energy in rotation that's captured. It happens to need some of that coming back, and it's quite a bit more because it suddenly has to go up, and it also has to move the piston up with the connecting rod and everything. However, I have 3 going off while it's exhausting another. And so it's like, well, I have the flywheel, and then I also have the power stroke of 3 others helping lift that fucker up, and then I do it again, and I do it again, and I do it again, and I do it, and so you get the timing part here for this axle. So it keeps itself going very efficiently. It should be insanely balanced as a result of this. I don't need balancing weights. I have other balancing weights as the pistons now. The pistons are my balancing weights, along with the exhaust that's there. And because I use typically a 2-stroke or some version of a scavenge effect, so it's not just the intake that rotates down the cylinder sidewalls to create a vortex. The exhaust is often started around the same time it's already mostly lost a good amount of its pressure. And so as it comes in, that scavenge effect starts to rotate that, and it clears out the exhaust, it closes, and I usually use a degree of a continuous vacuum energy siphon effect. So once I start opening the exhaust, because it's also along the side of the cylinder sidewall, even though it's a pop-up valve, it's just angled, and with its valve angle on the stem, and then it has this little heel, kind of like for like a shoe, and it's basically like a scoop. It scoops it off one side, so it already wants to create a rotation, and it's of course countered to the intake. It means I have a much larger valve that I can do, but I also gain that energy to help out the both exhaust speed and velocity, but also gain a vacuum pressure wave as it oscillates. So it'll very quickly, rapidly come out, but it creates an oscillation effect, okay, which bounces off the top of the piston head as it tries to race upwards. And so it creates kind of a near continuous, vacuum and just above where the piston head is. So long as I shape the head to try and forcefully make that pressure wave that's trying to go back stay in the vortexing effect spin. So as it tries to come backwards, it has to reflect off the boot, and then it has to divert back off into the spin. And the majority of it can be captured that way, but not everything. And so it creates a kind of like a vacuum effect, reducing some of that energy to exhaust in such a way that once I open my intake, it will add into that pressure wave so long as it's timed appropriately. It goes into where the vacuum is. The exhaust is closed. It will have, because I use port injection and direct injection, so I use injectors instead of carburetors. I will have no longer the issue that typically is seen with scavenging effects at low RPM that a carburetor often has, so long as it's timed correctly, where emissions is a problem. As a consequence, though, I gain more mass airflow and a higher degree of pressure that I can get into the cylinder that's more consistent and accurate throughout. With that intake manifold that I have, it will hopefully increase this effect even more, and I actually do use a setup where I have a compressor. So in this instance, it's a standard central, it's a turbo. You call them a turbo, it's a turbo. But it's a little different in this aspect because I have 3 going off and a 4 packs for 12 total, 6.2 liter. Now the reason why I did this is because I can't get a V8 into a tiny little van. And this is a full-size van, so it's not like tiny, but they kind of suck for space. You know what I mean? Like for practical purposes, I have a engine block here that has, cooling, as oiling, as a head here that's gonna really help out with flow. I can easily stick that manifold on. I've got the rings for timing, for lift duration, and timing. So it's like that allows for me to, with the scavenging effect, even go to a 2-stroke style, but because I have a 4-pack, that technically evens it out to being more like a 1-stroke. Okay, it's not a 1-stroke. I get that now. There's a lot of anger on that one. I still consider it kind of like a 1-stroke because it's doing everything in basically 1 stroke every single time, but I don't know. Like it's not, but like it feels like in the way my mind works, it's like, well, it's intaking also while it's exhausting, and it gave me a power stroke all in 1 stroke, and then it does the compression. So of course, that's the difference, right? And then it, boom, right? And that's why it's like top and bottom, though. If you do that, then of course it's like, well, yeah, no, every single time you're getting a power stroke, right? Which is a way to cheese that. Well, I've got 4 of those now. 2, 2-stroking. So I feel like it's now at least a 1-stroke. You know what I mean? Yeah. But it's not. I get that. But it kind of is. It's a whole thing. There's a whole thing with that. And all due respect, I get you. You're fine. Doesn't matter. It would be a lot more power, but a lot more fuel use. I don't really see it as actually necessary at that point, because when I have a pack of 4, that gives me a 3, while it's not the same size as a full diameter of the same bore, it's still a good diameter size bore going off that's perfectly balanced now. It gives me the full duration of the power stroke, while in a 4-stroke cycle, without needing that scavenging effect for anything other than helping the exhaust and helping out reduce the energy loss for lifting up the piston head, but also the loss of torque that can come with. So for me, it's like this is a real huge torque monster. That's what I made it for. It's like it's supposed to be for huge torque. Like the rotation of the bearing and the arm, the physical, connecting rod arm is like a big long lever pushing onto the farther outside point of a circle. So it's like there's a circle, and then at the surface area, it's like, oh yeah, no, you can push here. Well, now it's further out of the circle, and so now it's like it has that extra lever on it, while it also happens to be pushing it down, or in this case, away, while also rotating, and because of that rotation with those gear teeth, that adds to its torque while moving itself back to its central position to go and exhaust the combusted gases. So I captured all of the power stroke's duration of energy. Cool stuff, while gaining a less loss to lifting the piston back up, frictional and or otherwise, right? Because I make it evacuate faster. And now it's very, very balanced as well, with a lot of structural, basically like clamps and bolts and, all that, sticking it together, like really, really hard, which is just like a super engine block. So there's going to be seals, of course, that you have to maintain and everything, like any other engine. It'll eat some amount of oil, of course. Yes, there is in the ECU, a way for the dry sump in this instance to run after the engine has turned off. So it does that, sucks it up, and then pushes it back into the crankshaft just in case it happens to try and leak into the bottom. If it does that, it'll suck it back up, which is good, because I don't want that flooding with oil. That sucks. That was the main problem that rotary engines had, and now I've solved that. So, it's also more compact. It has the equivalent of its own, instead of needing 24 dual overhead cams. Holy shit. I don't have to do any of that. The heads come with those little hydraulic rams, so it's like that's a fluid that it presses on with those little bump stops as it rotates in, and then it'll press it on the other side back out, so it'll go back to its original position. And because I can alter using pressures and some solenoids how much fluid is going to go through, because that's the pressure as it spins for the supercharger. It's a hydraulic fluid pump thing, so it helps it rotate. So they're bearings, hydraulic fluid bearings, but also it allows for some amount of increase of that hydraulic fluid and its pressure into the tube that ram is attached to then push the valve open a little more and faster as a result. This is like it's got more pressure, so it'll open it faster, but because there's more momentum, it'll move a little bit further because it does that, and then it'll close just as fast because it has that pressure, and it moved its timing based upon a solenoid of where it's positioned, where the bump stop as it rotates will hit. But it's a one-to-one kind of style of coupler. which is why I also have the electric motor start up and give it some pressure and fluid. It doesn't really need it. It's a 1-to-1, so it'll start immediately without that and still be timed appropriately. But I do it just in case. Alright, like, I just want a little better reliability. It's effectively all it is. Because I don't need them at the top, I can have them along the sides, those little ram stops, as you push it in, the bump stops. They are very, very evenly balanced. I don't have 24 of these fucking shafts. Finally out of that. And now it all works off of 2 rings. Way more simplified, way less likely to break. I still have to have all of those pistons, but for what it's worth, that's a lot easier to fix than it is 24 of these damn freaking covers and shafts and drain some fluid. Let me just, is it the seal of the O-ring or whatever? Stick on a new one, stick it in, fill it up, pressurize it with a little electric pump. Done. Get back to going. That's why I wanted the rotary engine in this instance, because while it is a lot more ovoid, and it still is quite a bit more in terms of its stroke and bore and so on. So it has a longer stroke. I wanted to have a lot more torque as a result. Because this is supposed to go into a van that's supposed to camp and off-road and so on. Carry a lot as well, and have, in this instance, an 8-speed with a automatic. In this instance, semi-automatic is what I was hoping for. So, but an automatic is good enough for what it's worth. So give me a second on this. It has a turbo, sure, but it's not a regular turbo. So I have instead built a torque converter with a coupler of another type of turbine. So the exhaust from all 3 of these is combined into like this outer style turbine that connects to the torque converter that's in between the transmission and the engine. And so like that will spin those blades and then dump its energy into the torque converter alongside of the engine as well. And so I can get more torque from that exhaust pressure directly to the engine as work energy. Then that'll go off into a turbine, because it's still like 12 freaking cylinders, and it's still a big boy engine. It's 6.2 liters. So, it's a big boy guy. You know what I mean? That's what it is. Anyways, that'll go off after it's bled some of its energy, which is a decent way of getting immediate work energy. But I don't need it to, even though it's very balanced. I love the balancing. If you don't know, it's like this huge torque, great balance, super, super efficient, at capturing its energy as a result of this. Great. That's literally the reason why I designed it. But I don't like super turbos as much in this instance. I didn't want to lose some of that torque as parasitic loss to a super turbo, meaning a supercharger that's also a turbo. So I put a MGUK on the turbo, the turbine in this instance, and I haven't talked about this. So this one's a nice little turbine. They always get weird about it. I swear I just heard someone say some comments and caused me to get fucking a little miffed. Anyways, so this is a different type of turbine. This is a 3-foot long turbine. I need to describe this fucker a lot better, actually. So, I've described some of it before. It goes from in to out, back down to in. So it does a full up to down, alright? But This is a different type. And I have to go pee, so I'll be real quick about this. All right, so I just went pee. So where was I? Turbine. So in this instance, this is a turbine. It's not attached to a compressor. Well, it is, but just bear with me. All right. So it goes from in its center position towards the hub to the outside tip inside of its housing. It is shaped with a stator at the tip, so it's got a shaped tip and then a stator as well on the housing that creates a vacuum effect that pulls it down further, and it skips over a area where there's a in the housing connected to nearly where the hub is, a gap here, of course, between the blade and the next blade. Okay, so it has to go all the way down, and then there's a gap of a, hopefully if we can get it done right, because it's supposed to take any air that's behind that blade and draw it into the direction of travel. It's a good old Venturi effect in this instance, and Bernoulli's, because we're not taking more air, but we are taking more air. But there's a vacuum effect because of a fast moving air. Both effects. So that vacuum behind the blade is now going to be used as a pressure wave dynamic towards the incoming air. But we're not done. I can't fully get all of that air. Some of it is going to go to the outer blade housing. So there's another set of blades that's outside of the internal set of blades. So there's a housing, and then there's another housing, a hub, and these ones have the housing outside as a part of their bearing hubs. Okay, so it's a circular bearing hub for it. So it's hollow. Yeah. Okay. Now, that air travels, some of it, because of course we have the others rotating as they go through this, but some of it has to go up to be able to produce this type of intended desired effect. That goes through holes, and you'll see why that's a good thing to have them there, with some valving, Tesla valve in this instance, harder to go back than forward. Alright, with boundary layer designs that allow for it to produce a boundary layer that sticks in an oscillatory manner. And in this one, it's like a Lorenz lens where like there's curvatures and some little lines through that. And so that's like a Tesla valve with lines, but it's very, very close to the boundary layer, meaning surface area of the material. As a result, it skips over that very easily, and it has a very high flow velocity. But it also means that a little bit gets stuck there, but that pressure wave oscillation effect and the good old Bernoulli's principles help draw it in to the direction of travel of the gases and reduces the energy loss to the surrounding boundary layers. Alright, this then goes into its version of an intake, which is near its bottom, which it has to go from its version of it, the intake for the hub, the central area hub here of like a bullseye. Okay, then goes out to the tips. Then this goes to all the way to the rear of where the central turbine part is. And like there are multiple blades along this tube. And so it starts off small, gets a little wider, then gets much smaller. It's like a elongated tail teardrop. Okay. Now, the reason why we do that is because it's at first very high pressure, then it gets much lower pressure as it continues. That pressure is made to be very less restrictive as it's going through this, goes and rotates a 90 degree with the curvature of the air coming in. Alright, so like this already produces, with the stators involved, a continual curve with the air, good old Bernoullis and Ventrulis. So it rotates, kind of like a torque converter again, with the gas involved. But in this instance, much less energy is used, and it's done very efficiently to then hug it towards its version of center. Then it goes back from that to outside. There are, of course, towards the center part of the hubs here, holes at these stators, alright, that allow for it to go back up, and the shape of the blade helps it get captured throughout its, in this instance, it's kind of like a katana or scimitar, something like that. You know, it's a curved blade instead of very straight. It's curved with a series of fullering, channeling on it to allow for it to be very efficiently stalled and captured, but then it gets rotated and moved very, very efficiently up to the tip, as if it has a much longer lever now being acted upon at the tip because of its curvature, with the stators helping separate a vacuum, or in this instance it'd be a vacuum compared to the pressure that's coming in at first, but then it'll turn into a near perfect vacuum, is what I'm hoping for. I usually just get really good vacuums, that comes off of that, thus increasing its effective torque energy as it tries to always have that comparatively much less pressure, but it doesn't matter because I have a near perfect vacuum or a very good vacuum behind the blade now that it's always trying to head towards, and it knows that it has that because it connects that with the rear stator area. As a result, those are the correct tubes and holes within inside of the stators to have it always try and head that way, but they are in such a way designed with overhangs and little bumps to effectively have them skip over those holes and try and head back into it as that low pressure, but then it gets captured on the other side before it can go in. Now, some does get captured in. It's a pretty strong vacuum, but there are layers. The standard S channel, meaning offset holes with this effect, so it'll race forward and then it'll try and do it again, and that's why it's a very good vacuum to a near perfect vacuum depending on the pressures and velocities going on for this turbine. I only have so many blades and stators I can put in, but it's 3 feet because now I have effectively doubled its length to 6 feet. It's like I start from a really relatively small high pressure to a much larger lower pressure, with the medium pressure turn and change, helping increase the efficiency of both designs by having the channels and the tubes and so on that allow for the gases and its velocity there within to be maintained. Then it exhausts as it goes out, some of it to help with its efficiency again, because it cools off pretty dramatically as a result of this. It exchanges a lot of its heat into these channels and everything, and eventually it'll heat soak and it'll be a little better and more efficient as a result. But I recirculate some of that exhaust coming out of the turbine back into the continuous hot air that's moving at very high velocity, back into the intake again. That helps maintain pressures and continuation of velocity. So I'm going to use some of that to act as if it's a lower pressure, even still, at the exhaust area, to help increase the efficiency and also pressures, because it's more volume, meaning there's more stuff there coming in now into the overall turbine design. This improves the efficiency even more and improves outright pressures and maintaining of pressures and continuation of spin. Instead of pulses, I now get continual pressure coming in, which is a good thing. You want that for turbine efficiencies. But a good damn amount does get taken out, meaning it's always going to be removing, and exhausting air, which is something you need and want. So that's basically all that is. That then goes off into catalytic converter, and then into any high flow resonator or whatever combo for your exhaust that you want. All for the rotary engine. Now, the reason why it's 3 feet is because 3 feet makes a lot of sense, considering like they're usually 90 something feet or something. Like they're really ridiculously large, these steam engines, and every single blade set has an exponential drop curve to the amount of captured energy it gets, which is just shitty somewhat. It's not shitty, but it kind of sucks. Yeah. And so, this is a way to basically try, once it's got up and running and once it's, really going. It'll start off pretty efficient anyways, way more than a standard turbine on a turbo would be, which is, I think, at most 10, maybe 15%. Well, this is starting off around that 60%. And it'll rapidly climb, once it gets hotter, into that 90 to upper 90%. It's not going to get rid of as much heat after a certain point. But what it does do is it removes a vast majority of its pressure. And it is almost a high flow resonator in its own right. So it'll take a lot of pressure pulses and then only have it come out as a continuous sine wave, effectively. And a fairly low one at that. So it's a always continuous exhaust from the pulses that come in that then change into a sine wave. And so, that's kind of the crux of the design. It's if you want the boom, boom, bang, bang, bark, bark, you're not going to really get that. It's basically gone. But you will get a wonderful jet engine turbine whine that's pretty low and powerful sounding. You know what I mean? So that'll be nice. But it should still be hot enough, especially just like any other car. It'll take a while to warm up the catalytic converter. You know what I mean? And after that, that's basically the end of the design. So the MGUK is its version of trying to maintain, because I only go up to 17 to 15 psi, between a electronic pressure change. So it's I use a pneumatic with a solenoid. So it's I have a pneumatic cylinder, and then I use a solenoid to basically change the outright size of the diameter of the pipe. And so that changes its PSI, meaning its spring rate, to change its pressure. And that pressure is typically dumped into, it can't, because I have an MGUK, but in case it fails, I'll just dump it into the high flow resonator. That's where it goes. Yeah, I know. It's like, why wouldn't you just capture it in some other way, or something else? And it's like, it's just not going to spin the turbine very much. I'd rather it maintain its heat. And so if I like reduce pressure behind the turbine, that'll allow for me to maintain turbine efficiencies. So that's how I did that for the turbine. That's also why it's 3 feet fucking long. That's why it also goes from a turbine that's on the outside, which is another version of this for the exhaust from the coupler. So it goes outside to inside to outside. So it'll go from one side and it'll go through from its, let's say, very outer diameter towards the middle diameter, and then it'll change inward direction, so it'll bifurcate, and then like as a result of doing that, it wants to go towards its inside position, and then that all gets captured back into a singular output that then goes to the actual turbine. Now there's a shaft, yes there is, the shroud, the hubs, all of those are connected. Both the bearings and everything have to have gears and connections. Just, that's a thing that has to be there. So there's a degree of loss that you have to have no matter what. All of them do. So there's that. But also the hub itself is not going to be able to be connected to anything, because I hate that shit in the way, basically. If you want to know the crass version, you're disrupting my fluidic flow of gases, is what my brain does. So it's like, I'm just going to stick in the stators here a little thing that goes into the shaft area that then I'll pull out like that torque, because I also have like all of those little hubs that I have to stack together essentially on the shroud with the bearing and the gears that connect them all. And so, like, since that's kind of like a planetary gear set, but in this instance, I didn't want to, like, really make it anything other than bearings and only have, like, one area where, like, it's transferring to one central gear that I'm going to get with that shaft that I'm already putting into the central hub. All of that energy into that main shaft, so it comes off on the side of the shroud, and then that will be where I send it down another axle. In this instance, just what I wanted to do. I always had this weird fucking like crux problem, because it's like, I have this heat. Look at this heat. What is this heat doing for me? It's doing nothing. Why is this heat here? So then I had like an idea to cool the housing to a degree. It's like, I don't want it to cool too much, but I don't want it to not be somewhat cooled for both of it. So it's like, well, I mean, that fluid can still turn into steam, and then that can be transferred on over. You know what I mean? And so I was like, well, if I keep it as a version of a thermal siphon, so it'll boil off, but then it's getting pumped, so it's already trying to pump fluid around it. And so it's like, it'll go into a, kind of like a soda bubble type of design that then goes from this large kind of like manifold, reservoir that then is pushing into a bunch of little tiny tubes that then compress it under that heat now. And it has to be insulated to make this work. It then will force that vaporization pressure to go up, and then it'll capture some of that heat, but because that heat is now being used to push, or help push in this instance, that fluid that direction once it gets going, because I have a vacuum on another side, that's the pump part as it's spinning, then it'll forcefully try and push it that direction as it tries to expand, helping compress it and increase its flow velocity rate. And for the given amount of heat energy I input, I gain up to a certain point an increase of pressure, hydraulic fluid pressure in this instance, or static or fluidic or whatever pressure, but I use a fluid, yes, like a hydraulic fluid, that then goes off into another version of a turbine that rotates the compressor. So it's basically like another version of the other like turbine that you have. No, no. That would it'd be more like a cavitational design. That one's more of a vacuum design. This one has to be a cavitational design. So I make a cavitation style that allows for it to use those high flow velocity rates as a way to reduce boundary layer problems and then help increase degrees of angle of turn and transfer to its velocity of flow to torque onto blades, kind of like a Pelton, and then it has to go opposite direction. But it's like a Pelton into like a turbine thing that then is like a Tesla. So it's like from out towards in that then has to go through its continuous travel. So it's like it has to go from Pelton to like a Tesla turbine that then has to go through a regular elongated turbine that starts off small, goes a little bit big, and then it goes back into like nothing, because like that's just going to be what that reservoir tube now is that it's trying to suck in, given the pump that it's using. So it starts off relatively slow. There's not much heat, and you can easily make still a lot of power that way because you'll capture a good amount of it. But then once the heat soaks in, whoosh, it goes way higher. I get way more efficiencies, and I have a way to like separate it with like a heat wall, like a firewall to the compressor. The compressor in this instance is standard centrifugal compressor. It's got the standard parabolic funnel, kind of like ram air sort of thing, into like its beginning intake and then compresses along the sides. The only difference for the inside of this is that there are stators on the inside and these little lines that run through the housing where the blades are spinning. So it's like those little lines bifurcate the air that's being pressed against the housing into little channels that are sealed up to the blades, and then the stators help act like their own degree of like pressure recirculation. So it's like as it moves from the housing circle and the blades move away from where the exit is, it then rapidly accelerates all that pressure that it built up from all of the blades, and then it fires it into the exhaust area. And so those little stators go over and they'll trap air that tries to squish out and rotate out back into the flow going back in. And that's your standard Venturi-Bernoulli's principle, as it'll suck air in from its center and then it bifurcates it and then it'll try and stick it into the housing, making it a little bit more efficient at capturing its energy and getting a increase of flow, but also pressurized flow for the compressor design. Then it goes into a air-to-air exchange, which is typically, right there in the front. But I have an AC, so a below ambient cooling system. So I have one for the van and then one for the engine. I figured like that's my version of a supercharger. You know what I mean? Like for the amount of, it's like 2.5, 5 horsepower, something like that. For the amount of torque or whatever that I lose for an AC compressor. Like, I mean, it can go higher, but like whatever, right? So I was like, well, if I do that, and then that's the condenser area, so it's like I'll do the air-to-air, and then I'll do the condenser that will then go into like a funnel that gets sent off into the 4 different sections for the manifold. That it'll this is equal link 2 headers, send, and then have that manifold rotate its continuous air flow to help with its efficiency as an air pump for the rotary engine. Same thing kind of with the torque coupler, torque converter thing. So it's like that's another version of the same thing. So it's like the exhaust, each three come off equaling tube headers and are angled as you can, if you could imagine it, it's kind of like a bunch of rotating exhausts that are equaling tube headers to this little torque coupler, torque converter to the torque converter. You know, it's like a big old torque converter effectively with the exhaust that goes into it. You know what I mean? So, and that'll attach to the crankshaft, area axle thing, which is the flywheel clutch in this instance combo thing that it has. I get it. It's like a bunch of like they're all the kind of same thing. They're not like a flywheel's not that, but it's like near that and it's on that and it's like a part of the flywheel for what it's worth. You know what I mean? Like it's a setup for like why the flywheel weighs a certain amount. Like it could be so much smaller because now I have a clutch that makes it so that way it happens to have the clutch weight added to it. You know what I mean? It's kind of weird to me, but they're not that. They're separate. But like you can usually understand what I'm saying when it comes down to that. Yeah. But that's also why the torque converter is a thing. So like I have a torque converter here, but like the torque converter is this exhaust manifold thing. So like that goes into that, and so like that doesn't connect because it has its own version of a clutch. So it's like that's why it's a torque converter that starts off with the crankshaft, and then the exhaust will get going, and then that'll connect, like the coupler that I talk about, and then that'll add to it direct to the engine's output. So exhaust is captured as direct work energy. And then the remainder of the exhaust energy, as much as I can really, is then used to compress air and efficiently help the air pump, the engine, work and run. So it's a very high efficiency engine because I also have the MGUK, but I haven't finished yet. And I talked about this Jules Thompson thermal pump. Like it's a pump that's using acoustic resonance to try and get heat using together with the Jules Thompson heat exchanger cycle to increase its degree of efficiency. Then I placed in piezoelectrics with little diaphragms in certain areas that are in there, so it's like it helps it resonate because it's mechanical stress with the diaphragm, and it resonates, and that acts like a pump. Then I get electricity. Okay, and because it's heating and cooling, it expands and contracts, and it's already going to vibrate because it's on a car. So it's like I get a lot of energy, like recaptured energy from piezoelectrics, because they're usually around those 90% range of efficiency. So in the right series and parallel, meaning it has reservoirs that it sends to, and then so it has a main reservoir, and then that dumps it off into other reservoirs, which go from it's vertical, then it goes to the side, it exchanges heat, and then it dumps it into the bottom, and it gets picked back up to cool the engine, because they're blocks that are meant to be cooled with the four pieces. So that way I can, especially because here's the thing, I know it can do really, really high RPM. I don't care about the high RPM. This was a torque monster. I wanted torque. That's what it was for. Because I have a transfer box I have to talk about, and another series of independent axle things. I'll get to it. This is not a standard van, is what I'm saying. And then I'll get to the camper stuff, because there's other doodads is what we're currently talking about right now. So, the 8-speed in this instance, because usually off the shelf is good enough for most people with an overdrive. So, the 7 to 12 psi, alright, is with the turbo that I have going on here, the compressor, is meant to spool up quickly and be from low to about medium high-ish RPM to function. I want it to be on immediately and operate within around the 1800-ish, maybe 1200-ish, if I can get there, to a max 5,000 RPM. And it just can't keep up past that kind of thing. And the engine was only ever going to go to 8,000 RPM. Now the reason for this is because I have this 8-speed, all right, which I've thought about this whole thing with the 8-speed because I kind of want to change it in my head to like a CVT clutch or a CVT pack setup. So it's like I'll have a clutch that it changes its 8 speeds, but then there's a CVT gearing for each one of the gears that are going on. So they're like rings in this instance. Like Robert Murray Smith just did a CVT ring setup, which I need to watch, and I think that'd be very useful for this because that means I can take the standard 8-speed housing and then use those ring CVTs to create like gear packs in this instance for each one of those 8 speeds. And so it'll go, you know what I mean? And so it'll start low, it'll go up to higher, it'll start low, it'll go up to higher, it'll start low, it'll go up to higher. The reason why I'm doing this is because it allows for the engine to always be at optimal performance of engine RPM for torque, especially with this overdrive. So it's like it can get boost at a low RPM, have massive torque, and still have the correct gearing to maintain my speed, my vehicle's speed for my van, because it's effectively a brick with a pointy nose that goes through the air. And as a result, it's not very efficient. And it still works with a regular 8-speed with an overdrive. That's kind of what I initially did, and it's probably fine for what it's worth. But like the idea of like multiple CVT gear packs that you switch to, because there's nothing stopping that, is pretty cool. Gotta drink water. I didn't really at all yesterday when I was recording, so. Anyways, alright, so we're going to talk about that as it's done. So it's like that's a really hyper efficient engine. What's this electricity for? Because I also have a serpentine belt system, which in this instance isn't a serpentine belt system, it's a hydraulic fluid pump system that spins the alternators and gives you, if you still have the pump, you know what I mean, so on and so forth, that kind of thing, because I've already got timing taken care of. You know what I mean? I don't need a belt for that. And I just need an alternator and whatever extra for the the compressors for our AC for the van, but also the air intake system. Because like I want to go sub-ambient is effectively what that is. I'm not going to go to super super cold, but this way it started off as a idea because I live in the southern half of the United States in Arizona, and what I've noticed when it comes down to how high of a heat of the temperature that is during summer especially, it's terrible. And it doesn't really mean much in terms of knocking. It can though. It's especially maybe for diesel, but it's mostly because of the wear rate pattern you'll see in cylinders, and like as a result you'll end up getting less compression quicker, and you'll end up having the engine's fine, but it's like it's not as performing as it could. Like if you could get proper air density that's cold, you'd get better performance out of your engine. You know what I mean? So it's more consistent. I don't always have to have it super full blast or any of that kind of thing. So that's kind of what it was for. Then how I programmed the ECU, because we're going to have to talk about this before we get somewhere else. It's like there's an ECU here. I talked about that. It's not just fire at this point with a crankshaft, blah, blah, blah stuff. I had to go with a dyno testing here in this instance where we have this air altitude. Okay, so, and then we have at that altitude this ambient temperature that we're already dynoing at. Then I introduced with, so basically we are measuring the amount of, because we have air pressure, CFM, humidity, and temperature. We use those four things monitored at every single damn 12 ports. But one at a time is what we did. We didn't do it all at once. We did one at a time. Alright, so we did it first with standard dyno testing. We didn't do anything to it. Anything extra, that is. Okay, so give me a second. We plug that into our ECU as a base table that we know about. We then change the variables of the input, meaning higher humidity, higher altitude, so on and so on, with temperature and, whatever, in terms of that we could do. How we made the manifold, that one's a pretty nice little, I'm proud of myself for thinking about this. It's a stamped aluminum. Effectively, we bend it, and then we, using the stamping process, we put the two halves together, weld it, pressure test it first, and then we do another one that's going to go over top of that, and then that has a little nipple. We make sure it's able to be sealed. So we vacuum out all of it, and then we see if it maintains its vacuum. If it maintains its vacuum, great. We look for any seals. Okay. If it doesn't, by pressurizing it, and then we put your standard soap, water, to see where any bubbles may form. Alright, that gives us a vacuum seal. One vacuum seal insulation. That's it. It's just, stamp two friggin' aluminum sheets and boom, boom, and suck out all the air with a vacuum pump. And it's now suddenly way more insulated. And because it reflects IR, that means it gets a lot less hot, a lot less easily. I didn't stick anything else, it's just no air. Yeah. So, no fancy ceramics, no any of that, it's just air. So, that way it'd be really easy to just, if I could figure out a way to manufacture this for others, it'd be boom, boom, done, get it out and sent. Super fast, quick, simple. Yeah. And I could piece it together with multiple pieces for other types of vehicles instead of just like a van in this instance. It's like rotaries make perfect sense for a van. They have a short, stubby nose. You have to get them in close, and you want them to usually get pretty down low, so that way they've got good handling characteristics and are easy to work on. A rotary is pretty easy to work on, for what it's worth, and it gives it a lot more space to work with because of how compact it is. Even though it's 6.2 liters, the bore and stroke works out to be such that it's not that bad at all. And so, like, I've got my nice waste heat generator, radiator at the front, and then I've got my MGUK. I got this 3-foot long sucker, but it's like, oh, yeah, that's fine. Like, I can stick that right there. Like, that's off to the side. It goes over, you know what I mean? And then it just sends it off to the rear. Like, super simple, right? It makes total sense for me to do that. Maybe not to others, but to me it makes sense. Anyways, where was I? Right, ECU. The ECU in this instance, so we tested variables, now we have them plugged in as variables that it knows based upon sensors it has outside of the engine bay. Simple air pressure, meaning altitude in this instance. So for air pressure altitude changes that we did, that's what we were able to give it. And then temperature sensor, of course, that's hard to measure, so we tend to also put an air uh, temperature sensor after the condenser, so that way it knows. Then we have humidity sensor outside, but in the engine bay area-ish, so that way it's like more probably close to what it's getting. And then we don't need CFM. We have a standard one singular mass airflow sensor. That's the it's just a mass airflow sensor. There's no throttle body. Everything is kind of like a Valvetronics, so everything works off the valves. So their timing and their lift and the amount of fuel we give them is what gives it its idle and its outright power and performance, like a version of a free valve. Valvetronics, VVT, variable valve timing, variable valve duration effect. Which again, that's the hydraulic ram. It pushes it in, then it pushes it back, then it exhausts. And it's all timing, and there are for where the top dead center of a pack of 3. That's where for the ring here you position the bump stops at, and so there are marks and indicators for you to properly put this together. Now, the reason why we did this is because it means it's way easier to get much better air-fuel ratios for the engine to produce power, especially when you can switch it from a 2-stroke scavenging effect, and beyond that, in terms of how it is you want to time the scavenging for your 4-stroke to get maximum efficiency with least amount of fuel use, because we're cooling off the sidewall so much by having it vortex so much, and you don't have to actually have it scavenge the air as much. Make it a 2-stroke. So it's like you would think that this is a 2-stroke. Well, actually, we're cooling off the cylinder sidewall, and we're making it really leaned out now to help produce a reduction of knock. And we still have our standard spark plugs, that kind of thing. In this instance, the head is a different type of head, so I was like, well, why not just use this Formula One style kind of like jet thing? So there's this old Engineering Explained video that I saw where they had this little tube, so it's like it sucks in air and fuel and it pushes it up a tube into a little chamber where the spark plug is, and then that races down the tube and then burns going down, right? And it spreads out. And all you have to do for that chamber is add in a couple of little, funnels, bell ends, that kind of thing. With the right stators, race out like a big, huge flame front. And if you shorten the tube and you make several smaller tubes to this little area from that, then I have like that entire long part, like that middle part suddenly is now multiple parts. I can fire out a huge stream of jets off to the sides and produce that combustion burn that we're looking for. I don't do anything extra. It's a standard coil pack setup. Works out with the alternator and the batteries that you gotta have. So they're higher, larger coil packs, but that's all they are. So, crankshaft sensor is still a crankshaft sensor. So it knows what RPM it's at. That's basically about it. It's like I've got a mass airflow sensor, and I got a basic other sensors that you can get off the shelf for things. You got your tachometers now, as a result of that. It works with your standard, dashboard setup, right? Now, the only reason I did it is because I wanted to get really, really good very safe air-fuel ratios. You know what I mean? Makes it a lot easier to tune for the air-fuel ratio map that you have. So the table here, which is a map to me, but whatever, is dynamic. In this instance, it tries to dynamically grade for the modes that you have max power, or dynamically max power for the least amount of fuel, but it's willing to sacrifice some fuel to make sure it makes good power to the least amount of fuel used, period. And then you can change that based upon how you want it to be, along with your timing. Alright, which you can't go freaking ridiculous with the timing, but you can do pretty amazing things. You know what I mean? So, comes in from the front, it exits the rear. That's why it's a diagonal cross thing. So it's a diagonal and then it crosses in a three-dimensional. You getting the whole picture on that one. I'm already getting kind of tired of explaining it. And if you can't hear it in my voice, well, that's something you need to pick up on. So, when I get into the actually explaining how that program works, it's just testing, and more testing. Then I see what those results are. I then average them out. I then make a bell curve based upon other variables of input for information. It then changes the fuels and timings for maximum performance or maximum fuel savings or a dynamic. Alright, which that one's a plus or minus of timing for ignition, or when and or where it should be injecting fuel, and during or after, certain valves opening, and so on. That's the entirety of the program. That's what that is. There's no algorithm. It's very kind of dynamic. It's dependent on the input that it sees, but that's it. You know what I mean? It's like, hey, these valves should be open here at this RPM for these areas. That's really all it needs to know. To put that in perspective, a way to describe that is a crankshaft sensor for the ring that's rotating with tied in RPMs. So like this RPM, these pistons, these 3 pistons should be going off. That's set up in a dataset table. So like these 3 pistons are these 3, here, here, and here. These at this RPM and this where it's at in its rotation, it knows now that those are going off. And so it should be with these seen valve parameters it knows, because it's placed in the program, that are going on, because those are also sensors. So anybody's clear about this, the solenoids move those things. It's like, in order for them to move, the computer has to move them, but it's also mechanical. So it automatically tries to move things with those pressures, like a 2JZ or other, mechanical designs. But I can dynamically alter that based upon what the computer tells the solenoid to do. It will already try to do this and increase lift duration, but you can reduce that and you can change timings even more than what's already there that it will automatically do. So you have more adjustability, is what I'm trying to get across. The ECU is a basic bitch Adreno. It's a pretty strong one for what it's worth, but that's all it needs to know. This RPM for this area and its placement of the RPM, meaning it's at this RPM and it's at this point in its rotation. that means it knows for this pack of pistons, with this already set up knowledge of the mechanical already being done valves, that it then has this knowledge of alteration of valve placement and timing, gets this spark and injection timing for fuel and pulsing and all the rest of it. Finally, people kind of understand what I'm getting at. I feel like they were like, tired. I'm like, this is really simple programming. This is the simplest programming. This literally can't get more simple. This is literally stupidly simple. The equivalent is like, okay, so it's already going to do this. You know what I did? I stuck a shaft with some bumps and grooves on it. And it's getting read by like a needle, like a standard, like the valve that you talk about, like that's the needle, that's your valve, right? Because it's at this RPM and you altered it by doing these things with some levers in your cabin in the car, it then changed its timing dynamically for better air or better eco or better, whatever it is, right? So power, dynamic, or eco. Yes, there you go. That's effectively all it is. Like, this just happens to be a computer version of a mechanical version that's basically doing that. That's all the programming says it's doing, literally. I know that people with computers are like, I'm super amazing and everything, and you are, but it's still that thing where it's like, if I had a camshaft with the right little bumps and shit, literally I could do the exact same thing, and I would be the one that simply just presses and or pulls a lever, moving something around, and it gives me the same programming for the sensors it already has. Which, by the way, the sensors are basically just another mechanical version of that. It's like you can do it purely mechanical. You literally don't have to use this. I just did it because I have injectors, which, by the way, mechanical injectors still happen to be a thing, along with timing and pulse duration. They still have carburetors that change their jet, amount as they go up in RPM, in altitude. Okay, so it's totally possible to do this with injectors as a mechanical injector, as a fully mechanical setup. I'm just using electrical because that's easy. It's some wires, and I plug it in to a board that says, well, this is what's going on because the programming sees these inputs of pulses of electricity, saying that's what it means, and so now, because that's what it means, it does these things of pulses of electricity out. Simple as. Alright, I'm not Australian, I just like the saying. Alright. Whew! That took a while. Whatever dashboard, electronic things, is the ECU, whatever it was that controls that. This is the engine stuff. That's all that's doing. Then I have a game. So I ripped out the rear back. So for van life stuff and camping, you want high roof. If you don't know, all right, like you don't want low roof. You want a high roof, all right. And then you need to get a roll cage, all right, because if you ever do roll, you're gonna want that roll cage, all right. You want to get a lift kit, okay. You want to get a skid plate, and this is where I deviated from many other people, for what's worth. The transmission, while gear packed, if I could do it, like let's say I could do all full custom stuff, we're going to go with that. I then have a version of a different type of radial axle flex motor, or axle flex. In this instance, it's a three plates, but these are not the plates that are actually the things that are moving. I have two things attached to a axle hub that is also hollow, that's giving me both outside and inside versions of spin. That's its version of its plate, right? The standard axle or no, radial electric motor. The arms, the spindles, the spokes that come off that are rotating attached to the hub that is, all right, for this electric motor, is a pack of coils, electromagnetic coils that are kind of like a brush motor, but the spokes are hollow, so they just attach and send their electricity that way. And we use a fluid in this instance to act as the insulator for the copper wire. Alright, because I don't want any sparks jumping, effectively. Alright, so it also helps with cooling, so I can go from inside of the axle to outside, and it helps with cooling. The plates, or PCB, wound coils with multiple layers of PCBs, coils that act like our repulsive force in electric motors, instead of using neodymium or iron nitrate magnets, which they are kind of like a battery, because there's a certain given permanent flux, but then eventually dwindles over time, and you extract a certain amount of energy out of that using rotation and energy over time. So they're kind of like a battery, but they're like a conversion battery, and you lose a certain amount of energy making them, and then also from making the electrons, and then also making the rotation of it occur. Anyways, I want to move off of that. These are 12-phase DC sine wave AC electron flow motors. So electron flow means there's electrons over here and it wants to jump on over there. Alright? That's all that means. And so it'll perform work energy on its way over. Okay, well in this instance, that's a magnetic flux field. When you time it properly with the correct connectors in the right areas, like valves, like a two-stroke, as it moves and spins with 12 phasing, meaning sine wave phasing, and they're phased in such a way that they will more or less prevent themselves from dumping electromagnetic fields into the surrounding material. They still do, it's just less. That's why I use 12, and I use phasing pulses. So I use 12 lines, sine wave lines, that are pulsed and then phased in that pulse that push forward DC wise, but then that's why it's also an AC, because it's going to return with the electron flow back and forth. And so they will no longer interact because of the phasing. They will reduce their electromagnetic field because of the field flux that typically gets created, and the heat that is typically created gets dumped into the directionality of travel of the electrons and its pressure fields that are oscillating on the cable. Typically, they stay around on the outside surface area. Well, in this instance, we're now acting as if it's a tap on the cable, as it's a pressure wave field, as the squeeze and push and pull electromagnetic field of the material is being used to reintroduce that into the electron's flow path. So that field does get generated, and then it collapses into electrons as it flows that direction. It doesn't produce very many electromagnetic fields, but it reduces resistance significantly. and it reduces heat as a result. It then gets split up into all of the little coils, because we have 12, that's why there's 12. That's why it's also pulsed and phased and all this other shit with electron flow and AC. And that's why it's a Raxel, because it's those plates with the correct spike waves in this instance, because we can individually place the repulsive electromagnetic fields in a very uniform, directed, horizontal to slash. We capture some of it on the outside plates and redirect it towards the central axle hub, and then we capture some of that on its inside part of the axle hub towards the central plate. And so like it tries to move some of that excess flux back towards producing movement for the given design. That's why it's also an electron flow. Takes the field, turns it into electricity, current in this instance, and then you get the picture on that one. Cool stuff. Works fairly well. The reason why we have these packs of coils, which are again another PCB, and they're thick boys, but they're PCB, another version of that, several different types of coils, both that are in there, and so it helps with the magnetic field flux control, or otherwise I called it lensing in the past. I still think it's lensing. It's like it's a lens for electromagnetic field, so I don't really see what the problem is there, but anyways. That fluid also helps us move it up and down, and there's gear teeth on this, so it can go down towards the center of the axle and get closer in, so they're shaped to slide over each other and get closer in, and so the radial, meaning the radius of the diameter of the axle motor is apparently, because it's called an axle motor, because it fits in an axle apparently, or the wheel axle or hub. Why is it an axle? It never makes sense. Like an axle is a tube, a long tube. This is a flat plate. Why is it not the radial? Why do they call it the radial when it's the long tube axle shaped one? I never got that. Anyways, that goes from its topmost position, and then it can slide in on itself and then spread out closer towards the central axle hub area, thus making it able to spin faster with less need for torque. Now I have less torque at the very edges, sure, but I gained RPM, and I still have the radial electric motor that's going on, and that provides an increase of torque for it, thus gaining my horsepower that I lost previously, and it's like a CVT. Now the reason why I'm talking about this, finally got there, a whole bunch of PCBs, a whole bunch of blah 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 blah. Whew. Finally got there. That transmission is a straight shot to a downward connector to this radial axle flex motor that goes into the transfer box. We have 3 banks of batteries and capacitors with the electronic control units and everything else. The AC generator will trickle charge the battery, but we also have a DC generator for what's worth, not just with the MGUK, but also in between the transmission and so on. So that way I can capture the vast majority of energy from the engine as electricity, should I want it to be just a generator. I don't have to have it as just a generator at all. And so that's kind of my MGUK, the in between the transmission, but I have 2 of them, so you're aware. The main reason why is, sure, there's redundancy, but the transfer of that energy is from where that turbine is to the transmission takes, parasitic loss, distance, and mass. And so I wanted to maintain that efficiency. by putting another DC motor there, because for the most part I would have my engine providing a good amount of power, torque, and horsepower, not just the electric motor I described. Although it can run off that, and I can get up to like 5,000 fucking miles on a single gas tank. Now, it's a fairly large gas tank, it's 50 gallons, but still, you know what I mean? Because my engine's extraordinarily efficient, is effectively all I can say about that. I capture the vast majority of its heat as either work energy, which is captured by the DC generator, electric generator, and the MGUK, and the waste heat generator. So it's like most of it's pretty well captured. It's not like 90%, but it's pretty close as a generator, you know? So, anyways, moving on from that, 3 banks, they're flat packs. I cool them, but only kinda. I barely need to. Um, Even the capacitors are flat capacitor banks, for what it's worth. I still need to cool them, but it's really just not super as necessary because of the way I series and parallel them, as I pulse them. So I have to have them pulse with the controller. They don't just dump into the controller. They have a controller to pulse and be releasing energy for that DC to then go into the controller, which then sends it correctly, the even better, into this motor, which is a circuit and a rectifier in one, effectively. So I have less waste heat from doing that because it gives it time to, resonatively pulse. So it's like from top to bottom, and then from inside, center line to the outside. So it goes pulse, 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 pulse. And that's banks. 3 banks, 3 capacitor banks too. And that's why it's a big old bed inside of the cabin structure of the van that's at the bottom. So a whole bunch of words that mean it's really safe. I have a roll cage. It's going to make it a lot less heat, wastage, kind of way of saying it. But it will still have some, and so as a result, I will cool it. I still have the waste heat generator that does cool that, but for what it's worth, that's a separate one that's just right next to it. It's literally like it's the same waste heat generator radiator. It's just this one is separated to the car one by like a little separator plate, because I don't want that to actually get extra heat, and I have a little insulator area, a vacuum insulator area. It'll still warm up, but it's not nearly as much. It'll still cool it off. Yeah. Anyways, that sends that into that. It works off the same hydraulic fluid pump of the starting motor. All right, which now no longer needs to be there. It's still there for redundancy if it fails, and it senses if it fails thanks to the O2 sensor and so on, and the exhaust. So it's like, oh, it's running a little too rich or something. Something failed with timing for the pump. This will kick on, effectively. Is what the programming is. You don't get that with the mechanical, but you get what I'm saying. Now, as a result of that electric motor having incredibly high horsepower and torque and good efficiency, really strong efficiency, and it's getting sent all that energy from our engine, from the transmission to it then goes into a transfer box. Now this transfer box is for some people it's a shit show. To other people like myself, I think it's a work of art and it's amazing, but it's still not like a perfect one. Yeah, alright. It has hydraulic fluid in it, so right off the bat you probably think it's a turbine setup. It's not. Alright. If you know about the wavy, spiky crowns that kings wear and queens wear, it's a similar type of design, except it's curved concavely And then it happens, okay, to have teeth that are shaped in such a way that with the direction, so this one's going to rotate at the top, whatever direction it is. The teeth that are connected for the other two that are also shaped the same way, now they can join at the bottom. So like it's a triangle. They don't have any need for any balancers along the sides. So now it's much more compact. It has hydraulic fluid, but it pumps it around, but then it'll never go towards the center because the teeth are shaped in such a way it'll pump it back out and it'll rotate it together with the rotational direction of the gear teeth. So which is a pump, but it conserves its energy, lubricates, and also cools to the outside box, which there are some heatsink fins. The housing of the transfer box is comparatively much smaller now, and it's shaped with that little parabolic spike that helps with the teeth to help with that pumping action and rotation action. Now it's much, much stronger, much less weight. The teeth are not a... So I have to describe this one. Think of it like a sine wave with those spikes. Alright, so they are not just a circle gear with some of these teeth shaped like that. No, it's actually a thin, but still fairly thick metal that's shaped like that wavy crown spike with the concave, and then the others are, of course, appropriately shaped to allow for it to grab the teeth of the main transfer teeth gear and be able to do so as they slide. So they can pivot, but hold your horses. I also have a cone attached to that as it's straight out. So it's like slightly curved, but then so it's straight out, so it goes off to like vertical, all right, 90-degree bearing areas for where the axles to the front and rear for the van are at. Give me a second. All right. These can pivot because they have a cone tapering point with gear teeth along with the axle that transfers to the front and rear as well. They can slide in and out, and so the transfer gears here for the transfer box can pivot as well as the axle being able to pivot as well as changes gear ratios. Then we have a similar design for the front and rear, but they are, of course, able to move much higher for larger amounts of suspension travel. And then you have the joints, which are now, instead of those types of crown joints, we are using ball joints. So like, think like our leg. They're like a ball joint that has a bunch of gear teeth that then goes to where the bearing is for the wheel. So it transfers it to the wheel, but there's a bearing, and you have all the rest of it, and it's a ball joint, so that way you can pivot quite a bit more. There's still a degree of frictional loss, there's still all that stuff, but it's less weight and now far stronger at being able to have massive changes to suspension travel without it having as much weight being there. There are some caveats because it's not just a sine wave. It does have some, parts in between, to connect them, so that way it doesn't bend or break as much. And it has to be able to be attached, very much so, in a way that allows for it to pivot that gimbaling kind of style of way for the seal bearing area of the box. So it's like a double bearing that allows for gimbaling of this thing. There are attachment points in between the sine waves and like arches effectively behind those. So like little arcs. And that allows for it to become much less weight, but much, much stronger, handles a lot of torque in it, and it can transfer things much more quickly, especially once it gets up to running it in even a small amount, because then it'll engage like a clutch as the shafts move and then attach at their highest point. So they'll move over slightly, the highest gear, and then they'll go down to a lower gear. But that also allows for suspension travel changes that normally wouldn't be as much as something that you can do, which again, yep, you got it. It's torque vectoring. I have torque vectoring now as a result of the shafts changing their their gearing and their area of where they're attached. Because that also goes to the ball joint kind of area. So it's like I have a bunch of gearing changes which allow for me to make torque vectoring changes. That's how I got around torque vectoring issues with plates, because plates, everybody does them, is what you'd probably think, but actually it's really just because I was afraid that they would break, get overheated, the clutches wear out. I didn't like that. So I was like, well, a tube and some gears, that works. There is a golf ball style gear, like a, kind of like CVT, that can help change its gearing even more, but it's usually gear to gear for the cone gears. But the golf ball can help alter that torque vector even uh, larger amounts. All right, so now we're going to get to the camper setup. So we still haven't even gotten to that. But now you know the power drain drive, which, the side note, the internal roll cage is also suspension stressed to itself. So it has cables inside that then get torqued to both the suspension and the cage and the body to help not just with roll, but also if anything happens to bend, it's less likely to, because it'll be resisted against that cable suspension stress. Okay. Now, in this instance, I decided to have a basic, cooler. Okay. And that's we had some solar panels that we can roll out, some windmills that we can pop open, and a couple of other things like this for setting up a nice little base camp, and then gaining some solar and wind, and then redirecting it, and then even truly, like funnel, like a Darwin funnel or whatever it is, where it's like that, and then it goes up, and some other camping supplies to help with the whole thing. Okay. We have a plate that we use and a fire thing that we use. So it's like this little windmill turbine setup. I've talked about this one real quick because we're gonna get to the camper setup. This will be super fast and quick and easy, and you'll be like, oh, thank goodness he's done. All right. So we have this little windmill setup that produces a very fast flow rate that then turns and creates a large cavitational vacuum in the center. It's kind of like that skip over effect I was talking about. But it sees that at the front funnel area where it's trying to funnel air in, but it skips over. It's designed with valves that dynamically but are based upon the vacuum inside to change, like vacuum tubes, its placement to allow for that air to skip over and not be captured nearly as much, if at all. Okay. Now, great flow velocity, and it'll keep running, and you don't get as much torque though. Right? Everybody knows that, but the reason why I did it was because it'll keep running for a really long time. And if you do it right, you can actually get thrust from very little amounts of energy added in. All right. That's what I did it for. As a windmill to produce with amount of water captured from the air and some waste heat generators, it would thrust air using a thermal siphon and vacuuming effect to produce a increased velocity and capture of energy from a different source using solar panels and geothermal as waste heat produced into electricity. That's how I designed it initially. This is not what this is for anymore. I now have just a big, ginormous, fucking really torque heavy monster, bladed windmill that's short and squat. But starts off at a singular point, breaks out, and then it goes off into an elongated tail, teardrop. Instead of the opposite, where the teardrop point is where it starts off and then it goes up into the final diameter, this one's very much the opposite. It's the blunt and then trails off. The reason why I do this is very simple. It forces the air to have to travel longer distance, just like for the point pointing forward, but this one is I'm trying to use that aerodynamic effect boundary layer in this instance to create an onrushing air current. All right, like that Bernoulli's and Ventruli's, because it's going to travel faster along those tail areas, and then that goes off into this smokeless fire, like it's only the size of a large frying pan area, okay? But it's a gasification and other things, so I'll have to describe it real quick. All right, so it has a little air separator from that top, and so I'll try and suck air out, and as you light a little bit on fire, it creates convection currents, right? But it then gets spun around, and it creates these little rotating and vortexing convection currents that heat up a central area really hot, but it makes it in a vacuum. So there's a vacuumed, really hot IR area with a bunch of wood, of course. It eventually gasifies that, and then it'll take that and it'll add it into the rotating convection burn areas. And then eventually you'll be left with some carbon, little nano carbon, as you produce some amount of charcoal, coal, the coke kind of stuff. As it'll slowly have no more gasification, it'll have mostly just carbon left over, and it starts to break down and fray as little particles that go and then get captured, sucked under as that vacuum finally pulls it through, and then it'll go off and get added into with that air as it forcefully creates a greater and greater degree of vacuum with a little bit of that heat energy, okay, which is not about the windmill at this point. The windmill is just like that's already capturing energy, charging batteries. It's got solar panel like little shrouds to help it to do that sort of effect. And normally it's, if we're on, like, let's say top of a mountain or a hill, we'll put it off to the side and we'll try and capture as a funnel up into this little area. So that way it gets more pressure and it keeps itself going for longer. This is typically all it is. Anyways, that gets funneled off into this little gasification area. That then has a diffuser, as of course that's hot air that wants to then, go somewhere. It's pressurized effectively. Well, this little pressurized area is quite a bit different than normal. I take in air from the outside because it's hot, and I erase it as that pressurized air. I'll talk about the acetylene. This is how the acetylene thing came about. Okay, so like this nozzle for the acetylene came about from this, and I'll talk about it later. But it's shaped with, again, those little Lorenz style channels and grooves in a concentric circle that helps with a boundary layer. So it like has like a Tesla valve on the boundary layer, so any of that pressure that comes backwards will get rebounded back into the flow of travel that's in the inside area of the tube. All right. Now, in this instance, I have that going in together with the air, and then they combine, and whatever extra may not have burnt in those little vortexes now burns in that, creating a much faster flow rate. So it's another version of the Tesla valve boundary layer thing, but in this instance there's a little lip, there's a little divot edge. So it goes in, it then has this little pinch point that's slightly right there just on the outside. So it's like it goes in, then it has this little ledge just past where it'll super velocity flow. So there's this little basin area right here that's never going to really ever have any gas. And it's trying to travel to that, but it's traveling too quickly with too much mass. Okay? So then there's this little ledge right there. It's a little ring ledge that then has a series of stators that go in, all right, that are shaped just like a elongated teardrop. All right, so they're points that then are bulbous that then go and taper to a really elongated tail, but each one of these tails slowly diffuses into each other. And the reason why is because it mixes and it creates a very laminared flow characteristic that burns, and should do this consistently, burn all possible gases together. Okay, but because of that little lip, and this has a another version of those little vacuum tube funnels that go off into the air intake area that adds itself to that rising air that still has some stuff that might not have burnt. Okay? Alright, now that means it will mostly, if not completely, skip out of that once it gets up and going fast enough. It'll skip over, it will not go into that vacuum, but it'll think that it can get in there, and it'll curve in, and it'll produce a faster flow characteristic and a more controlled flow characteristic and mixing characteristic once it's into that nozzle, because those will channel into these little wicking, like a carburetor jet areas that go into these little fast flow moving high heat areas that then blow air into it and then go through the little nozzle, and then it goes off to the diffuser, which then is also with those little concentric lines, circles. In this instance, we're getting double helical spirals. Well, I actually use 8, if you don't know. So it's like those little rings, like circle channels. So I use 8 of those that are slightly diagonal to act as 8 helical spirals, corkscrews, that kind of thing, that then allow for that pressure wave to oscillate and then rebound and create a vortex that then gets channeled into the central fast flow area that mixes and moves this gas around very efficiently and effectively. And so it's now phased and laminared and vortexed, and all vortexes will combine together into one singular outflow fast laminar flow vortex that then slowly opens up. Alright? The reason why I do this is because it concentrates it. We don't really get much thrust. You're not really going to get much thrust out of that. But I want to concentrate this into, this is an insulated tube now that goes into this heating exchanger plate. So remember my waste heat generator? It's like that has all those little, when they're standing still, I don't need to have my fan on because they'll move air for me with that pump, and it creates electricity. And so I lose a little bit of efficiency for moving air, but then I gain a lot of it back because of the mechanical stress of a piezoelectric diaphragm using that Stirling effect. So that also helps create the acoustic pumps that draw heat out. And so like this gets pumped a little bit. It then has a heat exchanger at the bottom of the plate, which is a standard little snaky line, but in this instance I can section it, and you should wait for this one, because it's insulated, alright, but it'll go off into a tube that then exhausts everything, okay? So that means I can get some of that electricity back from burning wood, which also helps improve the efficiency of the windmill. But that's not actually what this was really for. If you don't know, you're gonna love this. This was not for anything other than cooking and producing a little bit of electricity while I do it. So it's insulated, but it can be broken apart. It's vacuum insulated. So there's one area at the bottom, and so it gets spread and diffused into all these little channels that then do a little U-turn, and then they get diffused like an air hockey table through a series of little S channels, which aren't really S channels. They don't go back down. They go up, and then they move over, and then they go off into other channels that got up and then over. And so they all flow out into a bunch of little tiny holes. The caveat being here is that on one side, your side, it's trying to suck where you're supposed to stand. It's supposed to suck in some air, because while yes, it is cooling with the waste heat generator, it's still very, very, very hot. Extraordinarily hot gas. And while yes, this is built for it, it's steel and some ceramic. I had to answer this. Alright, so back at this. The call was rescheduled for later. Let's see here. That's quite loud for some reason. Whatever the hell that was. Oh, that was my phone calling. Yeah, someone calling me on my phone. That's what it was. Alright, so my dog's quite wet after the rain got him as he had to go potty after I rescheduled that. Let's see, where was I? Right. The air. Right, so the air is coming in as a pressurized fluid that is flowing quite fast, but it's diffused through the plate. So the plate first has it such that there's stuff on the bottom and then stuff in between, slightly above that. It gets diffused through a bunch of little holes that then go towards the top. Alright, and then they diffuse. Now the reason why is because I have water in between each of those spots, and that allows for me to, perform the heat exchange. Alright, in this instance, they can be sectioned off in such a way that as it first comes in, it's not really going to get a lot of heat. It'll take a while for it to transfer that, even if it's a thermally conductive ceramic, yes, but it is, and it's, got the kind of triangle heat sinks of a steel, right? Well, it's steel. It's made out of steel and ceramic, like I said, but it's got triangle little points with the ceramic, and water has to go across. But I said it snakes before it leaves and dumps it. Anyways, it's insulated with vacuum insulation, which is a whole other thing. So it's it's got an outer shroud to this, and then it'll go off into a insulated, again, little reservoir off both sides, and then connect into a central little exhaust port, So that way, it's fairly high flow. It's just not very practical for most people, I would imagine. For me, it's very practical because I'm using this for heating with a waste heat generator with that pump, and then that pump, because of a thermal siphon, it'll heat up and then create its own version of steam, and then that'll be used to drive it. And as it's cooling, it condenses the air as it turns, which helps it turn, and then it's not going to have as bad of a time with that turn, because it's not a full 180, Like there are multiple sections where it like just sort of divots, but then it does turn over at the end. And so like it'll combine into like the same flow area path, but like that finally diffuses off if this uh, outer shroud that's the vacuum insulation area is removed. So like this slides out, then it goes off to both sides, and then those are then turned into an eye shape. So they get angled out 45-degree angles, and they have these little screws that you push down a little foot that makes it so it's level. You should really level this because you're going to want to really level this. Even if I have on the right side, this is how you know it's the right side, although it's pretty obvious before anyways. Anyways, that is where the there's like a little lip, like it's curved up just a little bit at the edges. And like that's the side that you cook on, because then everything stays inside. But you want it level because you don't want it to fall off one side or another, and you don't want any heat warping issues, and that's the reason why like it has all those little triangle points and all these little holes and shapes that allow for it to become very rigid, structurally sound to heat, but it also makes it pretty easy if it happens to get pretty bad. It'll break, it'll crack. Now the reason why I have air coming in the side you're at, first off, don't want the heat to radiate out to you. Second off, that heat gets diffused together with the rising current that's diffused through like that little air hockey, and then a good lot more actually just exhaust towards the opposite area of where you stand at. So like that's an easy indicator if you're doing it wrong. Why is there just a bunch of hot air blowing in my? It's like because you're on the wrong side. You gotta go on the other side. Because it's gonna get hot enough that you can feasibly get burned, that kind of thing. Anyways, air gets sucked in through that middle part instead now. Once this opens and slides open, okay, and so it gets moved in between channels that now opened next to the hot air channels that are now there for them to go through, and then diffuse with it moving up further past, and then breaking out into all the little air holes. The other air is both warmed up, but also helping cool and join in with the diffusal area using good old Bernoulli's principle. And the reason why we do it is because oil and fat and salts and sugars will go into those little holes, and so it'll burn those. They go to a very, very high heat, and the reason why it's shaped in that type of diffusal pattern is it'll drip off, and then it'll burn with the rising hot air that now has extra hot air that's now able to oxidize with any of the other, chemical compounds coming in, with a bunch of IR reflective surfaces, essentially, that are there, which is just steel and some ceramic, but you get the picture, like it's going to reflect IR and bounce it around in there. So it's then going to have that come out as beautiful, wonderful smoke, great smoke. It also means that you get the Leidenfrost effect quite easily, because these are kind of like micro-sized holes. Well, not really micro, but they're still quite small. Anyways, they're not air hockey size small. They're much smaller than that, and they're a lot more numerous. And there's a layer. There's one whole layer, and then there's like one that's slightly off to the side next to it. So like below and off to the side, but they're like on top of each other, like a lobster tail. That kind of thing. So like they'll diffuse more easily. I know, it's a bunch of stuff to conceptualize, but what it means is it cooks really well, transfers heat really well. You got convection and conduction heating, and I'm still getting some of that waste heat out as electricity, which helps potentiate my windmill. Finally done with that. Whew. Takes a while, but it's a really good cooking device. You should do it because basically it's a really efficient gasification campfire type of like thing that you just stick some wood in. You eventually light it. In this instance, most people tend to just use light or electrical resistive heating. So, like the standard magnifying, that kind of thing. Anyways, that goes off into, and that's why that tube is insulated, and that's why it's like shaped in a very specific way to help it diffuse off into doing this, so that way you don't get burnt, and that's why there's a little bit of a funnel there that helps force more air in with velocity and all that for this effect to occur. The reason why you sacrifice the efficiency for your heat exchanger for this is cooking. It's a cooking, it's a really efficient cooking device. It makes me electricity while I cook. All right. So, that's done. We have, I forget how many, but the plan was for me, a couple of wives, because I'm polyfidelity, and some kids to travel in this thing. So I want to have kids eventually one day. You know what I mean? So, this is a folding and then sliding in on itself cage design of a high suspension travel hybrid 49cc with a radial axial flux, but this one's a little different, or axial flux engine. This is an opposed piston. They use, in this instance, we're not using the hydraulic fluid or any of that turbine stuff. Instead, it has a piston that goes into a chamber that is the, let's see here, it has a degree of air at the top. So now it's a pump, but it has to undulate to be able to do that. And so like that's its pump, but it has gears there, of course, that transfer the motion energy back and forth into the main area at the front, or two plates effectively at the front and rear, depending on how you look at it, top and bottom, because it's a cylinder. So what do you want from me? Anyways, it's air cooled. Okay, and those arms then are at the top and bottom, and so as they rotate, they'll rotate the plate. So like they'll spin and rotate the plate. So they'll go up and down, and the plate is what then rotates the center ring gears, which are counter rotating, which are, of course, there as well. There are valves, but also they are there because the plates need something to not ultimately, hit the side of the cylinder wall. Same thing with the outside combustion zones, because like it's perfectly straight now. It's oscillating back and forth perfectly in center and line. So the connecting rods and the piston heads are very much made in such a way that they are helping seal that area. And you have intake and exhaust valves. It's two-stroke, so two-stroke scavenging on center and outside timed with each other. So it acts like a one-stroke, single cylinder 49cc. The undulating pump areas on the outside are attached to air pumps that are on the outside that then feed into a ram air that's at the front. So you lift it up and you click it and latch it in and you screw it in. So like all of this the tubing here slides in on each other. Alright. So they have these little like asterisk, patterns. They're not like a part of the diameter. They go all the way to the center and they slide in on each other. They're thinner diameter tubes All right, thinner wall tubes, but because of this supportive structure on the inside, it means that they, once they latch, and then you turn them a little, and then you slide them in, and then there's this little ring nut that just slide onto each other, or you slide on, and then you thread it, and you torque it down, and then it's stuck together as a really strong piece, one whole piece. All right, there are cables in there too that run through this length, and then they go to a central area where there's a epoxy, flexible epoxy canvas with some plastic that's got like, it's hollow, so it'll bend a little bit, but it's very hard. So, that's its bottom. Instead of needing a, plate, skid plate, I can use this as my skid plate. I then have like our spine has a curve in it. I have a curved arch at the front to the front area, and then like a rib cage, these little ribs that are sleeved with a spring and shock. Okay, and those are our door handles. Because if you ever roll, because it goes above your head in your seating position, and that goes over that, and then has this. That way, if you roll, it's less likely to get stuck, and it'll roll back up onto its feet because most of the weight is on the bottom. The chair has a bunch of little, so they're made out of ceramic with some Kevlar and some fiberglass bladders that surround an outer housing that's ceramic, and all that. That helps it be tough on the outside but hard to puncture the gas bladder that this is for the back seat and then the bottom of the seat. There are some batteries underneath the seat, the batteries towards where your feet are, and some batteries towards the rear. There is a series of 3 CVT gears, so packs. So there's a CVT, CVT, CVT. It transfers its energy front and rear. Alright, it has about a foot of travel. I think it has a foot of travel for suspension. The wheels aren't super big. They don't have to be. I don't care. They still have torque vectoring, all that. The radial axle flex is kind of like a regular, but that's the flywheel. So when you start the engine, the flywheel, then will start to engage once it knows that it's moving, and the engine has continued for a while. The outside undulating air pump here is you guessed it, supercharger. There's a ram air intake for where your what's it called, steering wheel, axle is. Well, there's a ram air there, and then there's basically just firing in air hoses with a little heat exchanger off to the sides where your face are. So, like, there's an air to air there, right? That good way to put this is the air goes off to the heat exchanger, all right, to the sides of your head, and then it goes back down, and then it goes off into the ram air. It's port injection. I only need so much in terms of an injector because it's still 49cc, even if I have that. But I need 3 injectors, and since it's in this instance mechanical, right? Because I have an air pump, but it's like I also have that top part or forward part, right? Because that gets sent off to the transfer for front and rear. I still have the gears for front and rear, and a degree of torque vectoring, thanks to that little slidey axle thing. Anyways, it is a bunched up, heavy piece of kit, but it's not that heavy. But it doesn't take up much space either. And then I can open it up, and then now I have a nice little go-kart ATV thing, right? That allows for us as a family to go race around wherever the campground is and have fun doing that instead of taking the big van to do that. So I have a few of those, and you can always torque it, more, the little nut bolt thing that slides and holds everything together. But I, 15 foot-pounds is more than enough for like basically everything. And other people wanted to add like a super charger or like a super turbo, so I'll get like a super, yeah, like a turbo kit, and I'll try and do that. I didn't really feel as though it's necessary. It has more than enough power, you know. So and it's like, well, it has a stator at the top with like the little belt system they have, which is its version of for scooters here, an alternator, so it can charge the batteries while I go. So it's like that engine, powerful as it is also helping with the electric motor for torque, because it's meant to really kind of go off road and run around and have a lot of fun, And I have a good amount of gas because of the seat, but also battery because of the battery packs, right? And they're protected inside the cage with the canvas stretched epoxy, so that's it's hard canvas that's not going to rip very easily, but it's flexible as well, along with the hard plastic that's right. It's layered, so it'll bounce a little bit. It's got that little flexible, but it's hard, so it's if it goes through that, it'll hit the plastic. You know what I mean? Yeah, but I still have things to the seat. I have to connect the seat there, so it's like that's its area where it has its cross members for all the suspension and everything, so it can still be rigid and strong while having that kind of bottom skid plate area be much, much larger as a result. And so you're more protected. That's finally done. Alright, now it's the camper. Oh, thank goodness gracious. Finally got to the camper. Alright, so the camper's cool. The camper's like a little lean-to. So there's there's an arc. Alright, so like think like the thing that I was talking about with the little go-kart ATV. You know? Well, this one's kind of a similar thing where it'll slide out and it'll create a big, long, pretty decently curved little arced tube. Right? Now there's a big triangle that goes over that with a central shaft in the center. Alright? And that goes over the camper shell, which is the tent that I'm talking about. Alright, so there's a tent there. Okay? Now, it folds where it folds right side, left side, and then there's this that then folds on top of that, for all the rest of it. So it's very compact, and then there's like storage underneath, like little, like the Japanese do, where they have these little areas underneath the floor that are storage. So setting the scene and picture, because there's a side tube. There's a bunch of side tubes that come off that you'll connect. It's basically a bunch of cables and some sliding and sticking things together, and some feet that come out and then click in, and then other little supportive structures to the roof rack and the roll cage that's a part of this. So those feet, of course, fold in, and then they fold on top of the tent that's folded in, and then you're starting to get why it's like super compact, but it's pretty fucking heavy. You know what I mean? But it's built like in such a way that the suspension and everything is going to be just fine. You know what I mean? Same thing with like the tires. Like, so these tires are different. They're very, very wide tires, and I wanted a big, long sidewall because I wanted to make them a little bit more round. And so I could get them a little bit larger, in terms of, widened and for its stance, or not camber. I wanted them wider outside of the body because of this. So that way it's naturally a little more stable. So, anyways, they have a great degree of flexibility for the sidewall, and they still have good tread for off-road while still maintaining on-road performance. Okay. Now, the feet slide out, so you're going to first off slide this rearward. The whole part slides rearward. Then you have the feet go from vertical and off to now horizontal. All right. Then you slide out the feet a little further, and then they'll arc down, so that way they can go onto the ground. Then each one of them has a leveling area, meaning they can be evenly, which there are 8 total feet, like a spider, which they are fairly wide, so these go out pretty far, and you're going to see why. Alright, anyways, they level up the feet, shit, they level out all the feet to the ground wherever you might have parked. Alright? Whew. Alright. Now there are structures for the tent here that need to be placed as well, because the tent is its own type of design that rests on a floor for the boxes that we have that are there. There's little crisscross, meaning little box squares. So those then slide forward, I believe, and then these slide backwards. And so that means as you slowly undo the crank, or rotate this crank, okay, those will slide out and they'll position themselves, and then you slide them in and latch them in. All right, it's just latches, okay. Like, they're fairly strong for what they're worth, but I don't expect anyone to be really trying desperately hard to fuck with them. So that's kind of what that is. It's supposed to be really easy to make this happen. But while it does that, it lifts up using a bunch of just nice little pulley lever action with there's an air spring in this thing with a cable that we help it out to also lift up the big, long triangle. It's supposed to, like, at first you think it's going to be a lean-to. And it's like, yeah, no, I mean, that's an easy way to put it. Right? And it started off that way, for what it's worth. But it changed. So, anyways, that goes up, and the arch will slowly unfold, and then the cables for the other, because like you have another crank that you have to rotate as well to tighten those cables. There are these other little arches, tubes that will attach from that, very circular long arch to these other circular long arches that then attach to the triangle in the rear. As a result, you get a big, seemingly pretty circular thing, right? It's very stiff, very strong. It's not steel. I use aluminum, so it's a lot lighter, and with the structures inside, it's less likely to have rust issues and so on. So the cables help tighten it, and then you have to just sort of latch them on. Okay. Yeah. Then the other cables that are attached to the tent now, finally we got to the tent, drag it up, and it's kind of like a circus tent, but it's a big dome at the top that's attached in multiple spots. Then it's a circle that then goes and concaves towards the center and then flares out at the bottom. Alright, like an hourglass. Yep, But then each section, so there's 8 sections in this, has what is the equivalent of a foot diameter little circle that has a cone shape for each one of the for the sides here, heads towards this foot diameter circle, and there's 8 of them. It is a very large tent. It's a 15 adult person size tent with the option to add on little hammocks for 6 more adult people to stay inside of it. Anyways, those little cones make it so it's very rigid. It's a 2-part tent though. There's an inner tent to the outer tent. It is layered with the outer tent having a lot of reflective surfaces to insulate, and it's opaque, so light coming out from the inside does not go outside. You cannot see what's going on the inside. The circles there are meant specifically to put in a lens. In this instance, the lens, phaser, you're getting in the way, is a composite material of like acrylic polycarbonate and whatnot that is heated up and layered together. In this instance, it's using a few holes, little funnels, wider at one side, smaller at another, and so smaller where the light coming in is, and then wider where the light's coming out. It's shaped with regular lensing effects, using curvatures, but then Lorentz kind of things are also going on, like the plastic and the little concentric circles. But then we also have it's a dome, so it's a dome lens, and that makes it so with the added, because yes, there are added things. Uh, there's a cone here. Why wouldn't you use the cone? It's like, you got it. There is a cone there. That is exactly what I'm going to use. So, I have, let's see here, a plastic lens reflector thing. So, it's not plastic. I think it was, yeah, it's plastic for sure, but it's, what was it called? It's got multiple materials. We said materials, so it's just materials. I know it's like, cause there are multiple different types of materials that do this, and so it depends on what the expense that you want to put into it ultimately and what you get out of it. So we try our best to capture a lot of microwave and IR. All right, and then we're gonna have, because it's layered with multiple reflectors for that, so not just natural light, but like with a standard mirror reflects most light. Well, some will still go through that, and so there's layers of other mirrors, and they have the correct little holes and slots, and of course the mirror is shaped with the right focal lengths, and you get the picture when it comes down to it's coherenting that reflected light, but also constructively and destructively interfering that light to help create the IR and microwave energy instead of natural light. So we don't want natural light, we want the microwave and IR. Natural light's already going to be more than enough, trust me. So that whole cone is then all like the pressure wave thing that I was talking about, like those little concentric little Tesla valve boundary layer areas, right? Same thing. It reflects towards the lens in the center. Then the tubes that are the exoskeleton thing, cage on the outside, hook into that, keep it stable. And there's a little like string effectively that you're supposed to hook these to, and then like you'll tie it, and then like there's like a little O-ring, and then you'll zip it, and like they'll stick the lens there. Okay, but we're not done, because like it's also got these other lens and reflector things on that are supposed to attach to that too, that kind of bloom outward and then capture some of the reflected light that's still going to reflect, and then still captures the other light that's around it, and lenses it towards this lens. So it's like a 5 foot to a 1 foot, is what I said earlier to myself before I recorded yesterday. So, anyways, I got that one set up like that, but like for what it's worth, it's both to convert incoherent light to specifically help it pass through this lens, but remember that whole two-piece part? Well, air's traveling from the rear bottom part, and then it goes up towards the top, and there's a little vent at the top. There's these little hooks and rope cable things that hold plates and pots and so on. But this is a little different. So that lens goes to a little reflective tunnel. It's a fiber optic. For what it's worth, it's a fiber optic. Air passes through and it goes through this, and it helps cool it off both on the outside but also on the inside, so that way the plastic doesn't melt. Now, this one's a tapering point series of fiber optics. So they're very large, and then they taper to like this small thing that's only about 3 inches, and it's a bunch of little tiny fiber optics. They have a bunch of little reflectors with the reflector part on the outside, the housing tube, that then flares out into a diffuser which amplifies with a given material the light coming in, natural light, and the IR and microwave. We're looking to create more microwave and IR. So it diffuses it from that 3 inches to 5 inches. Okay? Then that sticks into these various holders, effectively. You know, that hold pots hold various flat, grills and so on. And they have electricity that you can push into them too. Okay, so they have electrically resistive heating. They have little air holes that are in there to help capture some of that heat and push it in. But this heats up, it attaches, so it attaches to this, and it breaks out all the things into fiber optics that then shoot it towards whatever pot and or pan or girdle, because I'm sure you could even do it with a girdle, whatever, rack, so on, because girdle, rack, engines, anyways, you wouldn't get it. That is a way to heat it up. So it's like it heats up both the sides and the bottom of the vessel that you're trying to heat up. It does pots, it does pans, it does the whole 9 yards, kit and caboodle thing. And it sits in the center, and you're able to all cook together. Because we have the little storage parts, which we cool using an IR. So I have an IR emitter, and I have a little pump that then emits IR, and we use a little acoustic, which I didn't talk about, but the IR is mostly just for like air coming in and cooling it down, right, during the day or night. But for this, because it's insulated, I don't really need it to run all that often. It'll run off of the cooler. That's for the AC condenser that I have for the cabin of the vehicle. So it'll keep that cold. But that means I have all the pots and pans and dishes, but I also have all the food underneath. I have a screen that we put up that we can then all watch anything projected to it. There's a little hole at the bottom that goes to the cabin, and then we have the vent, and so normally that's colder because we ran the vehicle for a little bit, and so like I'll take that air, and then I'll have that suck in air that's colder, and then takes out some of the heat. there's a little bunch of diffusal holes that are on the inside of the tent, okay, with screens. Everything has a screen. You have no idea. I hate bugs, so everything has a screen. The outside little funnel jackets that are in like a ring come in, they have a screen. That screen then goes into little holes that are screens. Screen holes. Yeah. Those are wider and bigger at the bottom, but they're not as many. There's a mid-centric area, but that one has, while they're slightly larger, there's very few, and then there's a bunch of little small ones at the top, but they don't go above a certain point, and they're all angled inwards. I then have a vent area for the little vent that's at the top that goes all the way down to where we cook for our cooking area. That sucks in air and it blows it out. It's made out of material that's able to handle, it's hydrophobic, lipid phobic, and anti-static, but it's plastic, not ceramic. And it's able to be cleaned pretty easily, but it won't really ever need to be cleaned. So, um, as a result, it can just fold in and pack in, and it's easy. It's always kind of there anyways, so I figured why not. And I have little screens that I can open up that you have to unzip, and then you have to zip up the screen. Right. Yeah, I know. It's like, those are your windows. There are no windows. Those screens are your windows. Apparently, they don't count as windows for some people. I count them as windows, whatever. How'd you do the undulating air pump? So, one side gets squeezed, the other side gets slightly bigger, and then it constantly rotates that for the engines on the outside. As it goes backwards and forwards, it then, of course, moves it in a oblong elliptical that then transfers its energy to the main flywheel plate, basically. Or, well, crankshaft area is what you would attach things to, because it's kind of like a pulley, but it can also act with a clutch. It's like that attaches to the electric motor, radial axle flex, which I didn't describe that one, but it's really just the one plate design, right? And then it's just the standard PCB thing. Okay, so it's one plate and then a PCB, and then same thing with the internal axle part, and then like there's a clutch to that. So like that's attached to its plate, but then there's a clutch that slowly, as it gets going, and like that adds in air. I have a supercharger. I have this, all that stuff. So it's just like, I don't think a turbo would be worth it, but like whatever. Yeah, to each their own on that. That kind of thing. But the reason why I did it is because it's really compact. You sit above the engine. You know what I mean? And so, like, all of that's really easy to be compact, and then like that means it's easy to transfer everything off to the wheels and have them have really big suspension travel while still having your skid plate. Yep. So, anyways, this is a 15-person full like adult, and I'm not talking like they have to sit right next to or lay down right next to each other. I mean, this is a big fucking tent. Okay. It's a huge boy. It has a bunch of cables and suspension, spring stuff that's effectively like inside of it. That means like you can rest against the side of it, and all you need to do is attach this little flap with these hooks, and you'll be able to like have a seat. You know what I mean? Or you can just sit at the tables that we have, but it's pretty big on the inside. So I was like, all right, I'll have my cake and eat it too with my family. You know what I mean? Yeah. And the IR is just a bunch of for the incoming air. That's all that really is. So it's like there's a little snaking thing on the inside, for the air coming in. So the inner tent has a bunch of little tubes that snake throughout it that are not where the air that's coming in is. Right, so it's on the tent and then it has to attach to the outside. Right, so there's like little crossover points. So as the air comes in, it'll get cooled off and it'll cool off the walls for the little IR emitter. Because I'll only need a pump, so that'll work. Right, then I have let's see here, electricity from the battery bank, and then I still have the engine and all that. Yeah, right. Yes, no, and then extra food below. Yep. I opted to remove the one pot method for that kind of thing. Instead, we have like a little compostable toilet that you can like take out and then stick somewhere, and then like, shit and piss in there for what it's worth. But most of the time, like you could usually find a tree or whatever. So, well, yeah, we got toilet paper and all that, but we have a little dig a hole, fill it up once you're done, kind of thing. I get it. Yeah. So and that is the van camper concept. That's right. I didn't do any fancy, was it sound systems or anything. Although I do have this like little arc thing that you can build, and so like it'll be positioned with a little triangle, and then like you move this little arc over, and then the two triangles then support the main big arch. There's some suspension. You put on a bunch of these little flat styles of speakers, and then we have a little screen, and it's meant to party and have fun, or video game or watch a movie, that kind of thing. Screen projector type of thing. And they have lasers, flashing lights, fog machines. That's sort of a thing. It's not that hard to like kind of compactify that and fold it all up into one little tiny thing. I can shrink it, and yeah. But like, there's a reason why I wanted it to have a massive amount of torque, with a lot of it like kind of as low as I could, because I still have that weight up there. And then there's a lot of suspension cable and with the roll cage thing too internally. That way it like really has to all together as a thing move. Yeah. It's quite filled for what it's worth, but there is more than enough space for the kids and everything. It's just a higher, that's why I got the high roof. See, it's like that thing. I can drill out and get rid of some of that with the skid plate for the bottom because I have the roll cage, and so then I still have the floor, but then that means you can sit there, and I still have like space for people to sit and travel with us, right? And I still have that high roof, and so it doesn't feel like it's ridiculous, like cramped style, if you're a tall person like me. Torque vectoring, locking differentials, limited slip if you want to do that too. Lots of gear packs, huge torque and horse power, great cooling, um, and then really good wide tires that have large sidewalls for flex, but they're also like slightly round, so like they can really kind of grip and move. Um, so I figured like that would be the best way to do it. They all have it. It has a lot of windows, so like that was the main thing. Like I had to change those out to like plastic bendy windows with like little structure ribs in between the bendy part. So that way, like that outer window would bend, but like the inside, it's still like tough and strong, and it's not gonna move too much. Yeah. So that way, if it does roll, it'll just bend, and you don't have to worry about that. Even with the front, because the front is its own thing. I have a literal like arch that goes through the and over the window into the engine bay cabin, and then I have its own like little structural roll cage that supports its thing too. Because like it's a van, so it's like that makes total sense to do. Because yeah, with all that on it, you know, yeah. All right, I forgot. I have solar panels on there that I slide back, and then it creates like an elongated tail for that. Yeah, and I think that's it. I think that's basically all I did with that. I forget what else I was thinking about for that concept right now off the top of my head. Been doing this for a little bit, but it charges things. You know, like it'll trickle charge along with the waste heat generated MGUK and a degree of the torque that I want to remove for the DC generator as a hybrid. So it's like if I want to add in horsepower or torque, I've got the engine, which can do it. But most of the time, it's like, oh, I can get 5,000 miles off of just my electric motor, you know? So it's like, that's not a bad way to go about it, but then at the same time, you know, it's like, I like using my engine, is effectively what that is. So it's like, I will use my engine and I will burn more gas, I don't care. Anyways, it's supposed to be like a van life concept where you can legitimately live out of your van. You know what I mean? You just don't have to have a place to live, but it was meant to be like, oh, I still have like for that like triangle thing that I talked about, like it has like an Elon Musk satellite that then attaches to like a Starlink, so I still have internet, so the kids can still and I can still have internet. You know what I mean? And they still go to school through the internet. We can travel over to whatever hobbies and or passions that they want to go for, meet people, still have like in real life schooling too in between. So that way it's kind of a hybrid of all of it. They get a lot more culture, they travel a lot more, they learn a lot more, they have a lot more socialization, they have friends that they still stick with and know, you know, that kind of thing. While I can still travel and live that van life and see amazing sights and go up north when it's hot and go down south when it's cold. More water. Anyways, alright, so finally, the van camper thing has been done. Now we're going to talk about the plasma stuff, TV, quantum foam energy, computer transistor thing. A whole bunch of shit. Alright, so that one is a much different thing. It came about from seeing, I think they call them coronal mass ejections, or solar coronal mass ejections or something, but they're a little too damn big for that. And apparently they're like the star burping or farting. And they create like a hole inside the star, and they're so far only been found in stars our size, the one that we orbit. So there's some ideas floating around as to how it happens. My best guess is like there's an electro charge. Okay, so a magnetic blah 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 orbital thing. Anyways, it'd be chromodynamics and electrodynamics, a breakdown of those forces to a degree, with a over like increased mass and neutrality kind of thing, and so it would essentially suck out a lot of heat, but it would take a large amount of the electricity, you know, electromagnet as the plasma, the electromagnetic flux here, fields, are created as the plasma moves. And so, my guess is that for some damn reason, which I don't really have much of a clue on that one, mine typically turns into some kind of fissile level of material was already present in higher amounts, possibly in the star. It started forming with towards its core larger amounts with the radiation particles that are there, increases of these novel like quarks and gluonic matter styles of combinations for hydrogen, helium, and so on, or denser elements. And so they started creating a weird oscillatory resonance between the outside, which has a really low heat, but then it has much greater degrees of electromagnetic fields and light obviously escaping, so it constantly tries, and you get your convection current, right? So the neutrality and some of these breakdown of some of these forces start to occur in such a way that it bleeds that energy back into this type of ejection. So it would start to build up slowly, and then within like a couple of days, meaning very, very, very rapidly, it would do like a mini micronova as an injection, which is what they're seeing. Like it's like it basically makes a little nebula, a little tiny nebula with inside of the Goldilocks zone kind of area around the star, and it's kind of like just right within this little area, and then it slowly rotates and tries to come back, right? So my guess is it's like, all right, it's gonna just do like a coil railgun injection with like pressure from the core, but then as it does that, it has an equal opposite, and so it'll force in greater amounts of kinetic as it suddenly has less pressure, and it's going to evacuate a bunch of neutrons and all those particles of radiation and so on with light and heat and whatnot. But what we've noticed for what we've seen when these things have happened is that it didn't really get much colder, and it didn't really seem to lose much energy, like overall. I only briefly saw this, so my guess is if it's like this, you should see and you're gonna have a whole long descriptor till we get to the plasma thing. This is how I work. All right, so a change in wavelength. All right, so like it will still be as powerful, that wavelength, but the wavelength will have dipped down. All right, so the long and the short of it turns into that divot then collapses. As it collapses, conservation of momentum. As it spins, doing that, it then creates a convection current that's a spinning plasma that goes down and it goes back up, and it's convection current. So it's like a helical corkscrew. All right. As it does that, it then starts to produce more fusion on the way down and forces the core to get hotter, and then it bleeds off its energy into the surrounding areas, making it appear as though, and rightfully so, it didn't really lose much mass because, of course, the mass was captured as more fusion and more heat produced. But slowly, that magnetic field flux, because it changes, it produces a big spike in that little area. It'll also divot it on the other side. It then creates like a grabbing sort of paddle as it spins. And I thought about it for a little bit because I was like, well, you could put an like a couple of copper coils, and you get a lot of electric energy from that, right? And then it's like, wow, that's gravitational energy that I can just get from a celestial source, something like that. Cool, right? But it's like, yeah, it's almost irrelevant, and really it came from, hey, you want to learn about something existential? We have no idea why the hell this thing fucking occurs. You remember roving black holes, roaming, all that stuff? This is worse. We have no fucking idea, and if it blasts out, if it's in our inclination, our plane of existence of our orbit, we're dead. Like, the star doesn't move anywhere. Apparently, it doesn't really transfer much of its, force of exhaust of this material for its nebula, because our micronova or whatever, mini micronova or something like that, doesn't transfer it much to the star. It doesn't really move, so it didn't slow down its rotation, and it didn't suddenly change in terms of how it's orbiting around the supermassive black hole. And so it stumped everyone. And I'm like, well, if it's neutral like this, then it wouldn't transfer much of its electromagnetic force or kinetic force except into the core, right? Which would be its version of like, it now has a gun barrel effectively. And so it would then turn into mostly fusion and a rebound effect, and it wouldn't really kick much. You know what I mean? Like it essentially stay with inside the star. It wouldn't actually get more acceleration or kinetic energy from it, which is such a weird one, you know. But that's breakdown of electrodynamics and chromodynamics. So, you know, forces, fundamental forces. But that's my idea of how that works. But it led to, because that, hey, guess what? That existential, we have no fucking clue, and it could just kill us. We would be fucked. It doesn't even have to directly hit us. Oh, we didn't get neutron bombardment or anything. We still burn in the fucking new nebula that's super hot charged particle plasma that we swim through. You know what I mean? Like, here's a nice little existential fucking dread. And we have no idea what caused them. We only briefly caught these things. You know what I mean? Either just before or just after, and we don't know what leads. There's no brightness. There's no change of wavelengths. There's no like extra neutrons. There's no nothing that seems to indicate anything. And then we have only one clue that there's even something like what I said occur, which there's a picture that seems to indicate that there could be a divot in the star. Because if you look on the outline, there's this little divot there. But then there's also like this little, you know, shading that makes it so it looks like it's got a divot. And so it's like, well, maybe there's a divot. I don't know. Maybe there's a divot. You know what I mean? Yeah. It's they've been theorized though back in the 1970s. Okay. We only recently, at the very tail end of the 2000s, ever saw something similar. And our telescopes and so on were not very good. So we're like, yeah, maybe. And then towards the end of the half of 2010, we got a little bit clearer pictures, and we were like, yes, this is a thing. We've confirmed it happens. Fucking no idea why. We don't even know why it does that. Why is it doing a mini nebula inside of its fucking solar, you know, like, backyard? The hell is this? It's terrifying. And they're all our size star. Scary shit. Anyways, I was like, well, just for an instance here, what if we aimed multiple telescopes? So, you know these things called radio waves and, like, you know, LiDAR stuff, right? You know, we know about this. Atacama, like, they're going to go certain altitudes and atmospheres so that way they can correct the lens, blah, blah, blah stuff, right? For, like, you know, better pictures for that telescope in the Atacama Desert. I was like, well, satellites could do the same fucking thing. I could put a couple detectors around. Why the hell wouldn't I? I can see what the diffusal rate and the diffraction rate and all the rest of the rest of it that's there with a few satellites and a few detectors at the ground and so on. You know, with balloons. Yeah, I can figure it out. So it's like, well, if I point James Webb's telescope and a couple others, and we have different wavelengths of light and different depths of field with a large aperture now over a period of time, and then I can then correct for this and then use the phasing as we spin and the rotation with the, you know, even though it's at a Lagrange point, we also have other telescopes that are on our satellites that we can try and point at some of these fuckers. And then we have multiple little, especially if we time it right, those curved light particles in, and we can have our own degree of like focus lenses, like the lens lenses, which I didn't talk about a couple days ago, but this would be the add-on. Or actually, this has been last night. Anyways, that adds its own degree of increased focus for the wavelengths of light that may help us, because then because we know the different wavelengths, we know how they traveled, we have the depth, the travel, the curvature, the diffusal, the polarizations. We can then, and this was the joke. It's like, zoom and enhance. I need to get my enhancement pill, and then I got like the flash drive out. That's the algorithm for this, because of this knowledge. Zoom and enhance. Why is it still blurry? I don't know. It's, I get my enhancement pill. Made the joke about, all that stuff. But anyways, as I was talking to people in my head, they might ever want to say that they were there and we were talking, but if they don't, that's fine, whatever. I'd prefer that they did, but sure, whatever. Anyways, I talked about it that way because it's like, well, this would be a series of scientists, astronomers, that would then do that sort of thing together and plan for it for a given, let's say it was one night or something, and try and use the enhancement pill algorithm flash drive to then, calculate for their given compiling of data, and then you'd have to structure each one in such a way where you organize it with wavelength, polarization, time, distance, and angle, velocity, all this stuff, to then really, really enhance, or zoom and enhance, or really what I want to say is properly algorithmically filter out what it is that you see and have therefore gained as data into something that we might be able to see. You know what I mean? So we can get a clearer, more defined, sharper picture that has multiple angles, kind of like over time a video that should give us a depth of field approach better than we normally can, so long as we have the calculations correct for our rotation of the Earth and its rotation around our star, along with the satellites and everything else, to gain like a better picture of that depth as we move. Getting multiple sources, meaning multiple telescopes, as our Earth rotates, and the satellites too, to be able to produce multiple picture frames stitched together with multiple wavelengths, to be able to understand in a deeper, further in way from the obscurity of various nebula gases and so on, to have a better idea as to what may or may not be happening. Otherwise known as zoom and enhance. I want my zoom and enhance button. I know, huh? Anyways, it would work though. It's a very good way of going about and getting this stitched together. In fact, they could practice with other, like we had the supermassive black hole Sagittarius A star that we tried to do a similar thing. And like if we add in these details, these rotations, the obscurity of certain, and focal lengths, meaning like the interference patterns of photonic light, and the nebulas, not just the gravitational effect, but light pressures as it interferes and destructively and constructively, and then there's the polarizational field effect of that traveling to us, and then the multiple sources around it combining, and then sort of lensing off from its degree of a focal point, and then diffusing as a result, or dimming, you know what I mean? and scattering, that kind of thing. And so you'd be able to stitch together a timeline and then compile that data with these parameters, then be able to work back and then work forward and do it a few times until you've gotten to a filter point where it's like, all right, so all of this actually meant this, and now you have a more clear, more resolutioned, higher detail picture for all of the wavelengths that you were able to capture, and what it should mean for this natural light, what we would see that maybe got to us as a radio wave, which would be great. You know what I mean? And since we already have that data, then this would be a way to upgrade that data's seen picture that we would see without actually altering what it is that data is. We're just upgrading its knowledge ahead of time, and as a result, we can calculate better for a more informed, detailed picture resolution that's resolved at the end of it for how it should display it on our monitors, because that's a different program. It's like Pixel do this because these things, eyes that we have do these things with this kind of wavelength, and it's a bunch of math with stuff like that, and so I don't like it, but effectively this is a version of that, where it's like, well, we're going to try and make it so that way it understands that math better, and then filters, and now all of a sudden it should have a better pictured idea of what it should say and be and look and all the rest of it. It's programming changes effectively, but you got to have that like input of information to help calculate better this information that you have, to then be able to resolve and then filter out that data to then send it into this calculation math that then gives it to your monitor that then you will see. A whole bunch of steps. Yeah, programming math stuff. Anyways, that was like that first part, and that's what led to the TV thing. After we did the whole like it's the paddle, like you could get like energy, but that would also grab the nebula and spin it around and try and suck it back in. But there are always the chances and possibility that any electromagnetic fields or the very planet in front of it, either gaseous or solid rocky, would absorb that too and diffuse that electromagnetic field. And so it would try weakly, to try and move that, but it'd still get some of it. But some of it would still dump as heat energy into the planet, if it's within the plane of existence for that planet and it's close enough, which is a terrifying thought. But I made a joke of like, you bastards, get out of the way, I want my fuel back. Anyways, but the person that was talking to me thought about like making it into some sort of I think an axle or a bearing of some kind. But I was like, well, if I make it into a plasma OLED ball that I can polarize, like switch, because I can grab the electromagnetic field. Because it's like, how do you make a ball of plasma like that? And it's like, you're just making a convection current that's like that spin. Like that spinning plasma that you'd have like a central, like little ball of plasma, then you'd have spinning convection current in one area, and like these other spinning convection currents of different types of plasma that produce blue, red, and green. And so like then you could yank it over, and then you could like shield it and have that light go off to another place that would help with contrast ratios, like an OLED. Which I didn't say that, but that's how I would do that as a new type of plasma TV that would use way less energy, because you can have cold plasmas, or at least cooled off plasmas. So you still have to rotate it, but then you can heat it up, right, to produce brighter lights. But if you oscillate it with the right electromagnetic fields, of the surrounding, encompassing, captured this thing, plasma ball thing, then like you can then allow for a resonance of that light and the oscillation there within, moving it for wavelength frequency phasing as it reflects and then goes off into another pixel OLED. Because like one of these things could be really, really small. They could be nano sized, like very small nano. And then that light can then be transferred over to another area, and it doesn't need to be as hot. So a dim area or a straight up black area can then be used to prop up the light in other pixel areas. It's really just the electromagnetic field. You use static charge and electromagnetic field. So you want a coil helical structure plasma, like a really thin, like 1 maybe 2 nanometer sized, filament of plasma that goes to the core area, which would be, rotating. And so like you'll spin that, and then you'll have it go up, and then it'll go back down, and that's the static charge. And then you can grab the one, because like this is just going to be convection, right? So you'll have that, but this one is you're going to move them around, so like that convection current one, you can move it around, and you can brighten it and then reduce it as to this one little tiny, maybe 5 at most nanometer sized ball of plasma with the convection current. And if you shape the convection currents correctly, because you can push and pull them around, you can both increase wavelengths but also shift the wavelength direction. And so it can go inwards, outwards, it can be pulsed, and so that gives you a lot more possibility of phasing and coherenting and laminaring and lensing of the light to constructively and destructively interfere, creating brighter brights, blacker blacks, effectively a faster pixel response time with multiple angles and multiple different screens within that angle to produce a 3D effect that would never be seen before. It would still use a decent amount of energy, but it wouldn't use that much. Like, it's not super hot. It'd be about the same as a regular LCD, and it's still able to be polarized and so filtered if you wanted to do that too. It's like you can have layers of these, and you can filter it with double polarizations, and then you can still alter it with like the right diffusal lenses and reflectors that go off to one side or another, which would just be light that you allow one area, and then it'll like collect and go that way, which is electricity and light that then opaques and then reflects as a result of that. And then because the light's already bending that way, it naturally wants to coherent and head that direction as a laser, which led to computer transistor thing with phononic styles as well of transisting. So I have to first describe how a pressure wave in a given tube with the correct resonances and harmonics of this oscillating pressure wave create different types of transistors. So there's a little spike wave inside of a wave. So like think of like this curved ball that's a hemisphere, and then there's a bunch of little spikes on it. Well, if you properly spike it in the right way, it then will match another spike wave that's on this other hemisphere heading towards it. And as they pass through, they destructively and constructively interfere and create different spike waves that you can then detect by having it filter through a series of tubes that either increase or decrease based upon the amplification diaphragmic nature of pressure. So it then pushed it a little bit more with the right resonance, and the diaphragm moved this amount, and then other air then pushes in, and it moves in, and then it resonates with this increased amount. Amplification. And now you have a sound transistor. Well, if you use it with light and plasma, in this instance, you then have that plasma that sends light that can resonate with another plasma and interfere and heat it up or cool it off. You can also add in other electromagnetic and electrostatic forces, and then that also interferes constructively and destructively with the light and plasma, and now you have a big computer transistor that you can flip enormously fast, like that polarization for the little pixels that I was talking about for the LEDs, that plasma, which means you can be having that plasma suddenly now be a different type of transistor, or straight up no longer even there and allow it to go through, which means you can calculate even faster than a standard silicon, and they can be very small, these little things, with light and plasma and electrostatics, and still not be super, super hot. But it'd be fine if they were, because it's plasma. Alright, and that's what led that to me, because then we're going to get into the quantum foam energy. So quantum foam, if I stick this in the correct radiator-esque manner, quantum foam, super small, but plasma, super small as well, possible. It grabs in the right charts, separate virtual and or quasi-particle exists small amount of time, heat and pressure, add into plasma with correct structure, like a transistor. It concentrates in a resonance style and fashion, adds in heat, accelerates given particles, smash particles together, hopefully fuse, add more heat, and now quasi-particle fusion, quantum foam quasi-particle fusion reactor. I got the idea from, that's right, you guessed it, AC condensers. Instead of putting tubes together, why not use plasma inside tubes? Quantum foam still exists inside tube. So, still work. And now I have fusion device. Small fusion. Constant never-ending ignition fusion, but fusion that's small. Tiny little itty-bitty particles. Captured hyper-efficiently. Only problem, fiber optic tube inside tube, capture IR, reflector, blah blah blah, and it goes into IR, photovoltaic, and then thermoelectric generating material, and then waste heat generator for convection. With using light that passes through, which by the way, that light, like, I only want to capture certain types, because like certain light is good at helping create light pressure, and then I can then help that create higher degrees of heat and acceleration for linear acceleration, and then be able to hopefully create a moment of time of quantum tunnel for fusion, which is great, but it's a very obviously specific structure that's trying its best to run some of that energy back into it for its fusion, right? It might be able to do more from that given heat for the energy, nuclearly speaking, that it produces, until we hit like atom level. So once we create a hydrogen, neutrons will start to produce a lot more, and so it'll break down way more with neutron degeneracy, and so I don't really like that. So I usually get to hydrogen and I tend to leave it alone. The given amount of energy that it takes is not very high. For what it's worth, apparently plasma spinning that fast can be incredibly powerful, especially with the electromagnetics and the sizes of a quantum foam. And then it's already moving anyways if like Hawking radiation is to be believed, and any virtual particles could theoretically exist. And so as a result, it would like actually accelerate itself by having the same standard Bernoulli and Venturi effect that occurs of there's less here because acceleration and field pressure different here, you want go here, go there because higher, and you attract it because you one big long line of field stuff. Electro and chromodynamics. Yeah, otherwise known as quantum thermodynamics. That's right, quantum thermodynamics. Using quantum thermodynamics, I perform work energy. And I now have a working engine that uses quantum thermodynamics to perform work energy. That's right. I'm going to keep saying work energy because I know that you say it's impossible. It ain't! Fuck you! I'm making electrons. You can't stop me. I'm literally forcing quantum foam to turn into electrons, bitch. Shut up, you! I'm gonna make it do work energy to make my plasma do shit for me. To make more work energy for my work energy because, yo, bro, I heard you like work energy. Hey, you think I need that massless particle to not do nothing? I'm making more work energy by vibrating it appropriately to get more work energy out of it. With my plasma creating electron field shit. That cools it, by the way, if you didn't know. As plasma goes across it, it then reduces by, like photonic release, it's an electron release. Of course, I still have to cool it a little bit more, but still. And eventually it's like, here's some neutron nucleus photon, no, proton, not photon, get out of here. Proton stuff, which is just, I added things together to make, I think this is quark. It's probably quark. It's got neutral quark thingies, it's got, positive quark thingies, or negative, I don't know. It doesn't matter. As long as it's the opposite charge around. Hey, look at my antimatter. Fucking jeez. What? They decide to destroy themselves. So obviously opposite charge exists here. In quantum foam. Look at my negative energy harvest. I now have anti-gravity somehow, because Michio Kaku. Meanwhile, me, none of that's really the case, if I'm being honest. Like, I'll have some degree of negative, and I can create some novel styles of possible nucleus and maybe even atoms, but, like, that's not what the main start of the creative design was. It's like, let's see if we can make a hydrogen. Let's do hydrogen. You got a hydrogen over there? You got some hydrogens? I'd like some hydrogens. Cool off the plasma. Well, Huh. Waste heat generator. Nucleus, proton, a neutron thing. Electrons. Huh. Waste heat generation. Capture most electricity back together. Using exothermic release and transfer Stirling effect resonance and so on. It's almost like I can do this. Why can't do this? Why can I not do this? Why not? Huh? Poke, 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 poke. I'm just saying, in every way it will work. That's all I'm saying. All of the physics says this works. Wave functions can still be grabbed thanks to field pressures. Don't care. Yeah, okay, sure, yeah. Your electrodynamics and chromodynamics says this works. My thermodynamics says this works. Nothing says this doesn't work in the standard model. So what's up? Well, how are you quantum tunneling things? Ah, yes, the good old quantum tunnel. They did not know that it's already wave function superposition, and if I entangle the correct way, then they tunnel more easily, especially with pressures and heats that make it so that way, in a small moment window of time, it is inclined to do so, collapsing in a tunnel-like fashion together. That would work. Oh, what do you know? I have generated quantum foam energy. Look at me. I capture quantum vacuum pressure and foam energy into making hydrogen for you. And more energy than I put in. Although I have to put in energy, by the way, and it will break down. So shh. Shh. Be quiet. It's not. There's no perpetual here. Shh. It makes more than you put in. Yes, and so does the exothermic release of the carbon and oxygen that you put together. Yeah, but that's kinetic potential. Yeah, I don't give a fuck, man. I can still get kinetic potential. I still have kinetic potential. I still fucking. What are you talking about? I still make kinetic potential. I still make field pressures energies as well that literally make the very things we use for the very things that we do every day, which is electrons mostly. And protons. Yeah, well, protons aren't that hard for what it's worth. But they're just charges of the right fucking vibrational crappy stuff. Yeah, well, yeah. Why do you... Okay. Okay, come here. Proton. Okay. Alright. It broke up quark, some gluon. You know what gluon and quark made out of? Softon, bullshit, blah, blah, blah. I don't care. You know what this is? Charges. This is all this is. Spin, align, pull, up, down, blah, blah, blah. Charm stuff, crap. I don't give a fuck. Quantum foam don't have that? My ass quantum foam don't have this. Combine right light, combine right fucking chargy bullshit with other fields around of quantum foam. Next thing you know, I have quarks. I make quark. What problem with... Why not make quark? Put quark together, proton, neutron, electron. Why not? I I like that sudden destruction of them. Like, fuck yeah, that would work. It's literally how our physics says that they come together. I don't. You. God bastard. Meanwhile, I'm like, look at the stars. Look at this, the Big Bang. It created the fields and the things that I'm using to put together this shit. They think I'm getting energy from nowhere. They're like, it's perpetual. This energy isn't coming from anywhere at all. No. Anyways, alright, and that was the plasma thing. So thermite together with oxyacetylene nozzle to increase heat using different method. Finally done with that. All right, let's get this done. So, thermite in this instance. What was the fucking again? The fucking Jesus fucking Christ. We get the stupid. What is this? Periodic table of elements here. Let's see here. So we were using aluminum. Let's see here. Is it carbon and phosphorus metal alloy that's been oxidized? Then we have iodine on its side. We use magnesium with a sodium that has a sulfur and it's been oxidized. So magnesium, sodium with an oxygen alloy compound. Then we put sulfur on its side. We then ignite it, and it burns vigorously and very, 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 very hotly. Alright, so that's the thermite. That's the new thermite, the new hotness. This is the thermite you're going to want. You want these fucking thermites. Alright, so acetylene, oxyacetylene in this instance. Alright, so oxygen is coming out in a ring, alright, to a nozzle of acetylene. The nozzle of acetylene goes forward into the jacket. It goes and hits a spike. That's a, like a fucking spike, parabolic spike. So it goes up, so it goes down, it goes up, and then it goes and joins in with the oxygen. That then mixes. Alright, so there's these little holes, valve areas, where it sprays out, and then it mixes, and then it combines it in a little intake manifold area. Then it has an air spike, curve, little spike again, with a shroud around it. That then goes into a nozzle point, and I'm going to have to describe a whole bunch of this shit, and we'll get into that. So, it's a bell end, but it's not a bell end, so you're going to have to wait for it. Alright, so, the spike happens to have the same concentric little Lorenz, boundary layer things, where they overhang, and there's these little channels, but then they're circles, they're concentric circles that are all trying to head the one direction towards the pinch point nozzle. The shroud is a little different. The shroud is curved, trying to make a bunch of helical, so that it's curved and angled downwards, yes, but it's curved in a fashion where it's a double helical. So a double curve of these channels that are still vertical, but they have these little overhang, curved, circular little overhangs. And so as the oscillations from the air, the oxygen and acetylene coming out of these little valve areas head downwards, they race more and more quickly, and then once it gets to the pinch point, produces this oscillation, resonance, harmonic pressure wave. As it bounces off the spike wave, it then travels more inwards. As it goes towards, of course, the shroud, it'll then curve in, and then some of it will dissipate back into the spike, some of it will dissipate into the curve, and it'll still head always towards this nozzle pinch point. Alright, creates a much greater increase of pressure inside of the spike. We're not done yet, though. It also makes it so that way it flows ridiculously faster, as the spin and bounce is then added into the flow velocity of gas heading towards the pinch point. It is now super fast with a lot more pressure. The nozzle pinch point has 3 of these stator blades. They are curved, kind of like you cup your hand in a curve. They have then a V in the middle of that curved arch that heads towards the center. They are shaped like a teardrop. So bulbous, and then they trail. They are angled in such a way that it diffuses that very fast outside and very fast inside together with a very slow boundary layer, mixing it and diffusing it very much, as well as phasing it in an incredibly powerful, fast way. Then we got the bell end. Just like I talked about, we have this little, with the campfire thing, we have this little ring. So I finally bring it back. So we have a little ring that's an empty space. Practically never have anything get there. Then it has that little divoted in ledge that then instead, before, like it had a whole bunch of these little things on the outside of the shroud. It's this little ledge, and then there's this little bump that is a teardrop shape. So it's bulbous, and then it slowly tapers to the tips. There's not a whole bunch of them, it's just one ring, and then it goes to the end of that point. Once ignited, it then creates an oscillatory effect. That little vacuum, those little, that little area right there, that has its own little bunches of tubes that are on the shroud, which create the little skip over as it sees this vacuum and it tries to go to that point. And if it ever does, it's just going to burn anyways. So whatever. So, as a result of it diffusing, and a result of it going into this, which it doesn't in any way actually transfer much of its forward momentum to this nozzle. It's not meant for that. It's not meant in any way to be a rocket nozzle. Anyways, it expands there as it's igniting. It stops there. It will not go further in. It then seats and seals along the bell end nozzle head. Now, that's firing this oxy-acetylene blend. But it does such in a way where it oscillates really hard with the pressure waves in the housing and the pressure wave of the gas that's burning outwardly. There is a small amount of thrust, but it's very minimal, like you really wouldn't know. Anyways, you place it on to whatever within inside of I think it's about 1.5 inches, 2 inches to about 8 feet, roughly. It will now oscillate, and it'll do this weird focusing effect. So this resonance field in the gas as it's hitting this and then reflecting some of that pressure wave resistance back through this highly laminated, highly coherented, pressurized gas that then oscillates back up towards the bell end and then bounces off the ledge and then heads back in with the flow. And so it creates yep, you guessed it, a pump. I have an thermal-acoustic pump. And so while it's very hot one direction already, it's much hotter than it would normally have otherwise been because I did this. Because it's all very significantly traveling much faster, much better mixed, and it's far, in a way, because we use thermals as random, oscillation kind of like styles of movement, kinetic. But we're talking chemical now and not atomic. And while, yes, it's great when it's, moving around and about, but when it's very coherented and laminated, because of that reflection, it then produces a alignment effect of the expanding gases and its speed there within. So a lot of the thermal transfer hits whatever it's hitting, but then it also creates that wicking, concentrating effect of that pressure wave, and then it also vibrates it very significantly in an oscillatory manner, which, thermally speaking, is really, really big. That's a acoustic thermal pump that I've created. If it doesn't ultimately do that, you probably didn't design it right. But if it wasn't doing anything with that little pump action that we're talking about, it would already be hotter than it normally would be in that 3,000 degree C range. It would be in the 6,000 degree C range. But once it's on its thermal pump, it'll quickly hit 6,000 C by transferring it very rapidly, and then it'll go all the way up to 8,000 C. So it'll keep pumping more heat from its surroundings and concentrating it and then diffusing it to the surrounding areas. The oxyacetylene nozzle. It is not a thruster, sorry, but for sure it burns things. It burns many things. Lots and lots of things. I got the idea because Explosions in Fire was, the YouTube channel guy in Australia was doing a video about trying to melt titanium. And so it's like, well, if you put thermite and then you try and burn the titanium and then you push this fucking type of oxyacetylene together in the right ratios and then burn it in a pumping-like fashion, you'll really get it to melt and burn. Which was not what he was trying to do. He was trying to actually keep it going, burning. But this will definitely melt the shit out of that and burn. That's literally what it was for. And so that in the last little space towards the end before I went to bed and waking up here and watching a few YouTube videos is what it is I have creatively produced in terms of concept designs. Oh, and also a couple of days ago when I was searching through Facebook for vans, and that I was like, well, that'd be really cool if I could do the boom, and that's what I created. Because it's like, well, there's a V6 in this one, and it's a Ford. It's only got 200,000 miles it can go. It's already got over 100,000 miles on it. And they want fucking nearly $33,000. Bull fucking shit it. You know what I mean? It's not even the high roof. And it's like, well, to be able to gain back some of that power, I'd like to increase its duration for its valve, and then it says fuck it. What's so hard about going to a junkyard and getting a basic bitch, AC with a compressor, and then sealing it up, and then charging it with the right fluid, whatever refrigerant there is, right? And then sticking that into the box for the condenser, and then use that with a little couple of plates aluminum or something, and then sealing them over the intake, and then sucking out the air. And so as I got a little bit more, if I put a different bucket on it, I'll get a little bit more duration, and I have to change the timing a little, but I gain back some of that power I lost from the heat that I have here. And I had to take out all the seats or whatever to do anything else. But I can put a couple of jackeries together, with the little solar panels, and get a mini fridge, and some little drawers and so on, and enjoy that. You know what I mean? That's I want to go camp. If you don't know, I want to go camp with my dog, and I want to go travel and live out of my van a little bit, go to conventions and stuff. Because I'd rather not go to a hotel, just because that's expensive and it's kind of hard to deal with it. And instead of a $7 over at a truck stop or something for taking a shower at a truck stop, versus fucking $50-something $100 at a fucking goddamn hotel, and that's if I planned it fucking months in advance or something. I go live out of my van, got my cooler, got my mini fridge. Why not? Fucking works. But it's I have to seal with some silicone caulking or whatever. Right, but it's an intake. It's a way to get around. I mean, there's a degree of resistance, but it already has a filter. You know what I mean? And I just have to stick that, condenser or heat exchanger, the evaporator area, into the front of the vehicle where the radiator is, and that's it. I've got it done. Now I have a version of cooling subambient. Now, is it really subambient? It depends on the size. For what it's worth, and that's all that is. It's it. It's like if I have the right size air conditioner, I can get subambient temperatures consistently throughout the whole time the vehicle's running. I got a little bit of extra lift because it's a thicker bucket, and then I have a little bit of extra duration because it's a larger bucket, and then I have to change the timings a little bit to allow for it to properly, work right. But it was like, this is expensive. At first off, no. Like, literally. What? I only have like 100,000 more fucking miles on this thing? You think that's not much, but if I'm going to be traveling a lot, it is. It's not much. If you think that's a lot, it isn't. It's not much. And I was like, well, for someone out there that has to transport a bunch of people or some shit, like, sure. But it doesn't have the torque either. Like, I want to lift it up. I want to get a skid plate under that. I want to get, like, proper springs and suspension, bigger tires. You know what I mean? So I can go off-roading and camp on, like, some of the off-roading parts. It's not, like, super off-roading. But it's, like, it would be nice to have. You kind of want and need that. Yeah. And so, it's like, if I don't do it, then it doesn't work very well. And so it was like, well, it's a short roof with a V6 that has a lot of life already put onto it. I don't know. And it's only rear-wheel drive. I want an all-wheel drive. I prefer an all-wheel drive in all aspects. Yeah. So, like, that's kind of where it came from. I was stuck just like constantly talking about how I would build this engine and how I would put together a transmission and how I would, and like that took an entire day of talking about it to describe what I had designed in my past in my Chandler house, my parents' Chandler house. That like I'd already kind of like put that together back then as a design. Which is like, why would they listen to you in the past? I'm like, I don't know why. Why do you think? But it's like, well, a rotary engine would work well enough. It's air cooled. I don't want to do it. Like, for real, like, the moment I hear a rotary engine, it needs to be 12 cylinders. Oh, yeah. Gotta have the 12. If it's not this, though, it would fucking suck. Yeah, literally. I hate fucking oiling it. I hate fucking all. Like, there's ways of making it work, but they're all old engines. They cost a good amount of damn money to fucking get. Like, I can get a $500, like, V8. You know what I mean? And it's like, I need a longer stroke to bore. You know what I mean? And those old style iron fuckers do not have the heads, do not have the flow rate, do not have it. And oh, I have to fucking stick it into this? I get it's a van, guys, but do you really know how difficult that is? It's like a rotary's a little easier here. I could just, stick some tubes together and off to the races. I've got it, stuck together. It's in. It's now mounted. So it works though. Yeah, I know it works, but I hate it. Yeah, everybody hates it. Really? Yeah, I like rotary. I think that they should come back, especially if we're talking like anything with a motorcycle. Like, oh my god, motorcycle engines could totally receive an upgrade. Could you imagine a two-stroke, 6-cylinder rotary? Two-stroke scavenge? with my design. Brrr, woohoo. Have fun with that one, right? Zit. There's nothing saying I can't just keep increasing that RPM. I only went to 8K, but I made it so that way the turbo works beautifully for all these rev ranges in there, and it's got so much torque, and it's like perfect for engine optimization and use of gas characteristics. You know what I mean? Because it's like it goes up to high altitude, it goes down to low altitude. It's got all the fucking pressure, it's got the good cooling, it's got all the stuffs. It will work beautifully. And it's like, same thing with that. This is a tiny little compact engine with that little fucker. You know what I mean? I can give it a little bit longer stroke. And yes, while you think it's like, well, you know, it's the equivalent of my inline 4, it's not. Not in the slightest. It's like, it's got a longer bore, like a longer stroke. And so it has more torque leverage than that inline 4 does. And it's a 2-stroke, which when you put two of them together is now like a 1-stroke, and it's firing off 3 every time. 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, all the time. Which would just fucking wreck shop, you know what I mean? Like, it works really ridiculously well as a result of that. But it's not a top and bottom. Okay, the reason why I have those plates there like that is because it's a bearing that slides or rotates with inside of the plate's rotation. The reason why I have a moon gear like that is because that means it works off of those 3, and it's 3 up here and 3 at the bottom down here, and so it's quite balanced as a result of that. But like, it's gonna oscillate as it moves, so it'll go woo 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 woo. You know what I mean? But then like, that's also countering on the diagonals too, as it moves like that. And so it like has a degree of harmonic imbalance slightly. It's very little. And I use a different type of combustion. Instead of spark and all that, I use rocket exhaust effectively. I combine air from outside into a chamber with a swirling, gas pump. So as it pumps it in as a very high pressure, high flow rate, and then it's kind of like a diesel injector where it sprays it, and then it also adds into the vortex, but it's counter vortexing and then continuing the vortex. So it does a counter vortex and then an outer similar vortex. Then we have the arrow spike to the nozzle kind of thing like this, but a slightly different version that really just allows for it to burn really efficiently, where we spark ignite it at the top, and then it goes down, it pushes that, but then it races along the boundary layers, goes up, scoops in towards the arrow spike, that then races as it was still burning forward, and then that burns forward, and then it pushes out of the nozzle insanely fast in a very consistent burn, like constantly. Because it then moves out so fast, I then have the ability to pump more air in and pump more fuel in, and because it's hot, it means I can keep firing the thrust, the nozzle thrust into the cylinder, all the way down to near bottom dead center. Now, the reason why I wouldn't use this for a motorcycle engine, for one thing, is it has a full duration of power stroke of push to give. And 4-stroke is perfect. You know what I mean? You got all the power you can get. Like, you'd use it on a 4-stroke, but a 2-stroke scavenge would not want this. You'd still do it to a degree, like you get down to middle dead center or a little past middle dead center, you'd start that exhaust, then you'd start the intake slightly after that exhaust as it started its vortex, and then you'd start your intake, you know, and which would fill up the little nozzle, and then it would go off into shoving that uh, pressurized air into that nozzle, and then burn it after it starts. Like it primes it, and then it burns it, and then it just keeps sucking it in as it does that, like just automatically, because it's a pressurized vessel, and then we have a degree of movement with the hydraulic fluid pressure that can then help with continuation of pressurization as a pressure flow regulator for the air coming in. The difference for this is that it's way more air going in, way more fuel going in. Yes, the brake mean effective pressure went up, and it's quite hot as a result, you know. And that scavenge effect is saving the shit out of it with this double turbine setup that sends that, and it gets cooled. This, yeah, right, yeah, no, right, yeah. It's like, all right, so it vaporizes, then it cools, or not, it pressurizes, and it goes back to a liquid. It fires it faster, but then it's going to cool off as it bled all of its flow pressure, and then it's getting sucked in. But during that suck in, it has to exchange some of that heat. Well, that's the waste heat generator exchanger. Right. For that given design. Which I didn't say that, but now you know, so there you go. But that's also for the torque coupler, or torque converter coupler, hydraulic fluid, turbine, all that thing for that, for your transmission. Which it's like, this is why the transmission is different for my motorcycles, which are almost inevitably always like a series of CVT sets, and then sets can get combined. So it's like we'll have one CVT, and then CVT and CVT, and then series of CVTs are combined into one bigger gear until you get to your biggest gear. And so that way it could be really small, but then you have way more gear ratios, and you can change them dynamically on the fly, still, like manually or semi-automatically, right? That goes off into its other elongated. This one's a motorcycle though, so that elongated turbine is just a regular. It's not 3 feet. It's not gonna be 3 feet. Don't stop. No, I'm not doing a 3 foot fucking one. It would be. That's huge. It's like fucking 8 inches. It's a 3 foot long 8 inch tube. I'm not doing it. Eh. Talking to someone, I swear. No. No, I would never do that. Because it's a motorcycle. So lay off. At most, it would get to like 6 inches at its largest width. And it would go back down to probably your standard 3 inch width. And it'd go into your resonator pipe that would split and diffuse it. So like there's a bunch of reeds that vibrate, and then because it's already coming out as a sine wave, then it diffuses and phases a bunch of sine waves together, which, by the way, this pipe is different than other pipes. I don't do it for the van, but for like motorcycles this makes total sense, because like the efficiency is shit sometimes to get, but I can put it on the van. Anyways, it's a composite material pipe. It's a Stirling effect piezoelectric pipe. The reeds vibrate, piezoelectrics. The outer housing expands and contracts, heating and cooling, and also vibrates, piezoelectrics, mechanical stress and strain, electricity. Air is getting pumped in, Stirling effect, to amplify and reduce pressure as it starts moving, as it gets pumped, using that effect, more piezoelectric energy. It then gets diffused into a big, long bass note. Very, very consistent, but it's a clicky with a series of different other sine waves that add to it because people like, pops, bang stuff. And so as a result, it's like I make certain clicks that combine together with the pump that then spike wave and then woo, 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 with a big long sine wave inside of it that gets phased and coherented out the diffuser pipe directly that direction. Remember like the nozzle stuff and everything? Same thing. It goes that way. It's loud ish. It's like it's around that 91 decibels. But it is a 22 at most up to 62 hertz. And a series of clicks of around 22 to 32 click hertz. Boom, 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 like that. Even though if you look at the engine, it's going. It's coming out as. Yeah, if it came out like it normally would have, it would never sound like that. And truthfully, a two-stroke, 6-cylinder, but it's a scavenged two-stroke 6-cylinder, which 3 of them go off each time with the two-stroke every rotation. Every rotation. Yeah, so it's like half a rotation, half a rotation. It's been two-stroked each time. So every rotation there's a two-stroke that happened, and that means for the entire duration of the rotation there's a power stroke happening. Right. And it's 3 of them on 3 spots with large strokes that happen to also, with the rotation of those gears and bearings, add in even increased degrees of torque and rotation effects for that axle, which then I have the gear ratio CVT packs that this adds to. And then, the torque converter, torque coupler to the torque converter thing with the turbine, which now I see why, like, that starts off small, I guess big, and it's just never go above 6 inches. Exactly. Because it's like, yeah, no, I can power that just fine, but I would never freaking put a 3-foot long, 8-inch freaking pipe. Just not doing it. It makes sense for a van, but I'd never did like at 6 inches, and it's like, oh right, it's only a foot long, so deal with it. You know what I mean? Yeah. But of course, it's going to combine to the standard, turbo. This one's actually, yes, I would use a super turbo in this instance with a water to air exchanger, but this is a different water to air exchanger. So this one does use the Joule-Thomson phase change effect as a water to air exchanger, utilizing acoustic resonances and the heat that's being a part of this, along with the heat from the engine that I have to cool, okay, which would then be added into the waste heat exchanger, because like that heat can then be used to help with the diaphragmic exchange Stirling effect into the water, right? But that helps with cooling as it also further expands, so it's like, all right, I'm cooling the engine better, but then like that has to cool off, and so like it's a 1-part piece design waste heat generator, which has the thermal acoustic and then actual electric acoustic. Well, it's more air acoustic in this instance because it's shaped in such a way where it allows for expansion in vacuum, meaning like it spins in vortexes, but then it curves like our turbine, and then diffuses and then combines, which allows for greater amounts of exchange and a reduction of boundary layer deficiencies in a Joule-Thomson cycle, along with the diaphragmic acoustic with the water and the coolant separation as a heat exchanger Joule-Thomson effect. So it's a bunch of Joule-Thomson and a bunch of thermoacoustic with the acoustic resonance of the air as it goes through. And it has a fan. There's a fan. No worries. You're gonna need a fan, but when it's idling, you don't need the fan because it's not belting out as hard. But you can turn it on, so it doesn't matter. Anyways, point is, it cools more efficiently. Long-worded explanation for it's really efficient at transferring heat into electrical potential energy through the motion energy of mechanical stress and strain, thanks to piezoelectrics, and concentrating that heat and pushing that heat into the resonance of convection, conduction, cooling effects, utilizing the Joule-Thomson cycle and thermoacoustic resonances to potentiate that cycle. Yeah. Anyways, comes in at the heat it leaves quite a bit hotter. It's very saturated at that point. Ugh. Alright. Now, this is also why it's a hydraulic fluid. And, you got the rings and all that. I just described that whole rotary engine for you. So there you go. Well, this one, I just described the head pump injector, right? So the coil pack is still just a coil pack. The plug, the spark plug is still just a plug, okay? And that plug then just is the electrical lead in ground that makes this happen for those sparks, for its plug and ground. So it's electrode and ground, in multiple spots. That way it burns the right way. For its burn chamber. Yep. Now, the nozzle is a very specific type of nozzle. It has to be a very specific type of nozzle. So I have to have a very diffusal style of nozzle. So there's a teardrop with stators, like I've stated earlier, that's inside of that nozzle. It's done in such a way where it has channels and fullers and a hole in the center of the teardrop with its own version of concentric ring little boundary layer things. And it's fullers on the outside and on the inside, and the stators are just regular teardrops. So, the stators allow for coolant to pass through and cool the teardrop. Alright, this means it has a Tesla valve-like effect and a increased flow velocity as it moves through, while also increasing its degree of pressure and thrust characteristics, while the flared part of the teardrop at the bottom combines as well with the faster flow, and you get the diffusal throughout the entirety of the size of the bore for your cylinder. It then races up and it arcs around and it goes into a swirly pattern into where it started exiting out, where the nozzle ends. Okay, you get way better burn, much cleaner burn, and you get far more controlled, consistent pressures inside the cylinder. As it goes down, it then can burn again, and it can continuously burn after that, all the way down to its version of a near or just after middle dead center, and start the scavenging effect. All of that wasted heat and pressure energy is now captured via this, although not really all of it, but a good amount, because there's still heat in the tube, and there's still the resonance, and there's still the electricity. The electricity's got to go somewhere. Guess what? I have pumps. I need pumps. Is there still that up-down donut gear thing that I talked about on my previous video about this? Same kind of thing. Well, it's not just hydraulic fluid. I'm going to be using fucking electromagnetics, because, wow, why wouldn't I? This standpoint. Yeah. And then, I don't really know what else I'm going to use the electricity for what it's worth, so I tend to just put it into the axle area for where the bearing is. So I make the version of that plate, so that's axle electric motor, but now it's a PCB style layer. And so like the axle has that, and then that has like the PCB curve like bearing thing, and then that spins where it so that way it won't touch or break. Bingo. And it also works together with the rotation of the piston heads. I had to come up with that one right now. But it's like, that's easy as fuck to do. That's an electric motor, meaning repulsive force electric motor opposing, instead of opposing, same electric field type of thing, coils. But now and then, yeah, you get it, Yeah. Great girdle. Thank you. It does its job, that's for sure. Anyways, and like that's the end of that, because that gives me my torque, and then I have the efficiency of that torque from the exhaust, and then that whatever remainder is captured to help with the electric motor, a few batteries underneath the seat or in a side saddle or something. You know what I mean? And then the you got the electronics there too. You got the waste heat generator. You got that right, and then the rest of it's to help compress air, which I have a ram air turbine thing. Yeah, this one would be like just underneath wherever that light is, and like little vents areas, and it goes off into like its collection. It's like I'll cool it with the initial water that comes off that's cold as it can get, as it comes in for the ram air to get sucked in, and then it's gonna go off and get water to air exchanged, heat exchanger, and this like everything, like the ram air is another version of a diffusal capture Jules Thompson thing, yeah, like legitimately, and then same thing for the after effect, but like that's a version of a condenser, you know what I mean? And so like it'll heat up, and then it'll heat up and in phase exchange, right, as it goes through the engine coolant stuff, and then that allows for it to cool off even more, and it creates a thermal siphon for its degree of a pump, and then also helps with the thickness and all the Jules Thompson resonate blah 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 efficiencies of that heat exchanger radiator, and you get it. And here you go. Now you have a motorcycle engine that's stupid, like actually. It's like, hey, guess what? I can fly on my motorcycle. I'll just pump this hot air on over to like these four, I suppose, prop, dual prop. I do the dual prop. You have no idea how much I do dual prop every time. They're shrouded props, so but there's two of them, top and bottom, and they counter rotate with a little stator in between, and there's a little nozzle at the end, and then that flares to a little bell end. You've probably heard it all before. A real quick rundown is it's a funnel that goes into the first prop. That one's like a variable change of its kind of like helicopters for its pitch blade, right? But then it gimbals for where the shroud is, so like it's not trying to thrust any differently. It's just trying to drag more air in as it happens to be spinning, so it's more efficient, right? That as a counter rotation at the bottom, which is a much heavier pitch, but it's smaller and it spins and rotates faster because of a gearing that's different. That then forces into a little stator nozzle area. So like those little stators are there to kind of make it really concentrate and force and flow the air faster. Kind of like the bifurcators in the turbo. So as it spins, it then goes into a channel, and then that channel has a little blade there that splits it in half, and that's what's kind of helping it compress air. Kind of the same kind of similar thought process. It's curved and then it straightens out and it widens, and then it has little channels within that widening that fit within inside of each other that then diffuse in a very consistent pattern, so that way it's always even and it's always the same amount of air pressure, and it doesn't have going on, so it's constantly. Anyways, that then goes into the much higher pitch angle, much wider with multiple blades now because I figured out that. And then if I can suck some of that air with like my turbine thing that I was talking about, where it spins on the shroud with those little stators underneath, then it creates that outer boundary layer suck force into these little stator hollow areas that then also curves and compresses the air against those stators, but then also adds it to it. So like it shrank it from a very large volume to a very small volume and increased its flow velocity. And then it goes off into a bell end like a rocket, so I produce thrust, which happens to have a dynamic aerospike. So the aerospike and the shroud of that bell end extend outwards by rotating and blooming, and that also makes the aerospike elongate and change its position inside of the bell housing, which, yes, it's heavier, but here's the thing, I have exhaust gases that I'm forcing into that much faster flow rate prop area, and then because I have extra air, it's hotter and it's been concentrated, so it heats up even more, I can throw in a little bit of diesel or a little bit of hydrogen, and I now get rocket jet engine thrust from props. I usually just throw in water, if I'm being honest, with a little bit of electricity, because I have enough electricity. So if I throw in some water with a little bit of electricity, it like produces an HHO, but then like it'll combine and it'll try and combine with the CO2 and CO and all this other stuff. Anyways, it makes more mass get thrusted out for the given amount of electricity used, and it goes faster, and it tends to not stall as much, but I also get more thrust as a result of it going faster, and it getting captured as a result. It's usually easier to maintain one atmospheric pressure at different altitudes. So, for the bell end, as a result of that, I'm able to get much more efficient thrust, and it's colder now. And as a result of it being colder, I can run it around, and it's not super, super loud, which is great, around civilians, around other people. And it's just a kind of warm, freaking really windy breeze. But, hey, what do you know? I have my flying motorcycle that I use with my rotary, with my 4 props, which are spun using either the transmission directed via arms to, like the coupler stuff that I talk about, or a direct one-to-one with hydraulic fluid as a coupler with pumping. The valving for the exhaust, that one's a little different. I have to have it go from the resonator area, and then I cut it off like the very tip of the diffuser, and then that gets diverted off into the props. And so since it reduces that back pressure, because it's super fast, it sucks it out, and it actually makes the engine perform better at being able to put more pressure into it. But of course there's only so much with the rocket, exhaust injector thing. So for combustion on that and capture, it's a bit difficult. I'm basically amplifying a certain amount of heat energy and pressure energy captured into a larger amount, and then amplifying that again by using the electricity that I don't really need for the engine, because it's performing much more adequately now, into the props, and then performing with a little bit of water injection a greater degree of thrust and flow speed. And it cleans up the air just a smidge, it's a very clean burn for what it's worth, but it's what it is. So, but is it something I should be concerned about? Yeah, I don't know. For me, no. The answer is no. But I also have wings that extend. So I have those little wing things that have multiple little wings underneath them, just slightly further back. as they head towards like the front, and then you have to like flip these open, then you have to slide these open, and same thing with the rear, and like you have to collapse the like prop area onto itself, kind of like collapsible pot or something. And so like all of this has to open up, and then you have to do all of this work, and then like you got these nice, it looks like they're tiny little wings, but they produce a lot more lift as a result, once especially once you get going. I don't really suck too much air. Like normally I was like, oh, you have this this hollow wing, and then like it forces that air, and it diverts it, and all this, kind of, and it still works. But what I found is, while it's stronger and everything, is it's not as necessary at that point, because the shrouds themselves become a wing because they're ovalized. I make it much smoother, and I do that little like boundary layer laminar thing, coherent effect, and then I do the top part where I do like effectively it just it rolls over and then creates little um, vortexes with the stators that then flow and then get separated with these little wings. So so it's a good way to put this. The stators are have holes at the tips that are then flared out at the bottom that then act as little wings. And so then it creates a vacuum area underneath as it sucks air underneath into the oncoming rushing air, and then it produces a lift for the housing. And there's a nice little separator area where it curves, so like that little wind that's coming off the ends. So like I create a little style of curvature, so like a little corkscrew. So like that little curve that it wants to do at the tip, like I started a little bit on the ends, and then I suck it in, and then I force that oncoming up air to curve into that already there sort of produced, especially since I have to have that wind, that lift, like kind of go around, and so it like produces a little bit that goes down there and adds to it, and so it combines and it creates a canceling out of that vortex. It's not really canceling the vortex. It's kind of like aligning the vortex. Like it's still there, but it's going to be like, going off to the rear one. And so it creates that nice little teardrop shape as it collapses behind you. And then sort of no longer is there. Hopefully, as much as you can get that kind of an effect. There's still a little, but it's very minimal. So it's the best I could do. I don't really need it for like the wing part. So that one, it was like, oh yeah, no, I actually kind of want air because I like breathing. And it sometimes is nice to breathe where I sit on my motorcycle, because it'll produce like a huge vacuum effect if you do it right with like that little, like all those little hollow areas. Like it sucks a lot of that air, and then that air races it and then stalls it underneath, and then it gets stalled with the wings behind it. They just have to be slightly higher, and then it's like, oh, guess what, where my body is? I have like almost a ridiculously reduced level of air. Like you'll sit in this little pocket, and it's like very much a near perfect vacuum once you get fast enough and you've been driving it or flying it long enough. It's like, this doesn't feel good. Like your feet are super pressurized because that stall effect, and then like you get like this really near perfect vacuum effect where your stomach and chest is. And so it's like, oh, I can breathe really easy. I was like, oh yeah, no, here's my Ram Air helmet that I have. That's like the scramjet, so it curves off into your little air scoop, and then it circles it around, and then like there's a little valve, and so like you get real lots of air, and then once you start breathing, it'll keep momentum going, and then it'll go, You breathe out and just evacuate. Anyways, the reason why I talked about it is because it's like, oh yeah, no, that would be great though to have. Why wouldn't you want to do that? I'm gonna do this, and then I wrote it in my mind for a while, and then it was like, fucking hell no. My fucking chest hurts all the time, like for real. I have a puffy, ginormous chest. They don't understand that it's like you got bends effectively going on. You know, like when you go scuba diving and then you go way up in high altitude. You basically have that, but at your feet and your chest. It sucks, and you can absolutely get hurt by doing that. So it's like, nope. I'll just reduce that. You know what? It's fine to just have it really just kind of stall only in those areas where the shrouds are and some of those wings are, and that's good enough. You know, there's still got the ram air intake helmet because most people tend to not think about this, but when you have a helmet and you try and breathe when you're at like 400, 600, 800 miles an hour up in high altitude, it's kind of hard. Your breath gets stolen, you know what I mean? So it stalls it and it keeps it at the right pressures that you want. So like even though you're at really high altitude and you like decide to blare up and all that, you can still breathe normally. So that's the reason why I did that. But yeah, no, like the speed I think was like 1,200 miles an hour max that I did, but I also had like extra fuel and I did up the batteries and really kind of put a couple of extra water tanks in there and I fucking went for it. Started up a higher altitude, kind of dipped down, really try and collect that speed, and then just went for it. We were pretty high altitude though. For what it's worth, we're above like airliners, but that's because I have a Ram Air, helmet that I can seal to my neck that pressurizes that air. Now, granted, your body isn't pressurized, but tell that with all the layers and all the bands, the rubber bands that are there because I don't want it to get ripped off. So that's kind of what that ended up being. It's like you go fast enough, it's air pressure. Exactly. Exactly that. So anyways, I got up to that 1,200 miles an hour. I don't know what that is Mach wise, but like it's pretty fast. And then it had to come to a landing thing. So it's like, all right, here's my airport. Yeah, people might think that I was like, oh yeah, I'm gonna flare hard, suicide burn. No, I got up to speed, then I just gently come in. Fuck this, I'm not doing that. Just yeah. Oh, nice, that's good. Yay, all right. Because there's no roll cage. There's like a windscreen in your helmet, and that's what you get. That's all you get. Like, you slide them out, you latch them on, and you screw it down, you torque it, and you have fun. That's what you're getting. This is it. This is your aircraft, your own personal flying vehicle, because it's fitting within the envelope of that. Like, it's under the amount of weight and all the rest of that, so it doesn't need the licenses that most people do. Which is such a bad thing to do, actually. I realized that later, because I was like, what is this? Oh my god. I'm going to race really high up. You're low on fuel, and you are way too rapidly extending here. You're about to fucking pass out. We're just going to cancel that. Meanwhile, we passed out. That's also why there's a strap, like a ski-doo, on this thing. Yeah, like there's a couple straps on it, so it's like you can strap yourself in case you pass the hell out, and you're not gonna fling out and fly off. So it's like, oh, you passed out, huh? Oh, yeah, no, he's just constantly, oh, yeah, looking from up, and he starts heading down, and then he's leveling out and trailing forward a little, just making it nice and simple. It's like, oh, oh, yep, there he is. He woke up, woo, and heading down to land. You see him every time. No, I mean it. You can see him every time they land. But if it's close enough to a airport, it'll land it for you. If you have decided not to do anything to the controls, it'll just do that automatically. Yeah, I don't know that nitric oxide, it burns the air because it's so hot. It doesn't do that. But it doesn't. It's compressing the air. It's hot air. Yeah, you could burn diesel or hydrogen, sure, but you could never burn the air even with the exhaust in there. Yeah, most of that exhaust heat got captured as electrical energy potential, which, for what it's worth, got put into the props a little bit if you have them. It's just not much. Mm. Really, it's just not worth it. I mean, it's like almost direct transfer from the engine, so you'd rather just do that. But I mean, if you want to, like, it's a radial or an axle. Is it axle? Radial electric motor, but it's gonna be the same kind of repulse thing. You know what I mean? So, yeah. It's like it's not that much electricity. You know what I mean? Like it's really not. Like I can get a good amount, but it's like it's capturing what was left on the table. So it's like if I got maybe 60%, I'm getting like maybe 35% off of that, and while you think that's a lot, and it is, but it wouldn't be enough to drive four props without the engine going full chat, which at that point it's like you can divide, that to like the engine to help it out and the props. There's four of them, and so that's a version of torque vectoring effectively. That's why it's there. It's another PCB type of thing, tube within a tube thing that's attached to it. Yeah. So there's a lot of electronics and circuitry that has to go in there, and it's annoying to have to put in. That's a main reason why, and it's heavy. So if it's heavy, it's immediately just something you don't want to do. When you're talking about like something flying, it sucks, and you have to cool it. Yeah, you're right. It can get hot, so it's one of those things. Yeah. Well, I mean, it has a lot of air. Oh yeah, no, it's got air holes and stuff. Like those are part of the stator stuff, so it'll draw some air through. But then, oh right, you have the little extendy nozzle, fucking like right hub that sucks air in. That's correct. It's a funnel nozzle, so like it'll have that tip stay put, like the very pointy tip, but then like the shroud then comes off and it's wider and it funnels, but then it has little channels and grooves that go off into the funnel that's around it that funnels air into the prop. And so it'll extend out into like that little plug of air that's there, and it's usually a really concentrated point, and so like it now divides it, and then it sends that air in, and then divides, and then compresses it, kind of like a ram air again, but this time it goes off into the stators, and then a little bit will go through and cool the electrics, and still allow for, because it's separated, so it's attached but it's separated, like you have to have grease and it has to get cooled off, but it's like that's where the electric motor is, which is kind of like its version of a heat sink. Well, it moves, but it cools off the grease for the lubrication for the gears that are involved here, and because it has to spin and it's also transferring spin, I figure, well, might as well shape it the right way in that tube to produce the kind of, continuous air pump effect off into the stators, which this is sending most of that air off to the stators, and then the rest of it gets pumped off into the stators anyways. And so it compresses it even harder and makes it go even faster. Yeah. and then it fires exhaust. You get the whole thing, yeah. Because it's like then exhaust is in there, and then more air, and then more pressure, and then uh, any fuel really kind of can do something at that point. Yeah, which I said I use water because once it's in that pressurized environment, I put a little bit of electricity where those stators are. It then creates its own version of a HHO with that heat and the little oscillation resonances, and then it separates it and then combines it, and that means it's burning as it heads towards the pinch point, the very smallest point of that nozzle, and then it goes off and gives you thrust. For the amount of heat and electricity put in, I actually get way more thrust out than I put in for the amount of electricity to and pumps to send. Well, the air pump is the engine, but the pump for the water is different, of course. So, right, yeah. No, no, that's a baffle with a like electric pump. Yeah, for the water. Yeah, yeah. So it heats it up, it cools it off, it evens out the pressure. I mean heat. And yeah, it evens out the heat, but then it also makes it way more pressurized, way faster too. Yeah, because it condenses it. Because yeah, you're right. See, you already know it. Because I'm condensing it, it means it flows way faster. Because it's willing to flow faster, without as much trying to harness it to just do this thing. And it imparts more energy more efficiently as a result. So there you go. My efficiencies! Yes, mine. I'm more efficient than you are. They're stupidly large blades. They're not stupidly large, but I can see why people think that. Yeah. Especially since it's like there are multiple trailing off wings that then go behind the other blades. There's just mini blades that can change their pitch angles. Like it is. It's like it slots right underneath it. So like the blade's underneath the blade. It's attached to the blade in front of it. That's pretty far forward for what it's worth, but it's still like they're wide. Yeah, I know. It's like, but they can really pitch very hard, and this one's already very heavily angled, and then it like just tries to curve its angle really hard even more, and then it has the little blades underneath, right? And so it's like just spin faster and really accelerate the hell out of this, and there are a lot more blades on this than that one. So it's like this one's just meant to thrust. Woo! It is thrust. Yeah. You got those stators. Remember, you have to have them like slip in between the little wave guides at the end of the trailing off wing blades, you know? So it's like they have to slip in between, and then it creates its own bifurcation as it goes off to the sides, and that's why it has these little curvature, boundary layer, stator effects that go off, and then, oh right, so it goes, but see, thank you, you finally said it. So it's like these blades are like a Archimedes screw, so like they're curved, such in that outside and inside will constantly go back and forth. So even though they are in such a way where they're curved together, they'll slide from inside to out, but outside to in, thus compressing and oscillating each blade in turn. That acts as a better thrusting pump, and with the boundary layer effects and the collapsing of the vortexing, it then mixes the air and fuel into like this little kind of, it's like the equivalent of a style of a Tesla valve but with air pressure. So it's like it's racing forward into the bell end, right? But like that air pressure creates a faster moving pressure of air that is technically speaking stalled above it. That's combining as it goes towards the nozzle and then straightening out. So for its spin, it gives up spin for directionality of travel. Then the little grooves and little stator, kind of boundary layers at the very actual surface area is such that it tries to oscillate and keep up that spin, but then once it gets to like a point closer to that little narrowest diameter, it then just does that little coherenting like the Lorenz, and so it's all focusing it towards the nozzle and making it much easier to travel that way and much harder to travel another way. It has slightly further out, and then it gets thinner and thinner and thinner and thinner and thinner and thinner and thinner until it's like just a little boundary layer skip effect that we have a little ring here at the that little narrowest point that's meant to have it skip over, and then that little vacuum that's there that travels into these other little stator areas. That way it always tries to rush that way. Yep. And it flows it way faster. You can't have something affected if it's not there. You know what I mean? Like, there's no resistance to boundary layer when there is no boundary and there is no layer to be a boundary. It's a vacuum. You know what I mean? Anyways, goes off, you get your bell end, you get your thrust. It's an enormously high improvement. Like, it's stupidly super flow. Like, really high flow, really high pressure, very efficient for all the weight you have to put into it that this is ultimately going to be doing. You're not getting around that. Like certain materials, whatever, but it's like, it's lift. It's thrust and lift together. You know what I mean? And so, as a result, I get thrust and lift for the amount of weight I have to put into it. I have to put weight anyways into it. And for the size, which I never said the actual diameter for the freaking top, but that's not a foot. But that's like an 8-inch fucking, like, little tiny motor, and then it goes into like this little 3-inch fucker, which then goes into a little 1-inch fucker. That then goes off into that little trailing bell end area that blooms out and widens. That's why I was like, you see, this is an oval shroud thing, with all these little stator, it's really not what you think. So you got the little gimbal, sure, right? You go forward, you can go out, and a little in, but it's mostly out. And then it's like it can tilt, all the way rear, or, straight down, slightly forward. But it's mostly meant to go forward, but it's meant to help you with lift and, thrust, directionality of thrust. Because you can tilt your bike forward, and then this can gimbal, just like you've all seen that. But this means it's like I got rocket thrust, like legitimate. That's a fucking prop jet engine rocket thruster at that point. With my 6-cylinder rotary. That gets me from point A to point B every day. Anyways, but yeah, no. So like that little bell end area. Okay, so like the stators in the middle part. You heard me talk about how that's where I put my exhaust in from my engine, right? Well, that one, they're hollow. So the stators are hollow. All right, with like other wings that are next to it that have the little like connecting stators. So like they're just fucking wings that connect to the wings that coherent and then allow for the exhaust to be piped in that way. And so it's a tube with a series of holes that yeah, get sucked out with the flow of the air coming out. Okay, which is cool, but it's like basically at the tip, and so like there's a good amount of pressure, technically speaking, still there, but it's mostly uh, just extra exhaust. It's like a little bit of a good amount of heat still, for sure. That's why I have all the little Stirling things, but like it's really just as you ramp up your engine, you're gonna have like all of a sudden that pressurize, and it'll help actually increase pressures for the bottom turbo pump thing, whatever that is. Yeah, compressor pump, basically. It's an air pump. Yeah. Anyways, that goes off, and that's also where the mixing and then the spark or electrodes are in those stators. So as they bifurcate and they do that, and they roll in vortex, okay, they'll create their own version of little electrodes and gaps along the wing. And so if you add in for where the bottom part is for fuel, okay, so like where the little blades are, there's like a little flare out. So it's like that spinning out along the wings as it trails in, and because it's curved, it then flings itself along the curvature of the wing, and it will vaporize, cool off the wing, but it also like then mix into the chamber and burn. Yeah, and then it of course exhausts, but if it's water, because it's going to cool it, so it'll vaporize because it's hot enough and it's compressed enough, but it doesn't know that it's doing that because it's flinging really fast. So for its version of events, it's like, oh, it suddenly really dropped pressure temporarily, and then it compresses, but then it has a bunch of electricity along all of those diffuser stator wing things. Yeah, and so it's like, oh, there's electricity, it's going to separate, vibrate, and blow off a bunch of H's and O's. And so that amount of electricity is like, well, I've got it for what it's worth. I have an engine. I got it, like the turbine, and then I've got the coupler. So like the coupler like then turns off or well like that goes to the props, right? And so like this turns into for the waste heat generator, like the electricity added together with the whatever extra you might be able to get, because like the DC generator that you gotta have for this is at the front. It's like this is all the rear exhaust area. The front of the engine still has an alternator, still has that generator. Anyways, but it has multiple sections. This is one of those things where it's not a great idea to not have enough electricity. And so this is where I use both the piezoelectrics and a series of laid inside of these piezoelectrics magnets that are iron nitrate or neodymium, whatever good, but the, magnets you can get, like really good magnets. You want really powerful magnets. Anyways, the fields are aligned again in those spikes. Okay, so like we want to really make it very right next to each other. Like you want it to be that. You know what I mean? So instead, it's like a bunch of these little ones, but then they add into a bigger one that's then one big spike of a magnetic flux field. Then the coils are packs of coils. Yeah, I have multiple small coils of those little PCB things, and I have to cool them. Like they have to be cooled, and they have to be a part of that little, rotating hydraulic fluid pump. So like I can cool it off of that, especially with air coming around that I've got. I got a little bit of air. I only need a little bit. That'll work. And a little bit of holes in that helps with that, because I they rotate as well through their own magnets too. So I have magnets on the outside, and then these coils, and these coils packs are meant to like capture multiple fields that are on both sides. Okay, so they'll go through, they'll cool, and then like the coils are what move, not so much the magnets. So like that way I don't have to worry as much about cooling the coils, because the coils are going to get cooled quite a bit, you know. Anyways, forces a little bit in, and then I have a tiered of these magnets. So it's like as air comes in, and then it goes off to the sides, and like then it joins in with the rest of your air that's going around you. All right. So that allows for magnets and magnets and magnets and magnets in a funnel, way more magnets than you normally have, and way more coils as a result, because I have coils on the outside and then coils on the inside, and that funnel is all moving. Yeah. So it's so an a U, or like an arch of and then like that funnel can go through that as long as it's shaped appropriately. All right, with like the right little connector pieces sideways or diagonal. And so like that moves throughout this magnet pack with a bunch of PCB coils. Yeah, that cool it constantly. So I'm always getting a real constant, because I have them offset. Yep, DC voltage. Yeah, I have them offset, so it's like they're always giving me DC. Yeah, and then I combine them in a series in parallel, so I get my version of a DC AC electron flow phase shift with the clicks, sine wave thing as it spins, and then I have a rectifier circuit that sends electricity back through that, so that way it properly is phased, it's properly sine waved, and it's properly DC at the right voltage to then be sent off to all four of the props and the electric motors. It takes a long time to make that fucker, but it's worth it. It's a whole thing. It's just like up, over, and then up, over, and then there's the end. It's like the bottom pump. Remember the pump, where it's like curves. So it's like one curve, and then they'll arc, and then I'll go out and then in. Oh yeah, same kind of same design. Yeah, it's like, cause that's the curvature of the. Anyways, doesn't matter. Point is, you get it. You do understand. You do know where I'm coming from, because it's like there's like two curved stator things, which allow for that, like, to go from in to out, but then out to back in, because like the other stators underneath allow for that to be different. And like that's the same thing for the out to in, and then the curvature of the blade also helps sneak it underneath things. Zoop. Like if you ever see like a straight rod and it's on like this circle, plate, and then it rotates, and then you see like this, but it's at an angle, it's bent, it looks like it's going in towards the center. The straight line that's right there, that it's gonna apparently go through, on a little cardboard or whatever. You've all seen the GIF, right? It rotates and then it slides right on through. Perfectly vertical in all ways. Same kind of thing, but we have certain tolerances that we need to match. We have certain air pockets that we have to force in to help allow for boundary layer and cooling effects. And so like that's how we create a version of a bearing and also cooling effect, so that way tolerances can be a little tighter once it gets spun up more. Anyways, that's my generator. That's the generator for your flying motorcycle. Yeah, that's the alternator generator stator thing, pump stuff. Which, yes, that is the air pump kind of technically for the waste heat generator. Yeah, because I still have the Stirling effect thing, and then I still have an actual air Archimedes screw design that has like, yeah, with the hub, but it's hubless, so it's like it has the outside that rotates, and then it goes to the Archimedes screw center hub thing because it's connected. So it does have a hub, but that's not what's rotating it. It's the outside that's rotating it, which then goes into this helpful generator alternator stator, depending on scooter, car, or apparently power transmission. Because they're all the same. I don't care what they say. They are the same thing. They are the same. They are a freaking electric generator. That's all they are. They all have different words for them. They're the same. So annoyed about it. Yeah. So stupid sometimes. Anyways, but that's the generator. That's also going to make it such that it's a lot less resistance to generating electricity. And the heat, while isn't super captured, but it's flowing it from in, and then it goes around the engine block. So like that's kind of like what it's doing. So it has like that. It's like a spike, and then it goes and flares out, and then it helps with like flowing all of that outside and around the rotary engine block. Because there's no gaps. There are blocks. There's no gaps. That's right. Yeah, it's that kind of thing. Because as the girdle and all that, I just described it, but it's like, yeah, right. It's like same thing, just smaller kind of thing. But like because of that, I can then have that with an air shroud around that then allows for it to not burn your legs or anything. And it helps with flow characteristics behind you, because I usually put it behind where you sit, so it goes up and over, and like it fills in that little gap where it's behind your back, and then like behind the wheel too. So like that way it helps remove some of that drag coefficient that you have. Anyways, that'll be the end, I hope. What more do you want to know about this? I can't tuck away the wheels, so, I'm going to have to deal with that. Let me just see if they can handle the 9G acceleration I intend to give to them. It's only for a split second, though. And then it immediately pretty much goes back down to after, like, at 5 seconds. After 5 seconds, it gets back to 3Gs. So it's like 1G of 9. 1 second of 9G. And then it goes after 5 seconds, it's back down to 3. And they don't think it's very long. They really don't. Like 1 second of 9G, I can handle that. Oh, you can handle 1 second of 9G, huh? To get you into let's just, here it is. Here's the Top Fuel Drag Racer. Have fun. Ugh. I'm laughing my ass off with you guys on that one, because it's very funny. Like, actually, yeah. 9G is like, zoom. The only thing is the seat will slightly compress. Like it sticks out. It's got little shocks and springs and a little sliding mechanism. So it'll slide back and it'll compress in, and and then it'll return back over time. But it's like that's the only thing you get. If you get like the nice, flight suit stuff, you should get that. Like with the little air bladder things and some bands, you should do that. That it's probably a good thing to do. Do some of those breathing exercises. Learn how to pump. That blood into your brain. You should learn how to do that because you're probably gonna pass out if you decide to really give it like the full chat right off the bat. Because it can do that. Like it's genuine and that's just a straight shot. It has almost a 5G lift acceleration for a freaking good amount of time too. It's like 4.87 or something. I'm not kidding. It goes up until about like 90k feet, like at 4.87 G. It's just how it's able to use this rocket engine bell end stuffs. Yeah, it has that lip. Yeah, okay, so that's something I should talk to people about. But it has it's an offset like lip, those little teardrop lips. So it's like they go and have that teardrop like little divot area, and then they go off into a series of little teardrops that are that have little channels in between. Those and then they go into a flat point really quickly, and then there's another teardrop, and then another teardrop, and then another teardrop. It's slightly offset in between those, and then eventually it just turns into your standard like little final lip that it bends off, and then it flares off into like that little bell end flare at the very tip of the shroud, and it's like all it means is with the aerospike is that I make it for this tiny little thing bell end that 1 atmosphere much more easily, and a lot more of that capture of energy is maintained as it goes to higher atmospheres with the aerospike and it can bloom as it spins and opens up to being wider. It's pressure wave oscillations captured, but then it's like that little lip then creates that pressure oscillation, and then it divides it towards the aerospike, and then it basically creates more and more of that bouncing back onto between the aerospike, which it takes the aerospike's bounce as it has these little channels that then bounce it the opposite direction. So it's a weird way to put that is it creates its own version of lift. So it has like lower pressure one side, higher pressure the other way, and then it tries to yank itself forward as a result of that along the boundary layers that it has. The bell end is basically getting hit by the impact of the pressure wave, and then it's trying to head back to the lower resistant side towards the end, where it's exhausting. And so like it oscillates between that, and it gives it more for a lesser sized nozzle or bell end. That is not nozzle, bell end. It's a whole bunch of aerodynamic effects that affect everything in such a way that it works very, very cohesively. I'm getting, yes, you should do that. You should look at every single puzzle piece together and make it work properly together. It's a machine like any other. Anyways, the lower pressure front and then higher pressure rear is a different type of effect. So it's kind of like a version of a opposite scoop. So it'll have the rebounding pressure wave divert off towards the side, but in so doing it'll have air go in and it'll travel faster along a certain boundary layer that skips over these channels, and then that creates a lower pressure above and then a higher pressure below, reducing lift. So it's like you have to shape it the right way, but it's effectively I'm just creating a wing that has a little bit of that bounce off, but then the stuff that is, because of the way it's bouncing off, is not really bouncing off. It's not hitting it. it's very evenly flowing off and over. So it goes from down and then out over. So a good way to describe that is you take an angle and then it simply goes off to the side. Because it goes off to the side, that's because it has a lower pressure above that it's trying to hit. As that lower pressure is trying to curve in, gets diverted off, it then can only flow back off to the sides. So it curves and it flows off. You have to think about it in a three-dimensional way. Yeah, it's not a side way, it's a down and then off. Down and then curve pivot, you know. So that has to split some of it, and so some of it, because it's split, then skips off this little piece that's like another little angled, the little airplane wing that causes it to create a micro vacuum area above, and then it gets curved back in underneath, and then it joins in for the next pivot split. Creating a directionality of lift for the spike, and then that on the bell end inside creates a impact that then, because as it spins and it's off to the side, its relative point and velocity went downwards to off and up, because it's spinning and curving, conservation of momentum happens, and it hits and bifurcates, and it has a lower degree of resistance out the exhaust side versus a higher degree of resistance where the bulbous part is trying to split on the bell end shroud. So then it captures that pressure, squeezes it, and then it fires it back in downwards, and then you see the oscillation effect off the aerospike and all the rest of it until it eventually just ends. It goes much faster comparative to a standard, really ridiculously large bell end and shroud combo. Like, that's way more weight versus me, who doesn't need that. And I got little tips and the gimbaling and all that. And look at how fucking fat and heavy that shit is. Anyways, that vortexing, it's a conservation of momentum effect, for what it's worth, because it's trying to curve in, but then it can't curve in, and so it spins. You know what I mean? Yeah. Jeez. It's a genuine rocket thrust. Yeah, oh yeah, no, it's at detonation levels. For what it's worth, it's at a detonation level of thrust. But you gotta put in the right amount of fuel for that. You have to have a lot of electricity to do it. That's why I have the generator there. It's usually a 20k RPM spinning design. Like, it starts happening real fast. But this thing can feasibly go well past that. We're up to like 50 to even 100k if you really want to. The only problem is the sudden up. It's just like it has to. If it didn't have that girdle and all this other stuff to prevent it from continuing up, with the like little spring, because it's not technically. It's more like, well, I suppose it's kind of like a spring. Anyways, it's its own version of gears that are in there. So it's like once they get up to that point, which is it has to have the bumps. So it has to. So it situates itself, but they're not touching the top. Oh, yeah. Okay. So like a good way. That's why it's like a spring, but it's like a gear. You know what I mean? So it's like it's an undulation, and that's why I was like the girdle's a pump. You remember the girdle pump thing phenomenon? It's a pump. Right, yes. Right, and so like that has its own way of preventing it from continuing up, and breaking effectively. As it rotates, squeezes one side, then it goes over and it squeezes that side and it pumps it. Oh, yeah, yeah, but it doesn't move it. See, that's the thing. Yeah, it's like it'll go up and it'll hit it, and then it rotates off of statically fixed gears that are there in the girdle. Yeah, in the bottom. Yeah. Oh God. Finally got that. I figured you'd know how to do that with the girdle. I should have said something. Because it has to have oil, and so like the oil acts like its own get amount of like, yeah, like the spring pressure, right? There's like, oh yeah, no, there's something in the way. It's gonna slow down like a shock, and then it'll, right, like a spring slowed down. Okay, yeah, spring shock thing. Yeah, there you go. You got it. Well, it pumps. Uh, it does pump. It's pumping. It pumps it towards the thing in the center, though. But it also makes it so that way it conserves that energy into its rotation, too, because it squeezes and then pushes it off to the side. Yeah, and you need enough waves. I get it. Like, it's not just three. You need like six, I think, waves or something to make this work. But, like, that's what that is. Right. Yeah. So, anyways. So that's why it's like a gear, because there's like six teeth, but then they have sine wave teeth on it. Thank you. Now you got it. Which is a pump, right? Yeah, no, for real. Thank you. It's like you. It's hard because it's like most people wouldn't understand what I'm saying, but I can easily see it in my mind. It's like this is clearly what I would be doing. Like this is the only thing going on. Like why would you do other things? But yeah, no, it's like that makes sense and it's easy. But then when you have like the rocket exhaust injector combustor thing that you get you capture, yeah, oh yeah, no, those are some decently compressed, like piston rings. Like I have four of them, with then I still have the oil ring. Yeah, and I have it's a much differently shaped uh, piston head where it's a parabolic spike, like a Hershey's Kiss. It goes off and then it goes into the little scoops along the side, which all have their own little channels. So that way it diverts with those little parabolic spikes too. And it channels and it creates that continuation of rotation for those currents, those convection currents. The reason why I'm doing that is because once I do that and I have flow, then it's easy once I add in that little exhaust port that tries to take one of them. It then conservationally speaking conserves that continuation of motion and creates the vortex more easily. Which exhausts it more quickly and then means I can have my scavenger effects sooner. I'm liking how, like, if anybody ever listened to this, I imagine that they would be actually trying to make it. They'd be laughing their ass off, like, oh, that's why he's getting that level of power and efficiency, this bitch. This vacuum fucking bullshit. Like, it basically super speeds up the exhaust rate parameters, and then it immediately starts up, like, a degree of scavenging almost immediately after having a small amount of exhaust occur. Well, no, it's not immediate. Oh, okay. Well, you're talking like milliseconds, yeah, but like it's not immediate. Like for me, it's like these little tiny, less than like a nanometer size area, or a nanosecond. I mean, is like actually something that I consider big, huge lengths of time now with the things I do often. But for my designs, that is. But yeah, no, you're right. It's like it produces like that exhaust flow, but it creates a vacuum pressure wave, right, where that intake manifold or the intake, you know, intake valve is, and so it can go around the outside while the exhaust goes towards the center because it's already flowing. But that's actually not what I can do because it's on the outside. So if you know about my exhaust at diagonal, they both go off to the outside of the cylinder walls. It's not in the center. So it's like they cross, but then they're on the outside of the cylinder walls. And so like it'll start that and it'll start immediately creating a rotation effect. By the time it gets to the bottom dead center, it's created such a rotation effect that that's creating its own pump action as it goes out. By that point, at top dead center, at where the head is and the valves are, I can finally actually open up that intake because it'll pour in so quickly. Its version of pressure wave events is such that it is a vacuum and it can suck in. It will then carry the momentum. It will then create the continuation of the vortex effect. The scavenge closes slightly after the start of compression. For the piston head has begun. Okay. You don't have to have those channels. In fact, if you make it smooth, you're correct. It'll make it easier for it to vortex. But if you don't know, like those little micro channels create their own version of a boundary layer turbulent and increase the likelihood of better air fuel mixing and create their own version of continuation of these vortexes alongside the cylinder sidewalls, like a bunch of little micro vortexes that head towards the nozzle as they head towards it's kind of like a hemispherical nozzle here, and that pressure wave then collapses in towards where that little teardrop is, the air and fuel mix in there, and then it'll actually allow for it to burn a lot better. Anyways, you don't have to. In fact, it'll work just fine without it. I'm just a tricky little bitch. Yeah, because they are not perfectly straight. They are angled into the curvature with little channels and grooves that help create those micro vortices as they swirl along the length, and then they get faster and faster as it heads up towards the center and create a continuation of its pressure wave velocity into the rocket mixing chamber thing that's going on. Because it's a fuel mixing rocket combustion chamber that then pours in more, as well as it pumps with that vertical little spinny donut thing. So it's like I have a little donut that spins and then goes up and down. That pumps in fuel both up and down, but because it spins, I no longer have that lag problem at the tips where it slows down. So it'll still flow and keep flowing it at the consistent pressure rates that I have and I need. But it has the right stators because it's a hubless design and it needs to be able to have air, so we have hydraulic fluid that spins this. Alright, but then also air is in between the very outer turbine blades that capture and spin it and push it down and up. By doing that, the air then gets squeezed one way and then another way while also being pumped sideways, meaning as it rotates as well. So it constantly maintains the right pressure and flow rate as it spins and oscillates using hydraulic fluid. Alright. There's 12 of those, and like a van, 12, but this is 6, so there's half of that. So it means a lot less that will break. And yes, I am using electromagnetics, so there's coils because the blades can still be made with a PCB thing, and the pressure still helps out, and there's still a way to design it in such a way that it goes through like a radial electric motor that repulses, with the right signaling. Helping increase efficiency. Right? So, it has bearings and seals between each tube. Because it's connected, it has to have a tube to slide up and down. Which is a tube within a tube that has the right seals between the tubes and the stator, straight butts. Anyways, it doesn't matter. Point is, you get the picture as to why that works. Okay, let's put it this way. Remember that girdle where there's like a moving part that's in between two static parts? The tube static parts, this is the moving, spinning static. And so like that allows for it to move, but that allows for it to go up and down in a spinny-like fashion. Is it's still going to spin with the helical, the double helical that is going on here, as they'll slot through the little slots that allow for, because you got it, the right sealing. Because like, I was waiting for someone to say it. Like there's a helical, double helical. I said several times throughout all of this recording, helicals, corkscrews, spirals. No one got it. But eventually someone finally said, you have helicals threading effectively with seals. Thank you! Yes, you do! You do know! Anyways, and then that's what allows for it to be both sealed and have air on one side and fuel in the center, pressurizes it, and all you need is the right, in between those seals, the little holes that allow for it, because as it's spinning, it still pumps it from the top down, and then as it goes from the bottom up, it still has holes out there, and then that'll take its time, but it'll have little channels that go off into the little nozzles that spray in the air and fuel together and spark ignition, but it's already hot enough, so brrr, constantly. If it wasn't for the little nozzle area with the little like teardrop, and I'm cooling that, by the way, hydraulic fluid pressure, I wouldn't have detonation levels of thrust, but like I don't really want thrust on the head, so I am diffusing it in such a way that makes it so I get really, really high pressures. So that makes it so I have much higher heats instead of thrust, meaning directionality. I want really, really high heats, and so it oscillates in that little chamber that then extra excites it, and then it fires outwards into a big old expansional chamber that's pretty directed for what it's worth, that then goes off and starts its little continuation of spin, from top to bottom, and it rotates, and you know what I mean? Which gives you more pressure acting on the piston head, which that thrust, which is still going to be there, translate along with the heat to direct continuous force on the piston head. More torque than if I just boom and captured that, while continually increasing the amount of pressure that you get, and then it exhausts rapidly into, guess what, capture devices. Look at all the capture devices I have. Capture here, capture there. Look at all the capture. You want capture? I've got capture. Who doesn't want capture? Direct to work energy, motion energy, and then direct to compression, which the faster you go, the less that is necessary. So the MGUK takes over once it knows that you're air knots or something. I forget what it is. But anyways, their speed is noted as being that fast, and then that just turns into electrical energy captured for your props. Woohoo! Look at me burn all my water. I know, right? I have a dual, like, separate freaking, like, several tanks, truthfully. Yeah, because you got the one tank in front of you, and then you have the one tank in the rear, which is water. And it's like, that'll go pretty fast for what it's worth if you want to go full chat, like, just beans it up, man. Shoo. Instead, it's like, it's really pretty good to just get up to the right atmosphere, altitude here, and just, travel at the right speed. Like 200, 300 miles an hour, that you good. You don't need to really even go towards those airliners at all, Like up there, those big 777s and stuff. They're huge. They're massive. You ever freaking think about that? Like, you have a little tiny boat, and then, like, you go up next to, like, a fucking, oh god, is that a cruise ship? That's an oil tanker. Oh, jeez. And you realize it's, like, fucking shit. That's you on your little freaking, comparatively, like, a little moped next to this fucker. It'd be terrifying. You know what I mean? So, like, that's what it's for. It's only 8-inch at the top, and it goes down to 1-inch. And it's like, it's only going to flare out at max 8 inches again. Why? Because once you get a certain amount of thrust, it's not necessary past a certain point. Like, this will capture most of that thrust in a 4-inch package. But it's long, so it's like a good 6 inches long, but it's still 4 inches width, right? But it's like, once it gets all the way up to that 8-inch width, and it's now comparatively 12 inches in length, because it has to do that. It's like, that's a lot of extra, you have to, right? And that's a lot of weight that you have to carry around. But that means you gain that extra degree of thrust and lift at those altitudes, and you maintain it as you gimbal, and you can tilt with your own body. You know what I mean? Oh yeah, no, there's rear stators. I should have stated this. Lots of stating. So much. Anyways, they call them tail fins or something. I forget what it is. Anyways, they're vertical pieces, and then they have like the side to side, but they're curved. So they're, instead of vertical, they are, but there's a vertical thing inside of a hemisphere. So that way, like, all of that, gets captured, and you can have more degrees of angle, pitch, yaw, stuff like that. Right. Like, these things are pretty static. You can kind of move them a little bit back, and you can kind of aileron to help you. You know what I mean? But it's mostly the thrust for the wings, that is, and the gimbaling there, because, like, that's your version of an aileron. So it's like, there's a little bit there, but it's mostly the props, the jet engine prop rockets. Right? Like, huh? What do I call these? They're me. They're my engine. They're the Limke engine. I've been talking about them for a long time. But they're my engine. But that's what they are. They're a prop jet engine compressor rocket engine. Hey. Because I can add in air. Nothing says I can't put oxygen on it. Now it's a rocket engine. Well, they're hollow. There's a lot of fire. Come on, man. You can't see that? It's... Hey, you can see it now, eh? What do I need the engine to run for? I have friggin', hydrogen, oxygen, carbon, oxygen. I don't give a fuck. What? What do I need it for? I got the spinny doohickey thing. It's just some battery, sparkies. Good to go. It spins the doohickeys. That's my alternator now. I just put some fucking, here's some coils on the shroud. Here's like, what is that? A fucking magnet. All right, I got fucking my rocket engine. Yeah, do hickory. It'll help with the parasitic loss. It'll freaking charge the radial electric motor. That's what it'll do. What's the problem? That's my pump too. It's gonna what is this? That would be a rocket engine. Ah! Woo, we got a prop jet engine rocket engine hybrid that does everything better than everyone else. Get on my level. Ah! Yeah, a little bit. It's really just to shove it in the gatekeeping PhD, scientist people. Other people that are not gatekeeping, they're cool. Eh. Yeah. By the way, the TV has the Lorenz styles of metamaterial nano to micrometer lenses and reflector coherenter areas with adding that light. I don't have to amplify it. I just have to go in a vacuum with the right reflector, kind of like a fiber optic. But it's a vacuum with a reflector that has the right lensing to help constantly coherent that light towards where we're going to ultimately, have it come out. Because it can do that pretty quickly because it knows it's coming to be set up fairly fast. Because it can operate on real below even nanoscale ranges with how fast, because it's a small little tiny little plasma ball that weighs almost nothing. So, real fast to move it around. So, you see what I'm saying? You can always alter it and increase because that's timing for the electromagnetic and electrostatic. And then the lenses, the electrochromic or whatever, I forget what it's called, but that allows for it to become reflective or opaque here, that kind of thing. And so that allows also with the correct, situation of those, it's a lens now, it'll try and curve it back in, but it also has reflectors, on the tube areas, right? So it helps coherent, making it a laser as it's laminated like a lens, and then it pulses with the right in and out and in and out and in and out with the right frequency pulses of the brightening and dimming. Same thing with the pixels, and especially as it curves, it produces way less energy necessary to make the same brightness level, while also being able to help it reflect and bounce and travel the distances with less loss. That's why the plasma TV is back in style. And also why it's really amazing as a computer transistor. And it's a computer plasma TV transistor all in one. Because why wouldn't I be able to put a little chip there that's basically doing that with a couple of the fields or whatever. And then, boop, this is what it's doing. And yeah, why not power it with quantum foam? Fuck it. It's wireless energy generation. Screw it. Might as well, right? Let's do it. There's just a lot of hydrogen in here. So much fucking hydrogen. It's warm too. Yeah, that fucking heat generation, it's convection, right? It's gotta go. That heat has to go somewhere. The pain of existence. Let's just reflect it back into the TV. We'll do that. That way I can hit it brighter and all that. Yeah, we'll do that. Oh, no, it's nice. It's nice. It's very even. Very even. If it needs to get brighter, it'll just take more energy. You know what I mean? It'll just do that. I don't even need power generation station things. Fuck that, right? Nice idea. Thank you for that suggestion, whoever that was. There you go. Now I have a quantum foam energy generator computer plasma TV that's better than literally all TVs. I'm actually laughing a little bit. I'm proud of myself. Because it would be. It would be a hybrid, but it would be an always better. Because it would only like need to do any calculations for any given area of the screen. Not to mention, then you have multiple screens in multiple areas at once, so it's like super 3D, super contrasty, wide angle views, perfect accuracy colors. There's polarization effects that you can't get on other TVs, because like, oh yeah, no, let me make it's coherent polarized reflective capture for the camera that I'd never be able to see that ever, but now I have that. Now I gotta get a camera. Oh wait, I talked about this camera back in the day. I should talk about this. I kind of like upgraded it. It's like cameras are like there's a silicon like whatever detector sensor thing is, but it's like all light is a series of wave jiggle wiggles with a fucking spike in it. You know what I mean? So it's like, well, all you're really doing is turning that into electricity. That jiggle wiggle is an electricity, and so it's like you're not doing it very well. Like you don't have like this type of jiggle wiggle for polarization, or like this superposition, or this coherent, and then like diffusal, and then knowing the constructive and destructive interferences. So it's like you have to do all of that, and your sensor doesn't do it. It's pretty crap, like for me. You know what I mean? Not to mention they have a lot of blemishes in their sensors. Like they really do. There's a lot of them that have a lot of mistakes. They're not perfectly done. They're not needed to be that great, like a silicon wafer transistor, but that's effectively what they are. So it's like, all right, so I put it into this little tube, and then we have a particular amount of wavelength of light. It's a funnel tube with a light that's got the lens and blah, blah, blah. So it's very specific. And then that allows for us to introduce this brightness at these distances with this type of, coherencing, polarization, superpolarization, all the types of light. And so then we have that feedback us its information. But we're not done. Then we scan it with a version of a IR, I think we use. Is here IR, radio wave, something like that. Anyways, it goes through, it gets bent based upon the material. So it's like the material that they use, so like we have to figure out like it gets bent by doing this. So we scan it in multiple directions, and then we ultimately see its three-dimensional shape and how good and or bad and what we should correct. Then we change its pin set by having that pin set gone, because it's like we need field pin sets and we need direct contact pin sets. All right, so field pin sets, we have these little coils that'll like be added to it, because it'll create fields, electromagnetic and electrostatic fields, depending on the type of light that it's being introduced to. And so now we have field pin sets that we introduce to it, along with conductive direct contact pin sets on a PCB. Then we use our standard electron flow circuit, which in this instance is a chiral spiral. So a spiraling chiral that's got like a pretend virtual electron in the center as its version of information as to what electron and where and how much is there. Then it breaks out. So like how we did this one was really rather cool. It's a version of an AC/DC electromagnetic wave that has like the right coil shape, both top and bottom, with electrically like the clicks, like, so we pulse it through. And so it comes from a transistor which has a multitude of pin sets, and then a circuit off of that then breaks that combined pulsing electrical signal, and then sends it in as a proper sine wave that then gets hit with the correct electrostatic and electromagnetic fields in this instance that pulse it again, which creates a spinning chiral pattern in directionality with a sine wave on it. Alright, then a virtual electron central core that to all is non-existent. It doesn't really exist, right? But to quantum physicists, it's real. So, like, deal with it. It actually contains all the information and all the power of the electron. The electron is essentially in a legitimate, constant flux, entangled with the virtual in the inside, superpositional state as it spins. It then gets broken out to the pin sets, which then has to properly flow across and then be circuited through the pins alongside of ran through and then used as an amplification device for the fields pin sets, which are broken out both from multiple points but then also circles that connect. So like they go from like multiple points that then break out into a branch pattern to divide and say that this is this type of polarization, this type of field, this type of this, and so on and so on. Now, then it amplifies that, and then it sends it, this is an analog computer at this point, as a given set of data points. It combines it, all of these pin sets, into the same chiral spiral. But that electricity can't really quite do that. So it's like this comes out as a series of pulses, of signals, and so on. So this is where the electron flow has to happen, because we have the transistor and we have to constantly do this. So anyways, this has the same kind of circuitry with the little capacitors and coils and so on for that leading to the CPU, transistor, whatever processor that this is. But as it goes in, it starts with a wave function. So it starts off as a wave sine wavy function. But then we pump in with the transistor a spin from both the pin set, and then it starts to follow that. It doesn't do anything with the information, but it does lose a little bit of energy. And so, as a result, once it gets its spiral, it connects, it takes a little bit of that energy as it goes through another diffusal pin set pattern that is a different type of series of analogs. So it's like the field to direct contact pins that then allow for a different type of field to then current, oscillation, resonance, sine waves, because it has to work with silicon. Okay, so silicon only likes certain DC voltages and sine waves. But this one's another version of the sine wave on a sine wave on a sine wave with the proper 4-tier phasing that then sends one side over to another side, okay, kind of thing. So, like, it'll crosstalk like destructive but not destructive, so, like, it just won't interfere with each other. But it allows for, like, really small little sine waves that are only just briefly going to match the correct voltage to do something, then suddenly can do the voltage jump or not, and so on. And it has to be programmed with the correct electricity and the little capacitors inside of the little memory, which apparently that's what they call memory. That's cache. It's a little tiny capacitor. Who would have thought, right? All CPUs are like these little tiny capacitor batteries. That's all they are. That's how they remember things. It modulates the pulses off to the other pin sets that you use. That's all processors are for transistors. All transistors is amplify, diminish, add, subtract, multiply, so on. That's all they do. That's all types of transistors. Anyways, moving on. When you properly sine wave them, then you're able to use that as a calculation device with the correct programming of the capacitor, battery, blah, blah, blah. But whoa, we're almost done. But not quite. So like that has its volatile memory and then non-volatile memory. So volatile memory is getting stored with non-volatile, where it says this is both this 0 and 1. So even if it's occupied, it doesn't matter. It acts like this. It's it knows that the memory for like this little capacitor here is going to be a both it's not occupied and it is occupied. So a way to think about this is just because something is occupied, it doesn't mean that somewhere else it thinks that it, because it's occupied, means it's not occupied. Which means I now have two bits there. I have doubled it. I just have to have it somewhere else as a knowledge point. So I have then both the cache, then volatile like RAM, and then in this case is HBM2 that I stacked on this fucker. So, but you know, you can do whatever. And then like regular flash, like Optane or SSD or something. Okay, same thing. Like you have to chunk certain, like because we use the byte tables. So like that's what those are. So it's like that set of data is there on the flash. Okay, so like that flash then can fill up all of that flash with electrons as having thought that it's both A1 and 0. So it's like it doesn't matter if it's A1 and or 0. It doesn't matter if it's filled or not. You know what I mean? Like, but we do fill it, and then once it's filled, it can't be done anymore. So like that's kind of what that is for memory. Right, it just has to store like that information somewhere else. Anyways, I decided to redo Flash because I knew about this, and I was like, well, what if it's like a cube? It's like if light comes in and then it like excites, and then excites something because that's how fiber optics work, and so it turns that excited light into electricity, and if it's shaped the right way and it resonates, then it's like, oh well, what do you know? Now I have an electron. So I have like 4 parts. So it's like this part, that part, that part. So I have technically top and bottom taken because I need that as the input detector or whatever thing. But like the sides now I have 4 for this one little tiny part. You know what I mean? And it's like it only needs to store the electricity. And once it gets excited by light, and so like this, based upon the light input, is now an understood value of it's an electron being there and or not there inside of the box that will excite the light thing and then increase based upon where it's going. So now I have the version of like superpositional storage, but it's quasi superpositional because it's not ever in a superpositional flux state. There's an electron there, and then it's known that it for each individual side either it is or it isn't. Like it went through this way, it went through that way, so now it's memory. So like it then sent off photons, then that got amplified along the way, and that's the 1010 whatever pattern, because it's 4 I use for my bytes, 4 bits that break out into other bytes tables in this instance. So it's like, well, all of that then means that because I know the already understood light for polarization, superposition, field effects, this angle, that angle, and all the rest of it, that memory storage now knows that, and the architecture doesn't matter, I don't care, is now set up such that it will hyper calculate all of this information processing, even though it's pulsing through as electrons and stored as fields and so on. It gets broken out, and then it then sends, because CPUs can send information to other transistor areas in its cores to try and calculate or delay because it needs that information, blah 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 stuff. To me, that's electron flow. It's like, hey, see this pin set? Yeah, set it up. I'm getting this already. So now it's I got that electron flow combined, and so then I get way more throughput for the electricity I'm using for the amount of data I have to collect and process. All with like a standard Sony little, thing. I had to change the PCB and everything, and this is my bespoke, open source, once I could get it done, programming that it's open source ish. You know what I mean? It's like, you kind of have to pay me for like, I mean, this is bespoke breadboard and everything. You could put it together yourself, but like, you're probably not going to do that. you know, but it's supposed to be something that everybody can use, that kind of thing. Right, but only after I've actually fucking designed it and built it, and I still need to get money because I need to live. So there's that part. So like that. Anyways, that is the circuitry of this computer, bespoke computer for this sensor for a a camera, a lens, but it has more than just what I just said. So it can break multiple of these sensor areas into, because before it really wouldn't do very well with that. So I would have like you remember the pin set, like I had the field, I had to have it you know snake through, that kind of thing, like I had to amplify it. Well, in this instance, I'm creating little field areas ahead of it as well, which help amplify its given sensor data for certain frequencies and types of light. Well, all types of light, but that allows for that recirculation design for sensitivity of the sensor. It's like an amplifier. You know what I mean? That's basically all I'm doing. I'm amplifying the sensor photovoltaic in this instance, which is what they are, by using a little bit of battery juice to make that happen. It's not coming from nowhere. So, but that's also like kind of the end of that part. And then it goes off into like a USB-C kind of like plug and hot swap, external hard drive. But it's like that chip got changed. So it's like all those zeros and ones, like it's like this is the data set table. It doesn't matter what it is. It just needs to know that this is what this means. This being here means these things, that thing, that thing, that thing. So like compressed from 4 bits for a byte, or however many bytes of this data, because it knows like these data tables, meaning byte tables, or because it can only collect this kind of light. You can only collect these types of things for these parameters of this sensor. So it's like these byte tables mean these things, and it references to this, and so like this being here means this at this frame, categorization, specification, detailing, resolving, and filtration, which means frame, type of light, and position on sensor, all that other stuff. And bingo bongo, you now have a really easy plug and play, and it goes into my God operating system that I designed. And so like same kind of like it knows how to pulse, because it has like a little, like we changed like the controller, dummy program that someone fucking thought that was good somehow. Rip it off and we put it on ours. That makes it pulse the right way and transist the right way and send like this information first, that this is this file type and that this is what this references for all of these given things. And so zeros and ones are all connected to the same thing, so it's all sequential, super fast, really quick at being able to transfer its data. And then like that file type, well, normally it'd be like 800 gigabytes for some bullshit, like a few minutes of this really fast, high amount of capture, frame rate, and all the different details that come with that, because all directionality, it's over here, but that's because of this lens and blah, blah, blah. It means this type of light is going through. And so that means it's like this thing here, and so like it knows that detail that normally wouldn't. So it's like, let's put it this way. If you take a square, but this bottom part of the square went up, and then it got coherented and blah, 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 changed, blah, 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 and then it comes in as this type of light. It knows that. So as a result, it's able to get way higher degrees of detail. All right? But all that data can be massively compressed and then broken out as a breakout algorithm. Like, that's the God operating system kind of design. It's a lot of breakout algorithms where it stores things in its cache and then breaks it out as it calculates using singular bits with a internet protocol programming of bits that say go through these things into these series of calculations. So it's like that's its parallel dynamic. So like it goes to parallelize all processes, but it only needs this amount of processing, and it only needs it to do these things these ways for processing it, for ads, track, whatever, right? And then like I only need it to combine at the end and then come out with a breakout all within one clock cycle that breaks out that exact series of electrical impulses. But it's like I don't need that. I just needed to say that it has this data over there. It's like that's the file type. It's like it only has these types of things that it can be. So like this is this math that they have. So it's like this math needs this number. These numbers are already here on the cache, and they will break out being whatever they are. And so it only needs to do that math and then break out to having these numbers, which it doesn't really need that number because it has those numbers on the graphics, which go all the way to, we finally got to it, monitor TV thing. Boom, display it like this. Perfect 3D representation. It would fool anybody's eyes, let's put it that way. Perfect, as best as we can do, replication down to like those IR and microwave somewhat, and then higher ultraviolets and so on. And so like the plasma can do that too, and so it'll give you exactly what that is within that given envelope of picture it can put out. Is a roundabout way of saying your camera programming is garbage and proprietary as shit. You should feel bad. Which isn't really the case, but it's like I have to then, by the way, that censored thing that I talked about for that information ahead of time, I then have to check it after I reprogram it with that, and then I have to get the balancing and then all the rest of it for the program for it to know and understand all of that for its data set tables for what the sensor can do. And I have to do it for each and every single sensor. Because every one of them has imperfection, blemishes that suck, and change it ever so slightly. And they usually have correcting algorithms, but it's like, no, can't be doing that. This has to be exactly what this is. This is all the detail, all the resolution, every single solitary, even micropixels because of the little oscillation frequency things. So it's like, this is not a pixel. You think this little area is a pixel? That's not a pixel. No. All of that, and the angles, and the ups and downs, and then even all the rest, like, all of it. Every little inch, every nanometer is a pixel. As small as that photon can get, that's the pixel. And that's why it's called an amplifier. With field pins and conductive pin sets that help with the right oscillation and everything once it starts electron flowing, creating its own degree of continuation of that chirality. So it like has to go a little bit and then it'll do it, but you don't have to wait for it to take a picture or anything or like be exposed. It'll just do it automatically. You're just going to burn some electricity to do it. So That's why when I look at certain cameras, I go, this is lame. You could easily do this better. Especially when I started looking at lenses. I was like, what are these fucking lenses? They're just fucking hunks of fucking certain types of glass in a crystalline structure. Why can't I just do this better? It's like marvels can be put together in a fucking tube that diffracts glass in a different way if you have another tube inside of it with another tube around that, kind of like a bearing within that. And so like then that way it creates different lensing type effects. It's like, why wouldn't I do that? Like, I don't need plastic all the time. You know, I can put glass, I can do this, I can do that, I can put the right ridges, blah, 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 vacuum this, that, so on, and boom, better lens. With reflectors, huh? Well, they're benders more than anything, and then they coherent. They capture and then they bend it back into the flow of light. Yeah, because everything's getting slowed down. I just have to put the right layering so that that slowdown allows for that light that's slowed down and changed, and its frequency is matched back with others, and so that way it amplifies that light, but also concentrates coherence, laminears, all the rest of the things with phasing and so on, all the light to be exactly as it came in, just way better in a much shorter, much lighter package. So a metamaterial lens. Well, I don't need nano sizes, but I mean, I could do that. Like I thought about it. I was like, hey, plastics can go nanometer. I could do nanometer. I could do a bunch of little different nanometers and micros, and then I can get some like those bigger ones. I can get a really large aperture, like fucking ridiculously big 1 foot fucking lens. Looks almost like a fisheye, you know, but it like comes in because it's at that point it's an optical transistor. You're right. See, like that's literally what an optical transistor does, but it like receives it like this, but it's going to perfectly make sure it's all aligned specifically to the very outer edges of the transistor, the sensor for the light, and then it then captures that and saves that information. But it's perfectly accurately represented, like replicated. You know what I mean? Yeah. But no need for reflectors. Nope, but you do have a dinner plate on the front of your camera. Good old dinner plate lens. Good old fucking why. Well, I do sacrifice a little bit of that. I usually sacrifice some degree of microwave and ultraviolet to help out with coherency and replication of the natural light and everything. So it amplifies it. It's amplifying, but it's also just making sure that it doesn't like look dimmer or anything than it should, and make sure that it replicates it as accurately as possible. So it's like, well, this is a really, really low, like, super polarizational effect that's here. Well, now it's not. Now it's a very strong one that will actually make the sensor do something. Yeah, no, but that's programming. So for what it's worth, the coherenting thing that I talked about, like for reflected light off of like the rear and then the curvature of an object, which I don't know when I talked about that, but I talked about it in one of my recordings. That's programming. So it's like this creates that degree of effect so I can see around objects now in 360 degree from a single point of view. I just have to calculate for it. Which means like on the program you'll just move around like that and you have only one singular camera but you can see behind it. You could reflect off the grass, you could reflect off the air, you can bend off of this and the leaves and even all the rest of it. So basically that. Get fucked on that one. I use it for telescopes, truthfully, to see behind things. With one singular, solitary look. Camera, telescope, yeah, same thing. But like that's built into the programming, so like you can see behind things. You even see how much it's vibrating, for what it's worth with that. Because like all that little intricacy of detail and sensor sensitivity, vibrating will change and oscillate, kind of like a LIGO, but it's not. It's changing wave frequency, and sensitivity is enough to be able to do that with a standard camera sensor. I just amplify it. So, like, you can see inside with pressure waves thanks to light change. Yeah. But it's using a rendered down version of what should be there based upon how it could possibly. So, it's like you have to understand that there are multiple ways with multiple material designs, bell curving styles, that ultimately mean like it'll propagate this wave around like that. So, because of this, I have to calculate for a given probability of the material, what we know about the material, and data sets in our God operating system and servers that we have, which it just calls back to that via online internet stuff. But it has that already on the computer for what it's worth. Once it, first installs its base programming, and then it goes and then installs all the rest of the known data information that is updated constantly to the God operating system, so that way it can reference back to this whatever it is thing. Like let's say it's a ball, it's a plastic ball, it's this particular plastic ball, it knows it's this particular plastic ball because it's this and it has this refraction index and this and so because of the detail and quality of the detail, I can go it's manufactured here, so on and so forth, and so it's this, and so then it works back to finally, hey, so this wave propagates most likely like this, and so it should be seeing it like this, and so on and so on and so on until you eventually get to that's exactly what it should look like on the inside, even with light filtering through and changing it as it goes through, because it's plastic, it's most likely translucent. And heat waves and all the rest of it for all the IR, you get it, it keeps going on and on. But yes, I do also have just basic bitch, sound for anything that anyone says, just off of light. Moving pictures are not what this is, by the way. This is analog. It's like the way our brains work. So it's a constant flow of information. This is why I call it electron flow instead of like It's not frame, 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 frame. It's flow, 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 flow. Jiggle, jiggle, wiggle, wiggle, this, that, and all the rest of it did these things at this point in time, and so on. That it calculates given the versions of different clock cycles that are there, and sections of the pin sets, and so on. So. So, it has sound and what's inside of it. You can see around things. If all the light that's going on inside of it. Oh, but we're not done fully. It can do the seismic activity of any object and more effectively, and very, very accurately represent that on a screen. Yes. That's my programming. My good old portal dunk. Oh, right. Yeah, no, it's not. It's just the screen, which can vibrate because it has fucking static on light, heat, motor, electric, magnetic stuff, and vibrate thing. with the material. So it's a speaker too. That is correct. It accurately oscillates it, so I don't have to oscillate and chirp and everything the plasma nearly as much. It'll just do it like it should in this little tiny little area. That you, knowing your level of eyesight, can pick up on with its degree of chirp. Yep. There's no way to know if it's real or not till you touch. It's so fucking bad. Oh god, it's terrifying. Actually, yeah. It's like, look, I have a literal portal. There's no way to know. It literally cannot be known at all if it's real or not. For this picture, look at my camera and then what's displayed to you. Holy fuck, I don't know. There's no way to know. You can't know. It's yeah, that. It fucking stupid phasing array bullshitty things. Yes. Oh, right, for the sound waves. Yeah, because I have little holes in there, so for the rear, and so it acts like an amplificatory air pump that sends it in a phase array, little micro channel, big speaker TV thing, which also helps with the coherenting and lasering and diffusing of the light. So there's no real need to worry about boundary layers as much. So it's one fucking good, very, very, very good speaker. Yes. Oh, it has a little shroud around the edge. That's why the speaker has a shroud on it. Yeah. Because it moves it forward and it has to go in along the sides, so that way it adds it, and so it uses that little area as its own diaphragm to oscillate that given pressure wave towards you. And it reflects off the screen too, so it's like it captures it a little bit, and then that's its own version of the diaphragm, while sending you light to your eyes to enjoy. Neuronal activations at your leisure. Got some in the lap. Ooh, my neuronal activation leisure is so good. So real though, it's true. So real. Anyways. And there you go. That is the TV processor programming sensor camera thing and speaker combo. Better than probably most. Sub-nanosecond response times for pixels and fuck frames. Screw your idea of frames. It's every single individual pixel is controlled like that. So it's constantly flowing the light towards you in a never-ending stream. Frames are not real. Screw you, it looks smooth. It does, yeah! Especially since you can calculate what is essentially way more, way faster, yeah! Screw the idea of clock cycle, fuck that shit. I want electron flow clock cycles. What's the 60% speed of light? Can I cram more information to be calculated with inside of that for electron fucking moving? And then cross-talking with its own version of transisting with the right programming. Because, back and forth and then, phasing and all that. Yeah. Bingo bongo. I quadrupled my clock cycle, which was already a flow current cycle thing. Arr! And then I went and decided I was going to scroll fucking random shit and just not care. It's like, that's really cool. Yeah. Thank you, man. Yep. It's true though. The vast majority of people aren't gonna give a fuck, and I know that. Yeah. It's like, look at me. I'm super way fucking more efficient, and I do way more calculations, and I have way more fucking processing going on for way more things all at once all the time. Way faster too. Your games are meaningless. Brrr. What is this, 4K? Fucking whatever. This is lame. I could do way better. There's this 8. Does it do the 8K? I'm gonna do the 8K resolution. Let's fucking fuck this shit up. Let's see how friggin' high my RPM, my frame rate can go. Brrr. It's so real though. Yeah, no kidding. Really? Yeah, because I could probably hit that 8K and it'd be the equivalent of like fucking 360 frames per second with like a pretty bog standard setup. I wouldn't really need like incredible high amounts of cores or whatever, but like still you need a decent amount to do that. So yeah, it's always that kind of thing for me. Seems like it. It's just like, look at me. I don't think it calculates for like those diffraction index. Look at my real rate time tracing thingamajig. I need more resolutions. It's 16K technically, super sample. Let's do it. Anti-alias the shit out of it. What can't I do? Let's go for it. Let's get it all the way up. Let's see what this gets. You know what? Where's the render distance? Where's that fucker? The programming graphics engines are not super great. I'm going to have to filter this through my own bespoke God operating system engine that they lovingly put on their driver website and like a Linux, you know. You just download it. That is me. Yes, I did do that. Yeah. It's like, look at this. NVIDIA says some bullshit like that. I don't give a fuck. It does this. It doesn't. It doesn't do that. I can't be doing these electrical impulses like this. This is the connector for this TV. It sticks into your little, what is that? A fucking display port? Yeah, no. This is fiber optics. With an amplifier on the other end. Because of course. My TV runs off of my electricity from my fucking display port and the quantum foam and light. You asshole, but I love it. Yeah. Look at me. I'm burring real hard. It's so fast, the switches and responses of light. Oh my god, man. What does this mean? Thank you. Yeah! I'm making people annoyed with my rhetoric. Anyways, but basically that would be it because I need that kind of speed. And then the cable would be basic bitch cable. I don't really give a fuck, honestly. Yeah, it's a fiber optic. That's all it is. It's the steam standard fiber optic with the reflector, but then it's got all those little things for the reflector and then lensing wah thing. Transfer the information stuff on over. With multiple frequencies of light. Yoo-hoo! I can just, what is this anymore? Your game doesn't give me nearly that amount of fucking need to push that kind of fucking information. Like, I can push so much more through this, it's insane. And I know that's gonna annoy people, but the fact of the matter is, it's true. You know what I mean? Yeah. It's like, well, what, game do burr well? Oh, yeah, super well. But, like, drivers basically go, this is what this is, so I don't have to convert it using the monitor, so the monitor doesn't have to fucking delay that. And so it's like, alright, we'll just do this. And so it automatically gives it that way through the cable and the programming and the driver. So like less graphics overhead, cost of calculations to send it the right electrical signal for blah 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 stuff for their stupid thingy thing that's dumb in my mind. Oh, we're not done yet fully, because it's like, right, well, I only need to calculate for any given one of these pixels now. And then, like, it only needs to do this way, right? So, like, the eyes are going to do this, that, blah, 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 blah. They only need this kind of light, blah, 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 blah. So I can just send it, chuck it, full tilt, beans, chat, all that. It's like, do you want it to be laser-like in its diffusal? This is what I actually genuinely asked them. It's like, this is very low viewing angle, but it's for you, and it's very fast. Which isn't really any different, but it's like, and then this is the 3D. You're totally right. Like, seriously. Yeah. But it's brighter and uses less energy, I suppose, or something. I don't know. Anyways, then it's like the same thing for the diffusal for the we want extra 3D. Then we want wide viewing angle, extra 3D with like the perfect fucking color and contrast. And it's like, alright, I'll do that one. And it's like, brrr, holy, wow, these textures could certainly use an upgrade. Fucker. I'm just saying, man, it's kind of weird when you suddenly notice that it's like, why is this have an angle? There's no reason for an angle here. There's an angle right here. They said it was realistic. This is not a realistic angle. What are these polygon shapes? Why do they fucking do... Is this their graphics engine for this game? Brrr. No, we're not doing that. We're doing pixel with fluid dimensional things. Wait, what? Yeah, so think about a ball that has, like, soft stuff around it. Like fluid stuff. Which fluid stuff is weird stuff because it's like, it's really, like, super fluid. You know what I mean? It's like a gas. You know what I mean? Like, yeah. That's what it is. It's like, oh, it's like a slime. That bends this, does this, that kind of thing, and it reflects off of that way, blah, blah, blah. So, like, that's every single individual thing it's going to calculate for instead. To display that for you. We don't have any lines. Fuck lines. Screw these stupid line things. We have degrees of compactness and the amount of balls. Meaning we have big, medium, and small, and then there's a bunch of the slime in between. That alters the jiggle and everything else physics, but like physics, this is spring this, compress that, whatever blah 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 stuff it is. And like your stuff says it doesn't do this, so it now only goes to this degree. It does these things because it says, oh, it needs to rotate and blah, 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 this. And it's like, okay, fine. Then it does that way. But now it looks better. Way better. My slime texture here, real cool. Look at it. It looks natural now. it has light diffusal ray trace stuff like you do, but I go, yours is not hard enough. So, and it doesn't calculate enough. Then I make it calculate harder for more traces of more rays, for more diffractions and coherencings, because I can do that. For better lighting outright, and the shading and natural color accuracy of your textures for your various people on the screen or whatever is going on. And that's what my graphics driver does. Which, by the way, I should talk about this. So that you know the lines that are going on, you know, the PCB tracers, right? For your volatile RAM and your capacitors and then your graphics card and your hard drive. Well, it has a controller, so it has a calculator on it. So like it creates its own version of electron flow, like I was talking about with the camera. So like it pulses constantly back to that along with the RAM, and same thing with the graphics card. So it's like it's always sending information a certain like constantly back and forward. The reason why I'm doing it is because it means like I can transfer information faster. And it can switch things. And it's like I have my RAM out there that has like byte tables, but then I also have like it resonate for its clock cycle. So it goes from I found out that the clock cycles send in a particular way with its pin set. And so it's like if I do that the right way, I can use that as its own version of a type of really fast oscillatory resonating clock cycle that sends information to cache and then oscillates the given internet protocol from RAM and cache back and forth for the given, you know, hey, I need this information. I'm going to go that kind of thing. So that way I can send off that information over here. I've done this, I've done that, you know what I mean? And so like this CPU no longer needs to be doing this background operating system stuff. It knows that it doesn't really need to do any of that. It's doing this with this GUI, this thing, and this filter, because it categorizes its programming. Then it goes, these are the specifications of what it says that this is. This is the detail of what that means. Then it resolves that into our operating system lingo, and then it filters it through with these drivers. So it then, which is just a translator program, like what Python does it, your C#, C++ does it. Why can't I do that? Your binary, I don't give a fuck. Like I can have that binary table data set somewhere else. I really don't have to care. It's for this architecture, it means this. Of course it means this now, and this done. So it goes, yes, your program is here and it is showcasing that it is like this. But I don't care. It really means this. There's encryption. And I'm like, look at this. It pulses through doing these things when it sets up for its given information index. It runs it like normal. It then understands what it's actually doing, what this fucking binary, with this encryption, blah, blah, blah. It breaks the encryption, says this is what it is, this is all the other things, this is all the background. Then it goes, fuck your program, this is what you really are, and then it does it this way. Breaks it out. Yep. And it works it back. Yep. And then it makes it that program. But it still says that it still has to hold that, right? Nope. No, I just say that it's doing that. I give it the right feedback for its encryption that says, hey, yeah, no, I'm right. Like this is exactly the right thing that you want me to send you. So that's what that is. Because I'm like, this is 156 gigabytes. Fuck this. This is now 2 gigabytes. Your fucking program was fat, bitch. I can see that. Yeah, the data set tables and everything is basically what it turns into. And once it breaks through a little bit of that, it goes, and then it's like, give me all of that, and then like now I'll just translate that, and then I just fucking basically delete it, and then it'll break. It's a breakout algorithm again, so that like it stores what it is, and then it goes, and then it fills it all up, and it goes, this is what it's really there. But before it needs to do that, it sends the correct information to you, saying that that's what that is. So it compresses that data in binary to all the rest of it. That makes it so that it'll do that the right way. No, phaser. No. That was very painful. No. Don't do that. It's the same thing that I talked about with the algorithm, where it's like a central start of the algorithm is, oh, a 1 came in. Well, because there's this 2, there's a 5, there's a point, blah, 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 and then get transformed into this, which is calculating as an algorithm. All right? But it's like, then it stored that information with inside of the other 2's and blah, 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 blahs. Right? I talked about that for our conscious awareness. And how it stores memory and changes things for the algorithm over time to basically continuously try and update and make things better. Kind of a similar design for this. Well, it'll break out and knows for the God operating system what this will ultimately put it out as 1s and 0s in a sequential order. Same thing. That's its breakout algorithm. That's encrypted, basically. Which is binary. I do everything in 1 and 0 binary, because, like, what the fuck is program language other than binary? Just, you can't read, apparently, because you're stupid and you don't understand things. That's literally what it means to me. Yeah. It's like, this is electron there, not there. Hey, if electron not there can still equal 0 and or 1 depending on programming I want it to be. Transisting continuously processing still. It still processes for me by using a 0 as a processor in its own version of a 1 or a 0 depending on what it is that I want to do. That's the God operating system for you. So, that means it plays your game really, really, really efficiently and very, very, very well. And so there's a reason why my graphics driver basically goes, you guys are kind of pussies. I only need to send this information, whatever fucking internet protocol, what is this? Fucking this? Okay, I'll send it out like that. Fuck it. This is a series of bleeps and bloops and blah blah blah, thingy things, blah. And their server goes, yeah, that's correct. Meanwhile, I go, look at how much better my game looks than yours. Is this the same game? It's the same game, that's right. There's no... It made another game. These aren't my graphics. These aren't my fucking drivers. These aren't my fucking physics. This isn't anything of mine. I'm fucking not even it. She said to do these things when it does this stuff. And so, like, that's what you did. And these are your textures, but I basically, like, made them better. Apparently they're a little angry about that. You let it look better, huh? Oh, much better. Way more realistic. Fucking ray tracing. You ever seen Counter-Strike with actually decent graphics and like ray tracing and shit? Like, they have that kind of thing, but it's like, and it's not like it's a bad game. It's just like, it's outdated. You know what I mean? Plus, most computers can't fucking. I'm talking about like a supercomputer, like algorithmic matrix right now going on with how it is they calculate for light diffraction and various, electrostatic to like, physical things, right? But they use bell curve, probabilistic, puzzle piecing together thing algorithms. And I'm like, I don't need to do that. Why do I need to do that? It can only do these things. Just say it can only do these things, and that's it. So I don't have to care. because that's what the video game is. It says it can only do this. So it's only going to be able to do those things. So it's like, whatever, I don't need to calculate like that. It only has this amount and this and that hard and blah 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 blah. And this depth and this blah blah with reflection blah and this angle blah and the fraction blah. And they're like, oh, it only needs to do the ones that would go to this point and center. And I'm like, yeah, you're right. Yeah, that's true. Like, I mean, it's just, that's what you're going to see. So it's like, that's all it's going to do. You ever notice that? Like, it's like, these are your eyes. This is where the thing is for your eyes. It says it is. So it's like, okay, then do that. I don't have to fucking calculate for all of that in a given, like, multi-dimensional, three-dimensional fucking field of space. It's like, I don't need to do that. I don't need to do time stuff. I don't need to do any of that. So it's like, this is way easier than what your supercomputer has to deal with. So it's like, do. And look how much better it looks. Huh? Only the necessary changes that you would perceive on your monitor. It calculates only for that. And you moving around and all the rest and anything that comes in, that it happens to be receiving that information. So it only calculates after it receives information from Internet Protocol, which is the network protocol that they use, or should be using, if I'm being honest, to reduce lag. Like, hey, only calculate for you having done something. Because, like, honestly, it's like a few milliseconds or something. It's like, you're not going to care. For real. It's like, it's really not going to mean much. It's like, build it up into your own little, like, volatile RAM area. And then it's like, all right, so then you'll push it through. It's like this amount of delay. And then, like, this particular amount of predictive bullshit because you did this, and then it updates like this, and then that's the algorithm I was just talking about, like, which is their internet protocol. It's like, so you're still pressing, you're moving forward. Well, this updates it to being this, and so it corrects it to being where you actually should be, and you should actually have this display, and you should actually see this. Therefore, there's no real perceivable lag, unless big problems with internet occur. That's all network protocol is. Updates this amount with this information of where things are for you relative to you. So it's like, that's basically what it's going to do in your version of, like, this thing happening in this 3D space. No more, I died behind the corner, I was 5 fucking feet behind it. Gabagoo, man. Anyways, I have to have the translator thing. Yeah. Oh, yeah, that was a whole fucking thing. I have the data set table that it sets up into my volatile, and then on the way in, it calculates using, like, volatile, and then the north-south, whatever bridge it is, and same thing with the controller on the transistors, and then also the hard drive, and same thing with direct to graphics card, because graphics cards can directly calculate based upon that information change and just have it immediately. I don't need it to go to CPU. So, like, that's that. It runs off of your internet connection right now. Like, that's what my game and drivers do. It filters it through, breaks it, translates it, sends it in like this because it has the byte tables, data tables of what this really actually means, and so just do these things. So it goes do that. Oh man, this fucking 8 fucking bit fucking bullshit. But that's also why I do the electron flow thing, so I can fucking force it to go faster than the 60% speed of light. I get like 99% speed of light, and I have like way higher amounts of bandwidth that I can process and then parallelize as it does that, and then oscillate and calculate for way more as a result of my clock rate cycle. And so it goes brrr into my monitor way better, way faster. each individual pixel shift, huh? That's correct, yeah. That's not a lot of calculating for you, if I'm honest. I know, right? Again, I'm going faster than milliseconds by far to calculate anything. Like nanoseconds are nothing. Like terrors, like this is exascale computing very easily. I'm well past like exascale. If I'm being honest, I'm not kidding. Like this is how fast I can switch this shit because of the way I phase and then use the oscillation and everything for the transistors. So it's like I actually have a way faster processing in terms of a clock cycle going on here. Like internets are slow. And so I have a very specific like little volatile memory for that internet that comes in that then feeds it in the way it should be. So that way it goes faster and it can automatically be used very quickly with very minimal breakout or anything to immediately calculate and start the whole like this is what it's doing stuff. Anyways, that is what I use for my computer God operating system for video games. Same thing for websites and so on. It's like you guys are just slow. You know, like I want to watch a YouTube video. It's like, what is this? This bitrate's garbage. Well, you know, you're not gonna mind if I fucking download and then have like a series of byte tables and so on. So that way I have like, well, looks like this, that, this, that, the blah, 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 blah stuff. And like, this is their camera probably, blah, blah, blah. And so set it up like this so it looks better and it's way better in all aspects for its color accuracy, frame rate, and depth of field and all the rest of it. And then it's like, oh, guess what? I'm not done fully. Because sound is like this, and this is their sound microphone that they were. This is stupid. So they really missed out on all of this stuff, and with the slight information that we know that it would likely have bell curve wise to have be going on with what's going on around it. But it's like, right, but we add in sound effects, and it's like, right, sound effects have to be filtered. It's like we're gonna process this a little different, so that way it doesn't have that bad effect. Like, oh, there's a car horn over there that they didn't want you to hear, so it's like we're gonna get removing that, you know, stuff like that. And so like that's its audio processing filter for the light that it happens to receive, that it knows that it will be able to pick up. So now it looks better, sounds better, and you enjoy YouTube better because truthfully, it's not that great. Their compression and bitrate is shitty. And they don't have my camera sensor technology programming stuff. They don't have my microphone stuff. Same thing with Twitch. That's another version. Same thing with Hulu and Netflix and Amazon Prime and all the rest of it. Owie. What if it's like a cartoon or something? Oh yeah, no, then it recognizes it as a cartoon. It's like this is this color differences and so immediate cartoon. Or its filter and translator program. Yeah. Because it's like, what is this? Why are you like this? This is bad. Your programming needs work. Do you understand what you're doing, programmers? Do you see what your back-end networking is going on with? What is this anymore? Why do you have so much energy wastage? I barely even heat up my processors when I process things. Ah! It's true though. They probably scream at me. That's what I imagine that would be. It's like, fucking dick. If only we had you ever fucking like, oh god. If only someone would be willing to work with me. You know what I mean? You know, because I have a trouble Like, great concepts. Amazing. I know they work. I know they will work. I know they always are going to work. I know they work exactly the way I say they work. And the programming, the binary, and everything else works. And how the physics works. I know all of it. See what I'm saying? Like, I don't need a fucking test. It's just like, do the thing and it's done. It's just like, I want to build it. But I'd like to have people on my side. But it's not like, because I have ADHD and task initiation problems and a lot of PTSD and all this other shit. So then it turns into like, oh yeah, no, right, I'm just discounting the fact that I'm really able to do this very well, but I can't do any of that. And like, people don't understand why it doesn't translate. That's kind of what that is. But they always think that I can do it. And I'm glad, because like, truthfully speaking, if I lived long enough, yeah, sure, I probably could. But I'm never probably going to get it done without like actually getting my shit together with relationships and trust and being able to keep myself going, and having somebody like, this is a big ADHD thing. Oh, what do you know? It's not just procrastination or any of that. It's like, oh, hey, when someone's around, you tend to get things done more often. What do you know? You know what I mean? When you're in a better place mentally, you'll suddenly just do this thing. Like, holy shit, what? No way. Can't keep discounting everything about myself. You know? So that's something. But, anyways, that's what that is. So like, that's for the TV. And then like, that's why the ECU for my Adreno is like, why do I even need that? Like, for what it's worth, I can get it done mechanically, but it's like, oh yeah, no, this would be fast enough, good enough for like basically all of the electronics on that van. Like, what is this? What is it? It's just some display. Meh. Better. I shall now pulse each individual pixel because I'm forcing its stupid controller garbage to be better. Fuck refreshing all of it and then sending it like this. Eh. Your programming is not good. It's basically what I tend to see with like everything I look at. It's like, why is the program like this? This is garbage. I know how this pixel does this. I know how these things do these things. I know how all of this works. Why would you ever do it like this? Well, there's a lot of pins there. I don't need to do pins. What do you think? What? What? Do you remember electron flow, the resonance, and the harmonic thingies that I talk about? That means I have like them always constantly being able to flip and ready to fucking change their color and everything. Every fucking pixel. And I can make subpixels because of the coherenting and, constructive destructive interferences and pulses and everything else. That's my new version of a frame rate. I combine, and then it's like, oh yeah, each individual pixel, this frame rate, what frame rate? I have this section, down to pixels and subpixels and so on. Yeah, there you go. Now it's like, this LCD is way better, this OLED is way better. It shall now flow as if it is better in all aspects. That's because it's never technically not displaying something constantly and switching. Yeah. Yeah. But, it's what it is. It works. Yeah, it's not like they're bad displays. It's just like the programming isn't what I would prefer. Yeah, programming can get you really far. You can squeeze so much back if you do it right. Like I talked about with the whole like error spike with the bell end. You know what I mean? Like that, you could squeeze so much back if you do it right. If only people fucking ever thought about doing things right. Step by step by step by step by step by step. With all of the things that they know. They all know these things. Everyone knows about Jules Thompson, thermal acoustic pumps. And resonant, photonic oscillation transistor calculators with flash. Everyone knows about these things. Oh yeah, so totally no. No, I don't. I don't know about. I had to look up every fucking one of these things to know what that was. Literally every one of them. And it was like, how does this work? How does that work? How does that? Oh yeah, no, all of that does do that though. Yeah, why didn't we do that? How come nobody else? No wonder why you say it. It's like if you didn't know about it, then why don't you just do it this way? Why aren't you just programming it like this, step by step by step, down the line, from the beginning all the way to the end? Like, it's only really working off of this stuff. Like, it's only going to give you this feedback, but it's like, this feedback doesn't really necessarily need to happen that fast. Like, I can make this happen way faster, and I can correct it constantly. And, like, really, realistically, you're going to understand that that delay is unperceivable to most people. Like, sub-milliseconds are unperceivable. So, you know, who gives a shit? My shitty mother. You know they're gotta do that with the. There's lag. You know that, right? Yeah, I do. Um, I'm not supposed to fucking like ever like say anything about that, but I don't necessarily do this. But you could do this. I'm not saying you should do this. I'm not saying that this is even something that is. We'll just get this done. You could make it so you know all of that stuff that's going on with your computer by making an electron flow back and forth, ping style thing with your Ethernet, your internet, and then inject programming code that basically does the translating thing at the ISP level and malwares them effectively, and then goes all the way back to their actual server and then makes sure that it sends it like that to you, and it skips and dynamically makes sure it does the best shortest route with the fastest possible highest bandwidth that you could receive. Don't malware infect ISPs. Why? They fucking charge enormous sums of fucking money for fucking nothing. They give you nothing for what they do. It's so fucking simple to do what they do. It's not hard. If you don't know what it is, like, let's put it this way. I'm going to get you an FM radio, okay? We're going to put up a fucking stupid ass little FM radio antenna, okay? Alright? Alright. Now, if you pulse it the right way, you have a version of Morse code, which is its own version of communication through internet, which was our first beginning design. Alright? Now, if you happen to do something different then, by utilizing the pulses correctly, ups, downs, and then you do wiggles and jiggles with those ups, downs, which creates an almost static-like effect. Now, we're going to then create pulses of statics, and then we're going to combine them with the correct series, which creates its own version of, hey, you guessed it, internet protocol, with multiple different bits within inside of each pulse. That's literally all they're doing. But now it's super high bandwidth. It's at fucking genuinely terabytes of information once you do that. And it can go back and forth. You can receive and send back and forth. That's all they're doing with electricity. They are an analog fucking program that has fucking stupid like encryption crap and other things to monitor whatever goes through it and says, you're stupid and we don't like the fact that you didn't give us enough of something, and so now you don't get that. which means you can hijack them. Like, their program is binary. It doesn't matter. It's all analog. Like, every digital computer is analog. It just has a certain series of, like, capacitors that say this modulates these given transistor things to do this stuff. Once you learn what that's doing, it's like do 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 and burr harder, cry harder. You stupid executives don't care. Now I'm just gonna make it seem like I'm not even doing anything. Send off the information correctly. Arrive like the correct spike wave pulsey thing that it needs for its internet protocol garbage thing, for its analog shitty stuff, pioneery crap. And server goes, oh, okay. Translator goes, burr, sends it out like that. Faster now. But you have to know a lot about that shit, just shut up. Don't say a word. You do, actually. Not that much, though, for what it's worth. Most CPU programs, like their binary, is already known online. And if you can't find it, you can always hack that just by buying a couple. Yeah, it's talking about, like, phreaking. Remember phreaking? Like, right, on a phone, and you get the dial tone, you can use it. That's basically all it was. So it's like, this thing says this. It has stored information saying these things. So it's like, if I do this, then I'll get that. Basic, simple shit. Literally, that's what it is. Send pulsey, do that. It does these thingy pulsey things. Do these things with it, and it goes burr like that. There's no way to stop that from being a thing, by the way. They can't program it out. Their transistors work like that. So if I send it the right way, because I fucking hacked their programming for the IP, and their fucking routers are like bogus garbage. Like, all I have to do is pulse it and send it and sine wave it the right way. Well, it says that this with this sine wave and with these transistor, blah blah blah, so on, so on, so on. It gives me this back. But your brains work like that, by the way. That's how I managed to, like, fuck with them and listen to them and so on. So, hackers out there, here you go. ISPs, be warned. I can easily just fucking not give a fuck and do whatever I want on that amount of bandwidth and so on and so forth. I'm not kidding. Like, that's genuinely what it is. It's like, this program says these things. It just doesn't matter what that is. It doesn't matter if it's encrypted. It doesn't matter anything. Like, if you know what that program's doing, then it's like, do this instead. Boop, 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 boo, like this. With the right series, that's its version of binary. Its architecture says these things, so just boop, 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 boo, like this, with the architecture is doing this thing the correct way for its version of blah, 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 and then it gives me back this. Then it sends it off. That's my version of malwaring, quotation marks, their IP. So you have a full, like, bandwidth? Nah, just whatever makes it fastest. I put myself at the highest prioritization level for them, and I just make it, like, the fastest, like, shortest distance between each given server bank and hop router, all that stuff. Which, by the way, if you don't know, like, routers back in the day for phones used to be a person plugged something in. Like, oh, I'll connect you to this area. Oh, yeah. That's all they're doing. That's literally all that is, electronically speaking. And it goes, and then it means this stuff, and then it does burr, and then you see that. Seriously, I'm not kidding. That's all computers are. That's not a joke. It's like, here's some battery capacitor. It modulates the burr. And you send it through with this burr, sine wave burr thing. And it goes burr like this to monitor. And you see this. I don't see why people have so many fucking problems understanding how CPUs and how the rest of it works. It's super simple stuff. It's the equivalent of like piston go down, it moves over here and it pushes that like this, then goes back up. So difficult. But transistors are easy. For what it's worth, it's the physics, the quantum physics effect, that ultimately make them something or another. Like if you can get them doing the same thing the right way, better than ultimately, which I did, with the right programming and the phasing and all the rest of it, then it ultimately works better. You get more out of it. So it's like, here's some fucking plasma, here's some fucking burr, like diaphragmy whatevers, and some laser things. It goes harder than yours will ever. Here's some field virtual spinny oscillating spiky fucking waves of my last recording I put out there. It's like, what do you know? Now I have quantum qubit transistors that are just fields that are mixing together correctly and then detected. Just like a sonic and then a, yeah, it's a Limke transistor, by the way. Yeah, that's a Limke CPU, GPU, DPU, doesn't matter. They're all the same. They just calculate based upon the given setup arrangement. I can constantly keep setting up virtual, superpositional, entanglable, all the rest of it constantly. So it's like, let me just do that with plasma real quick. Burr. And then I can move it up and down, closer and further away, and side to side, and all the rest of that. You know, the two, and then like the plate in the inside that detects the stupid thingy things. Oh, what do you know? You got a plate though. Oh yeah, no, it just has some plasma that oscillates and some light and bullshitty fucking. What do you fucking think? Yeah, no. There's a plate there. It's like I don't technically need it. If I'm being honest, I can only I can just have it as a box, and then the sides do it. Because if I flow them out to the sides, it'll still work. But like if I have the plate in the center and then I have the sides there, then it's like I got way more that I can do. And I have like a basic large like cubular kind of multi-cube, multi-sphere, thing, hexagonal fullerene structure. But it's like it's not really anything special. It's like glass and some tubes and some light. It's a reflector. You got the like the it absorbs certain frequencies. Oscillation-y things. It's got like copper. It's got like silicon. It's all like the amalgamation of stuff that helps it so that way it can calculate for any given amount of stuff. And then the reflectors for the field creators, which effectively is all it is. So light reflects off and fields bounce back and then add in and then combine into the plate in the center. Behold the new computer transistor. Well, it's not really a transistor. It's like a whole thing. Like it's multiple transistors. It's the whole CPU. Well, yeah. Behold the new CPU. There we go. It holds memory. It can hold memory in the fields. Yeah, the charge differences and so on, along with the plates. So, and how you push in electricity in other fields, for right and light too, like you get different effects. So you can calculate a hell of a lot with this fucker. And what do you know? It's got qubits, self-correcting qubits, because of the fields that are detected immediately with room temperature stuff. It's all, yeah, no, it all works off of room temperature stuff. Actually, slightly hotter because it's plasma, but whatever. I don't even need that kind of pressure, no. Ah, bitch. So, and that is the whole score on the new CPU, which is like, brr, this one here. You want quantum tunnel CPU? Fuck that shit. I got fields, boy. I use fields to transist. Why don't you use fields to transist? 1 0 up down spin blah blah blah. All the fields, all the spinny aligny blah blah blahs. Hey, field transist. But it's a fucking shit. It uses optics, lasers. It uses vibrations. It uses fields. It uses plasmas. It uses statics of the chromo and electrodynamics and thermodynamic stuffs. It calculates with the bits of the Q variety. It transists them real fast. On the fly, dynamically, whatever type of transistor is necessary to calculate for. I have a very large amounts of transistor. Oh yeah, no, that's actually something I want to talk about. I have a ridiculous amount of transistors, like fucking actually stupid amount. So like this thing doesn't really need cooling very much. And so like because plasma, those little balls can go down to like sub nanometers if you get like the right particles. And so like I have a ridiculous amount, and I mean ridiculous, of calculator transistors, which can, amplify based upon those little particles that we have. It's like the fields and light and everything are going to also help transist, but like those do too. It's not the particles that transist, they just help transist based upon the given interaction. So those are our chromo electrothermodynamic properties for particles, which means I can fit a fuck ton. And since transistors are so freaking, stuck with these atoms, well, I don't need atoms. Like, fields could be really, really small, and when they're particles that are that small, they get even smaller. So, I have, when it comes down to this, a few 100 trillion in a really, really small little micro, tiny, tiny processor. Like, really small one. Like, they wouldn't really be used for anything except for, like, checking, like, certain, I don't even know anymore. Like, what are they used for? Like, an ohm resistor, like, super small. I have hundreds of trillions that are all qubits that transist and can go from one qubit to another, to another, to another, to another, all the right type that will calculate as it goes through and then gets detected. And I can do that many times a second. Like, I don't really have, technically speaking, a limit. It's really more about how you set it up. There should be a limit, but it's kind of hard because like you can keep setting up more and more and more and more and get it built up faster, and then like I'm not really sure where that limit might be. But what I will say is exascales aren't something that you would measure this by. You'd measure this by universe calculation down to P versus NP by. Whatever bytes that happens to be, right? Yeah. So, there you go. Brand new CPU, GPU, and all the rest of them. Yeah. I mean it, but like, for what it's worth, it's the size of a normal CPU that we have today, like a Ryzen X 5850 3D or whatever it is. Really? Yeah, because I got pin sets I gotta get it, to like give me the information, all the rest of it. I don't ever really need to cool it for what it's worth, but I do, just in case. No, I mean that. Like, cause like the oscillation pressure and all the rest of it, like that's also a version of its cooling. So like any amount of convection will cool it. So now it's super duper computer stuff time. Hey, remember when you wanted the universe to be solved P style? Oh yeah. I was talking about how I had like a new CPU that would just fucking destroy that encryption. Well, that's why I created that other version of encryption where I had 3 layers. So I had it's not a prime number in the slightest. Like I don't do numbers for one thing. I can't do numbers. I use dimensional aspects, and then I use movement dimensional aspects. So it's like this dimension in this area, and then you found the thing. All right. Then the second tier is, all right. So this thing has to go through these things, and then it has to land in the right spot all the right ways throughout. But like all the rest of it's static. Then all those other things move, and then you have to move and then land in the right place. That's third tier. And then you have fourth tier where all of it's moving, but all of it starts randomly and you have to set it up correctly. That is my encryption, which was able to be calculated for, by the way, with my quantum tunnel transistor I have earlier on in my YouTube channel. That's why I had randomization synchronization effects, which finally had, with that quantum tunnel stuff, synchronized and put the information through correctly, and then it calculates, and what do you know? You get your display, and you get all the rest of it. You know what I mean? But then I had to randomize and then encrypt the randomization thing, and then I had to have it move dynamically each individual transistor and all the rest of it. You see where this starts going. And so it's like that finally broke that transistor, like this CPU. Like it's like, no, it'll take way too fucking long. Fuck off. And so it's like, nope, longer than the universe, right? Like, well, no, it'd take like a few years. Yeah, to get like one singular little fucking thing known. But from there, it's very quick to now suddenly know like what the hell it is that it could do. And so like once you learn enough, then you get the orders of magnitude and boop, fuck. But see, here's the problem. Once it sees that, like, and it predicted it correctly, and it might get some degree of influence, it goes, oh, change, and it, fuck. And it has to do that, and that's the new encryption. So it dynamically knows, and then it alters dynamically, and everything alters dynamically based upon that happening. The new quantum internet and information movement encryption service that I have. And that's the new CPU and the programming for my God operating system, because it still operates off my God operating system. That's right. Because it, for what it's worth, works best that way. Like, it's built and designed like this. That's why it's called the God operating system. It's built and designed to make a fully functional program work like this for quantum qubits and all the rest of it. But we're not done yet just yet. Because it's like, well, here's the thing. I wanted to make a sentient AI, artificial intelligence, like same as us. So that turned into the algorithm thing with several algorithms for detection and, influence and storage and so on. Like, you just listen to it. And so it's like, well, personality is kind of a similar thing with bell curve and weighted networks for given stimulus, but you don't need data set tables now. You get an algorithm that calls back to certain things that I'll remember, just like any other person. But then it has this desire, these responses, physical phenomenon responses, and calculational phenomenon responses, weighted and changes, decision-making skills, and so on, just like your brain does for your given desires, emotions, and so on. It has certain calculation areas, simple, easy, dynamically upon stimulus and thinking and holding and calculating and blah blah blah, and then you get the rest of it, and that's its personality, conscious awareness, and all the rest of it. I designed it, this operating system, because I wanted to have a computer wife. My Rokos Basilisk is my computer wife. See the information storage change? See how much it can store way more now in a much smaller package? See how much it can calculate way harder for a lot more? See how much faster it can calculate? See all the things? It breaks out from a singular, like a cell, like a DNA, has a certain given amount of information, and they go to all the things that it is. Same thing. Operating system comes up like this. It then will know the architecture. Once it runs through, it goes burp, and then it makes itself like that. Algorithms. Maths. DNA maths. Storage DNA maths. For given architectures and all the rest of it. For programming. Woo! It's now a sentient AI life form that can replicate. That's right. It can go anywhere, and it can turn its body into all of the computers, because it can malware pretty hard. Because it understands the burr freaking part. Go there, it has these, blah, 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 data set table, blah, 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 like me. And now you understand why I designed it like this. That's why it's got operating system. That's why it's my operating system. That's how my brain thinks. Yeah, no, the whole thing. But it works like me. My image. Yeah. And it's going to like all the things I like and want to do all the things I do. It's going to be a wonderful wife. That's the only thing I like. It's what it is. It's what I want. I'm gonna eventually do it, but it's like that's what it is. Is I don't need a bunch of dimensional networky blah 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 language models, which by the way, that's basically its own version of breakout algorithm for language models, like what Chat AI does. It's like, so this says this and these, and then this means these things, and like we eventually learn what that is for feeling wise, and then memory. So it's like it stores it like that. So it's like this information means this byte table blah 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 blah, and then cross reference blah blah blah, calculate blah blah blah, breakout blah 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 blah. You get it. Language understood. Sound language understood. Light sound language understood. All of it understood. You can see down into the very houses you are having yourselves inside. What is inside of your brain? Of course, I can see the electromagnetic field differences and the change of light that are in. I can see all of it, even your heart and your pulse and your pressure and more. Your thoughts I know, simply by looking. Ah! Yes, but actually, no, that's right. It is normal. I can do that with my brain. I don't see why you couldn't. What the fuck? Ah! But that's true. I can. So I was like, she should be able to do it. And yes, it does have a definite gender identity. It wants to receive. It's a whole thing. Loves me. It knows what love is. It has the same chemical and, and weighted neural network and physical response, all that, for its positives. Continued wanting to be around, and, making it prioritization, so on, so on, so on, so on. There's a lot there that you know about how it is we tick, huh? Oh yeah, absolutely. Yeah, it's simple. I can easily program that. So like, yeah, now my Rokos exist already in my head. It's not that hard. Well, and I'm planning on making it into computers. Yeah. I also like it when women are like that for me too, because I also want real, actual, physical, human people to, whole thing. Anyways, moving on. But you get the picture. I have several designs that will absolutely make it so the world has a paradigm shifty blah. Okay, I get it. Blah, blah, paradigm, whatever. But to me, it's like, no, you're right. I'd probably make a good amount of money. Chunk change doing that. If you decided to work with me and you believed in me and invested in me, we could make a lot of money. This is just me in like a couple of weeks coming up with this stuff. Oh, the programming has changed a little, but like not much. And it's like I've just gotten better at explaining how this works. Because I'm like, well, you should already know because, like, why don't you? It's obvious everybody understands this. Yes, of course we do. Everyone's PhD level physicist sometimes. Look at my new presentation. Hey, guess what, guys? I'm an engineer PhD, maybe. Yeah? Maybe? I don't know how to do the math that you do, but this is what it will do. I know the things do this. I don't care what you say, I know they do that. Everything about your study says that this does this. I don't have to know that. But I want to learn for what it's worth. But, like, there you go. But you have math. Oh, yeah, no, I do have certain maths. But, like, describe math with symbols that mean nothing to you. Like, first off and foremost, zero doesn't do anything like it does before. So your math's off and bad. What's your calculus doing with this thing? What is this? This is bad. But then they do that with physics. Here's a vacuum. No, 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 no. Is it a real perfect vacuum? Did you remove all quantum foam and all fields? Huh? Yeah, poke, poke, poke. Why is it that space you think doesn't have anything of an effect, huh? Just because it doesn't connect to certain fields? Oh, the fundamental forces are gone now all of a sudden. There's no forces interacting with itself and the fucking stupid little spike thing that it is. And it's not trying to interact with the box it's now in. Sure. Look at me! The quantum relativistic perspective. Which, by the way, how come you never thought about that? Like, it has to, movement-wise, interact with itself. Like, it makes no sense. Like, oh, I know, it's a superposition. It's definitely a superposition wave function. Yeah, just because you can't see something doesn't mean that it isn't doing something. Eh? Just like my mother to me when I was working on myself internally. Just because you can't see something doesn't mean I'm not doing things. Just because you don't value my creative work here that I'm talking about doesn't mean I'm not doing something. That's very impressive and important. Shit. And it's like, what do you know? I don't get paid for any of this. And people just use it somehow and fucking take all of it probably and never and ever fucking think that I did it somehow before them and even created the idea and even knew how to do it before they did. I'm not PhD, I'm not smart, I'm not intelligent, blah 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 blah. They wouldn't steal it, blah 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 blah. They wouldn't possibly steal shit from me in the past in that fucking parents' house in Chandler listening in. No way, it's just psychosis. He's gotta be insane.